Welcome to this Python course. Now, before we get started with actually doing anything, I just want to talk a little bit about what this course is, who it's for, and what you should expect to achieve by the end of this course. This course is aimed towards beginners who have little or no experience with Python. By the end of this course, you'll be able to start programming with all the essential skills you need to actually build your own projects in Python. And throughout this course, we will also be building a few real-world projects to help you get started with using Python effectively. So in short, this course is going to teach you how to use Python. We're not going to be diving into the obscure parts of the language that's considered much more advanced, but I will give you the skills you need to use Python effectively in the real world. And after this course, you will easily be able to transfer your knowledge into more advanced projects. And Python is a very fun language. So if that sounds like something for you, then let's get started immediately with learning how we can install Python on our computer. The very first step for learning how to program in Python is downloading Python itself. So what we're going to do is go to a website called python.org, and this is the official website to download Python. Once you get here, what you want to do next is go to the download section. And what you should see here is your operating system followed by the latest Python version. During the time of this recording, it's going to be Python 3.12.1. But for you, it might be 3.13 or 3.14. What's important is that you download the latest Python version. Now, whether you're using Python 3.13 or 3.14, the contents of this course are going to remain the same. Anyway, let's tap on this button and wait for Python to download. Next, you're going to want to double tap on the package that you just installed. On Windows, this might be an XE. Right now, I'm doing this on Mac, so of course it's going to be a package. But you're going to want to double tap on that to start with the installation process. And here we're just going to tap on continue. Here we have some important information and I'm going to tap on continue. Then we have the license, which we must accept. And I'm going to tap on agree here. And then all we have to do is tap on install. And depending on your computer, it might ask you to insert your password. But once you have Python installed, you should end up with a package such as this one. It's going to contain an idle and it's going to contain some other files. Now, to actually verify that you've installed Python, I recommend tapping on this idle, and right away we can test it out by using some Python code such as print, and inside some quotation marks we're going to type in hello Bob. And if you get hello Bob back, it means that you've configured Python correctly. Anyway, that concludes the first step of installing Python. In the next video, we're going to be looking at how we can install PyCharm, which is a very powerful code editor which helps us code in Python much more easily. Previously, we learned how we could install Python on our computer. Next, let's learn how we can install that powerful code editor called PyCharm. So first of all, go to some web browser and make your way to jetbrains.com. And I'm going to leave a link in the resources section of this lecture so that you can just tap on that and go to the same page that you see here. You can also Google PyCharm. What's important is that you end up on the JetBrains website because this is the official version of PyCharm. Now, once you get here, what you want to do next is tap on download. And here you're going to see a screen that says PyCharm Professional version. And this is not the one that we're going to be using because JetBrains offers another version called PyCharm Community Edition, which you can find below the Professional Edition. And this website might or might not look different by the time you reach it. What's important is that you search for the Community Edition because that's completely free. And that's what I've been using for the past 4 years for programming in Python. Anyway, tap on download and wait for this to finish downloading. Once it has finished downloading, tap on the installer and go through the installation process. But since I already have this installed, I'm going to skip this step and I'm going to let you go through it by yourself. Anyway, once you open PyCharm for the first time, your screen is probably going to look slightly different to this one. And that's because I have a lot of projects that I've been working on in PyCharm already, but yours is probably going to be empty. But what we should both have is a button somewhere on this screen that says New Project. And if you can't find that button, go to File, wherever your tab bar is, and tap on New Project. Here we'll be able to create our very first project. Now, the first thing I recommend you do is find a folder where you want to store all of your Python projects. For me, I created a folder in my documents called Python projects. And what comes after that is the name of the project. So this can even be Python 2024, and that will be our project name. Below that, we have the Python interpreter, and this is where we need to select the correct Python version so that Python can interpret our code and run it. What's important here is the base interpreter. If it doesn't appear here, you're going to have to search for it manually by tapping on these triple dots. Now, unfortunately, I can't help you with this step because on every computer it differs. But right below that, all we have left is this section here that says create a main.py welcome script. And we're going to keep that selected because it gives us some code to start off with. We're never going to use this code, but it's quite nice if you're getting started with Python. Anyway, once we have that, let's go ahead and tap on create. Now I'm going to make this full screen, and this will be the first script that you will see. But there's a big chance that your PyCharm is not going to look exactly like this one, because I'm probably using a different theme or a different font. So in the next lesson, I'm going to cover everything you need to know about what I'm using in PyCharm so that you can replicate exactly what I'm doing, or so that you can have the exact same theme in case you prefer to use the theme that I'm using. Previously, I told you that I'm going to show you my setup in PyCharm. So let's go over that real quick so that we can get started with coding in Python immediately. Now, first, before anything, I want you to tap on this green arrow over here just to make sure that everything's configured correctly. And what you should see in the console is something that says Hi PyCharm. And that just tells us that we've set up Python with PyCharm correctly. Anyway, I'm going to delete all of this code because we're not going to be using any of that. And the very first thing I'm going to be showing you is how to get this theme. Now, chances are you might already have this theme. The thing is that every couple of years, PyCharm decides to change the default theme. So I'm just going to show you what I have right now in case you want to replicate this, or in case for whatever reason your screen does not look like this. So to do this, we're going to go to settings. And what we want to do is go to new UI. And all you have to do is select both of these. And of course, in appearance, you're going to want to select dark mode. And that's actually all I use as my theme. These are just the defaults that PyCharm gives us. As for the font, you can make your way to the editor, and inside here, you can tap on font, and here you can change your font to whatever you want. Once again, I'm using the default, which is JetBrains Mono, or at least I think that's the default, so in case it isn't, you're more than welcome to use the same font that I'm using. Now, finally, I'm going to show you a couple of shortcuts which I'm going to be using throughout this course, which I find very handy. So next, you want to make your way to the key map, which you can find right above the editor. But in case you can't find anything that I'm trying to show you, you can also search for it in the search bar. So by typing in key map, it will take us to this key map. Now, the first shortcut I'm going to show you is the run shortcut. And this is the one I will be using the most to run the code in my Python scripts. So inside here, you're going to want to go down to the part where you'll see run/debug. And where there's this green arrow over here, double tap on that and add a keyboard shortcut. For my computer, I decided to use Command+R, and for me that just means run or refresh or reload. It's a letter that I can easily remember that's going to allow me to run my script over and over without having to use my mouse. And another shortcut I really recommend you look into is the font size shortcut. So by typing in font, it's going to take you to the active editor where you can decide to include a shortcut for increasing the font size in all editors or decreasing the font size in all the editors. And you also have the option to increase the font size in the current editor or decrease it in the current editor. But really, all I do is use these two because sometimes I will want to increase the font size if it's late at night and my vision's starting to get blurry, or I might want to decrease the font size if I don't have enough space on my computer. So once again, add some keyboard shortcuts for this. My default is Shift Command with the plus, and to decrease it, I'm using Shift Command plus this Italian E. Anyway, once you've selected those shortcuts, you can do something such as print hello. Bob once again. And this is some very basic Python code. Of course, we're going to dive into the whole Python language later, but for now, just to test it out, print hello Bob. Make sure you spell everything correctly so it looks exactly like this, because otherwise the script will not run. But then before you even run the script, test out these shortcuts. Make sure that you can increase the font size and that you can decrease the font size as you please. For most of these lessons, I'm going to have the font size really big because I know you guys are probably going to be on mobile or even on the screen. It's just nice to learn from videos that have a proper font size. And to run the code, we have two options at the moment. We can go all the way up here to this green arrow and tap on it each time we want to run the script, or we can use the shortcut that we've defined in the key map, which for me is Command plus R. When we run it, we will get the message in the console. And if we want to run it again, we just hold Command plus R and it will run the code once again. So you can also change this with a different name, such as Dave. And when we rerun this script, it's going to say hello Dave next time, without us having to go here to this small green arrow each time we want to run the script. But anyway, that covers all the basic setup for getting started in Python and PyCharm. Now let's actually dive into learning the Python language. For the very first lesson, we're going to be talking about syntax. Now, every language in the world follows a set of rules, and Python is no different. If you try to write something that Python cannot understand, Python will not be able to interpret that, and that means that Python will not be able to execute that code. It's a lot like using punctuation in your language. If you use it wrongly, whoever is trying to receive that message will probably misunderstand what you're trying to say, and that can lead to a miscommunication or them not understanding at all. For example, here we're going to write our friendly message that says, hello, Bob, and this is going to work perfectly fine because we respected the rules of the Python syntax. If we were to run this inside the console, we're going to get hello Bob and everything's going to work smoothly. But at any point, if we disrespect the rules by maybe removing one of the parentheses, first, our code editor will probably complain, telling us that we're missing a parentheses. But second, if we try to run this code, we're going to be greeted with a syntax error because we did not respect the syntax that belongs to Python, which requires us to have two parentheses, a starting parentheses and a closing parentheses. And once we fix that, it will run just fine. The same thing goes with quotation marks. If you were to start a quotation mark, you're also going to want to finish that quotation mark, so it actually can contain the text that you want to put inside the parentheses. If we were to just start something like this without finishing it, it's going to consider everything after to be part of the text, and once again, it's going to give us a syntax error. And that just says that we did not respect the rules of the Python language. So syntax error is probably going to be the most common error you will run into when you start learning Python, but later on it will become one of the least common. It's really the same as learning the rules of any language. Once you learn to respect them, it becomes a lot easier to avoid it. Now there's one more thing that's really important in Python, and this is called case sensitivity, which means right now we used a function that came with Python called print. And if we type it like this, it works just fine. But if you were to use an uppercase P, Python considers this to be a completely different thing. So what I mean by case sensitivity is that Python looks at an uppercase P and a lowercase p as two separate entities. So if you accidentally type print with an uppercase T at the end, your code is not going to work. It's going to give you another error. And to fix it, you just need to put it back to lowercase because that's how Python wanted us to type it. But we will cover more about that later. Sometimes in programming, you're going to want to add a little note to your code that reminds you what it does or that reminds you something important regarding it. In general, if you write clean code, you're not going to have to use that many comments. Personally, I recommend you use them sparingly, but if there's ever something that you think you will forget later on, use it. There's nothing worse than forgetting what your code does. Throughout this course, we're going to be using a lot of clean code practices, so you're not going to have to use comments that often, but it's good to know how to use them in case you want to use them. The most common way to use a comment is to use the hash symbol, and after that you can write any text you want. You can say that this greets the user, and this will be ignored by Python. It will not be considered code. Even if you type code inside here, you can say print ciao bello, and that will be ignored by Python because it is considered a comment as long as you have the hash symbol in front of it. Now, something else that's cool about comments is that it allows you to quickly test alternative versions of code without having to run it. For example, you might want to see what it looks like if we were to print this instead of hello Bob. And we can do that by adding a comment and removing a comment without deleting the code, so we don't have to rewrite it later. As you can see, if we were to run it, it's going to say ciao bello. And you can even layer these if that's what you want to do. You can say, check this out, prints a friendly message to the user. And that will just give us some more information regarding this functionality. But once again, I recommend you use these sparingly and only in places that you find quite confusing, because once your project has hundreds of lines of code, adding even a couple of comments is going to make it so much harder to read in the end, because you will have so many lines of code to go through, and comments tend to clutter the space with unnecessary information. All I'm trying to say is, if you have some functionality that says hello to someone, try to avoid typing prints ciao bello, because this is redundant. You don't need that. You can easily see that down here. One of the most important concepts in programming is the concept of reusability. We want our code to be as reusable as possible, and you should always keep that in mind when you're writing code. In this lecture, I'm going to be introducing the concept of variables, which will help us with writing much more reusable code. First, let's write an example that does not use variables. Here we're going to write a print statement that says hello, and we're going to use the plus symbol to add another string to hello. So here we can type in hello Bob with an exclamation mark, and that's going to work just fine. If we were to run this, it's going to say hello Bob. Now we can duplicate this line, and my shortcut for doing this is Command plus D. It might be different on Windows, so make sure to go to the key map if you can't find it, but here I'll hold Command plus D and it's going to duplicate that line. And let's say I also want to say hello to a cat. I saw a cat on a street, I will say hello cat. If we run that, we now have two print statements, hello Bob and hello cat. And that happens because Python executes code one line at a time. So it's always going to start with the first one and then the second one and so on. Then we can even do this one more time by duplicating it, and we can say, hello, Dave. And now we have three print statements. But there's one big problem here, and that is, what if we want to change the greeting? Right now, we type this all in manually, and while it was easy to duplicate, it's not going to be easy to edit. For example, maybe we want to say bye instead of hello. So bye Bob, bye cat, and bye Dave. Here, it only took maybe 3 seconds to change all of them, but this is a very simple example. In larger code bases, or when you start working in much more professional projects, it's never going to be this simple. You might use this greeting in hundreds of places, and you do not want to change them all manually. So instead of writing the greeting manually, we're going to create a variable for it, and we're going to call it greeting. So to create a variable, first you start with the variable name, then you use the equal sign followed by the value that you want to assign to that variable. For example, here we want to say hello, and now we can replace all of these with the greeting. And when we run this, we're going to get the same result using the variable that we have defined. But this time, if we want to change it in all the places, all we need to do is change the value that we assign to that variable. And if we run it once again, you'll see that it will update all of them, and all we had to do is change it in one place. And once again, it's important to mention that Python is case sensitive. So if you were to type greeting with an uppercase G, but you created a variable with a lowercase g, Python is not going to understand what this is. You need to respect the case sensitivity. Also, a few rules to respect when you are creating variable names is first that you cannot start it with a number. You can't add crazy symbols such as an exclamation mark or an ampersand. That doesn't work either. It doesn't matter if it's at the beginning or at the end. The ampersand, the exclamation mark, those symbols do not work. And finally, as we move through this course, there are going to be some reserved keywords that come with Python, such as else or if. These are reserved by Python, so we cannot use them as variable names. But all of this will become self-explanatory as we progress through this course. In the previous lecture, we learned about how we can create variables to promote reusability in our Python scripts. Now it's time to take a moment to learn how we can create constants. And in Python, we don't really have a true way of defining constants. What we do instead is rely on a naming convention that tells other developers that this is a value that should never change throughout the lifespan of our program. For example, the value of pi is a value that never changes. It's always going to be the same, which if I remember correctly is 3.1415. And it goes much longer, of course, but that is the value of pi. It's not something you want to change throughout your program. So what we use as a naming convention for constants in Python is typing the variable name fully in uppercase characters. Another example is if you have a program that has a version number, you're going to want to type in that variable name in uppercase letters to say that this is version 2 and it's not something that you want to change later. But you can treat these as normal variable names, which means that we can print these and use these as normal. We can say version, or we can type in print pi, and that will work just fine. We can also multiply pi by 2 if that's what we want to do, and we will get the double of pi. We can still use it as normal. Now, in other programming languages, if you were to try to change these values, your script would raise an exception, or it would just not work, because the idea behind creating a constant is that that value should never change. You don't want anything to change it. But in Python, unfortunately, we have no true way of defining constants, which means that if some silly person decides to change the value of pi to 4, this will work perfectly fine. As you can see here, if we print pi, we're going to get the value of 4 because we changed it to 4 later on in our script. And once again, Python reads and executes code one line at a time. So first we got this executed, then we got this executed, then we got this empty line executed. And since this was the last line executed before printing pi, we got 4 as the final value for pi. So that was the concept behind constants in Python. In Python, we have many data types, and data types are used to define the type of a value so that Python can perform logical operations with values that are compatible. For example, you can often rely on that adding a number to another number will give you the result of those two numbers. But if you were to add a number to some text, logically that might not make too much sense, so Python will give us an error. And just to demonstrate that, we can print 10 plus hello. These types are incompatible, and you will get a type error if it's incompatible. So that just warns us that we're trying to do something that's not so logical. But something we could do instead is add 10 plus 5.5, and that would give us back 15.5 as a result, because these two types are compatible. A whole number and a decimal number are compatible. Anyway, I'm going to be showing you the most common data types that we will be working with in Python. Starting with the numeric types. The first one is called an integer, and an integer can be considered any whole number. Whether it's positive or negative, having it as a whole number will make it an integer. Next, we have what is called a float, and a float is any decimal number. So if you use this dot in between one number and another to create a decimal, it's going to turn it into a float. And at any moment, if you are confused about the type of a variable, you can either hover over it to get an idea of what it is. Here it says % of type float, or you can also print the type of that variable. And when you run it, it's going to tell you exactly what type that variable is. But moving on, we also have something called an imaginary number. And in Python, to define imaginary numbers, we use J. I've actually never used this in my 4 years of programming with Python, but it's good to know that it exists in case you do need to use it. Moving on, we have Boolean types. And Boolean types represent two states. One is true and one is false. For example, we can have a variable called isConnected and set that to true to show that we do have a connection. Or if we have a variable called hasMoney, we can assign it the value of false to tell whoever is reading this that the person has no money. So these two are the Boolean types. Next, we have string types. And string types are literally just text. So if we were to write hello Bob, this is a string, and most code editors are going to give it some color coding, whether that be green or some other color, to show you that it is a string. And strings can be written in both single quotes and double quotes. Then we have sequence types. And sequence types are literally just containers that contain values in some sort of sequence. For example, we might have something called numbers, and this is going to be what we call a list in Python because it's a list of elements. And here we created a list that contains 4 numbers. So this is one of the most common sequence types that we will be working with. Another sequence type we have is called a tuple. And a tuple looks a lot like a list, except here we use parentheses to define it. In this case, I created some coordinates, and the coordinates are 2.5 and 1.0. The main difference between these two is that with a list, you can add elements, you can remove elements, and you can perform a lot of operations on it. While with a tuple, once you create it. That's all you can do with it. This is what it's going to be. After the sequence types, we have mapping types. And a mapping type looks like this. So here we're going to type users, and we're going to use some curly brackets. And we're going to first provide a key called Mario with the value of 1, and then another key called Luigi with the value of 2. So mapping types use key value pairs, and in this case, what we created here is a dictionary. In Python, this is considered a dictionary, or this is called a dictionary. And finally, we have set types. So first, let's create a set, which will contain the values of 1, 10, 25, and maybe 50. And just like with dictionaries, we use curly brackets to define a set. Except here, we do not use key value pairs, and that's an important difference. Now with sets, we can perform many operations, such as removing elements and adding elements. So sometimes you might want to create a frozen set, and this just disables all of that functionality so you cannot change it. For example, to create a frozen set, use the frozen set method, and then you add 1, 2, and 3, or whatever elements you want. And this will make sure that we cannot modify the set. So those were the most common data types that we will be working with in Python. And don't worry if you don't remember everything from this lesson, because in this section of the course, we're going to be covering each and every single one of these data types in detail so that you can use them comfortably later on in Python. Python is a dynamically typed language, which means we can change the types of our values over the lifetime of our program as we run it. For example, we can create an integer, and we can print that integer, and we can print the type of this integer. And when we run it, it's going to print 10, and the type of our number is going to be of type integer. But let's copy and paste this code directly under and change 10 to some sort of text, such as hello. And this will work perfectly fine. Even if the number was defined as an integer initially, later on when we got to line number 5, we recreated it as a string. So the second time we run this, you'll see that for the second section of the code, it turned into a string. Again, Python interprets each line of code one at a time, which means as long as you perform these operations in the correct order, you will get the expected behavior. But what I'm going to be using throughout the entirety of this course is something that we refer to as type hints or type annotations. Instead of just typing number equals 10, you're going to see me typing in number of type integer equals 10. This is a very good practice to have in Python because you're being incredibly explicit with what you're doing. This is completely optional, but throughout this course, I'll show you the benefits of doing this. One of the immediate benefits is that since we defined number to be of type integer, if we were to try to reassign it to some text later, we're going to get some syntax highlighting because we expected an integer, but instead we assigned a text value to it. So we get an immediate warning that we're doing something silly because maybe someone's reading the code and instead of passing an integer, they decide, okay, I'm going to pass in the string of 10, which is not the correct type for number. So this gives us a warning and the opportunity to fix it early on before we run the program, helping us avoid errors at runtime. And you can type hint any variable you want. If you have some text, you can say it's of type string and that it should be hello. Here we're just informing our code editor that text is supposed to be of type string. So once again, if we do something silly, such as type in 100, we will get a warning before we run our program, because passing in the incorrect type might lead to our code exploding. But I'm going to be going over type hints in much greater detail as we progress through this course. For now, just look at it as a safety mechanism that helps us and other developers understand what we meant to do in our code and to prevent ourselves from writing silly mistakes. And once again, type hints / annotations are only for the developer. Python essentially ignores them completely. As I showed you earlier, if we were to type in number of type string, we would get a warning here. But if we were to run the code, it would run just fine because the operation we did here was compatible. Python does not care whether we pass in an integer or a string. This warning is only for us. And as an example of where this might be useful, here we can type in text of type string equals hello. And if we print the text plus an exclamation mark, this will work perfectly fine. But if the user passes in 10, first, we're going to get this warning. Second, if we run this, we will get an exception because of course we cannot add 10 to an exclamation mark. These are incompatible types. So having this warning ahead of time would actually save us the trouble from having to run the code and see that it doesn't work. If we want this to actually work, we would have to turn it into a string. And at this point, it's going to be of a compatible type. Sometimes when you're typing code in Python, you might not always have it in a nice format. For example, you might be typing super fast and you might put a few spaces between text, and string might also have a few spaces. And even here inside the print statement, you might have a few extra spaces. And to make it really beautiful, I'm also going to put this a few spaces down. Now, if we were to run this code, it would run perfectly fine. And that's because behind the scenes, Python is putting all of this together. So what Python sees is this. But what we see, unfortunately, is the harsh reality of the ugly code that we wrote. So what I'm going to show you is a very useful shortcut that can help us format this into something that's much more readable. As you can see, with a click of a button, I was able to format this into something much more readable. And the shortcut for doing this on my computer is Option Command plus L. But again, if that doesn't work, go straight to the settings and make your way to the key map. And then here, what you need to search for is reformat code. And you can change this to any shortcut you want, or you can see what shortcut it's already set to. Then just tap on OK. And the next time you type in some ugly code with some extra spaces or code that's missing some spaces, all you have to do is select everything with Command or Control plus A and use your combination to fix it. Previously, we learned about all the data types that exist in Python. Now it's time that we dive much deeper into each one of these respectfully, because I didn't really explain anything in the previous lesson. So let's learn how to use each and every one of these data types in Python in much more detail. And to get started, we're going to be learning about the integer data type. And an integer can be seen as any whole number. So here we're going to type in age of type integer is going to equal 30. As you can see, 30 is a whole number. It doesn't have a decimal or anything else. It's a whole number. And in Python, we represent integers using int. Int stands for integer. Another example can be money of type integer is equal to 100. 100 is a whole number. Then maybe we have something called self-esteem of type integer, and that's going to equal -50. So that's also a whole number. Even if it's negative, it's a whole number, so it gets interpreted as an integer. With integers, we can perform practically any mathematical operation. So if we have an integer called a with a value of 5 and an integer called b with a value of 10, we can use both of these to perform some mathematical operations, such as addition. And if we run this, we will get the sum of a plus b. Otherwise, we can also perform subtraction, so a minus b, which will give us -5. And of course, we can do both multiplication and division. So with the asterisk, we can perform multiplication, and with the slash, we can perform division. Now, if we run those two as well, we're going to get two more results. A times b is going to be 50, and a divided by b is going to be 0.5. It's important to note that performing an operation that turns a number into a decimal is going to turn it into a different data type. For example, if we remove all of these and we print the type of a divided by b, this is going to give us 0.5, and that is not an integer. That's what we call a float in Python. But we will be covering floats in the next lesson. In this lesson, we're going to be learning about decimal numbers, or in other words, floats. And to use them is quite simple. It's practically the exact same thing as using an integer, except any number that's considered a decimal is going to be of type float. For example, we might have a constant called pi of type float, and that's going to equal 3.1415. Since we use this decimal, it becomes a float. You might also have something called percent of type float, and that can be 0.50. And actually, the trailing zero is not necessary. This is enough to represent 50%. Or you might have something called height in meters of type float, and that can be 1.72, which is my height. And considering that float is a numeric data type, we can also perform all the same mathematical operations that we did with integers. So here we can create a variable called a, which is of type float, and contains the value of 0.5. Then we can have something called b, and that can be 1.5. Then we can perform all of the mathematical operations that we did with integers. And when we run this, we're going to get the outputs of each one of these. So a plus b will give us 2, a minus b will give us -1, a times b will give us 0.75, and a divided by b will give us 1/3. One thing that's important to note with type annotations is that with floats, you can insert integers such as 10, because this will be seen as 10.0. So these are compatible. On the other hand, if you were to create something of type integer and pass in a float such as 1.5, these are not compatible. So we will get a warning. Even if you type in 1.0, as soon as you turn this into a float, it's not going to be compatible with integer. But integers are compatible with floats because it's easy to turn an integer into a float, but Python cannot easily turn a float into an integer without rounding the number up or down. Now that we know about the two most common numeric data types in Python, it's time to dive into the operators that we can use with them. And the first ones that we're going to cover are the arithmetic operators. So in this example, we're going to create a variable called a with a value of 2 and a variable called b with a value of 4. In the previous two lessons, I already showed you that we can use plus for addition, minus for subtraction, the asterisk for multiplication, and the slash for division. But there are another few that we need to cover that aren't so self-explanatory. The first one being the floor division. And to create a floor division, we use 2 slashes. So here we're going to run this and see what we get. And as an output, we're going to get 0. What floor division does is make sure that we get a whole number back when we divide. For example, to make this easier to understand, we're going to put 4 here and 3 here. So this should give us some sort of weird decimal, such as 1.333, but instead what it's going to give us is 1 back. It's going to cut off that decimal part and just give us 1 back. If we change this to a 5, it's going to round it down. So 3 goes into 5 1.66 times, which again is not a whole number. So this rounds it down. And if we were just to use a normal slash or a normal division operator, it's going to give us this result back. So it can be quite useful to perform floor addition when you don't really care about the decimal. Another operator we should cover is the exponential operator. And to use it, we just need to provide 2 asterisks. So a to the power of b, which is 2 to the power of 4, is going to give us 16 as a result. And finally, we have something called the modulus operator. And what this does is give us back the remainder. For example, if we divide 3 by 2, what we're going to get back is 1. And if we do this with 5, it's going to be the same thing. 2 is going to fit in here 2 times, but it's still going to have a remainder of 1. If you want to make it more interesting, you can change this to 10 and put a 7 here, and we're going to get a remainder of 3 because 7 fits into 10 only once, and that means we're going to have 3 left over. It's important to note that the order of operation still applies and can be altered through the use of parentheses. So if we were to print, let's say, 10 plus 10 times 2, we're going to get 30 back because 10 times 2 is going to go first, and then we're going to add that to 10. If we run that, we're going to get 30. But if we were to wrap 10 plus 10 in parentheses, it's going to add 10 plus 10 first and then multiply it by 2. And finally, while we're here, I'm going to show you how we can use assignment operators. So suppose you have an integer that has a value of 2, and you want to add 2 to x. One thing we can do here is type in x equals x plus 2, and that works perfectly fine. If we were to print x, we should now have 4. As you can see, we have 4 in the console. But we also have some sugar syntax. So we don't really have to write all of this. We can type in plus equals 2, and that will perform the exact same operation as what I showed you earlier. X equals x plus 2. So the next time we run this, we're going to get the exact same result with less code. And you can do this with every operation. So here you can type in minus equals 2, which will give us back 0. Otherwise, we can try divided by equals 2, and that's going to give us 1.0, or even times equals 2, which will give us 4. If you're very daring, you can also use the floor division operator here, or the exponential operator, and we can change this to 3 to make it more interesting, or even the modulus operator, and it will give you the result of each one of those. And again, if you ever get confused, all you need to do is think of it as such. So here we have x equals x modulus 3. All we're doing is moving this in front of the equals and removing x. We take these away and put the modulus operator in front of it. You will probably see this being used very often with the plus, because this is a very basic operation that you might use in many places, where you might just want to add one number to x each time something happens, whether it's a score or you're just keeping track of something else. You might want to add 1 to x each time something happens, so you'll probably see something such as this to perform that operation. Continuing on the subject of operators, up next we have what we call comparison operators. And a comparison operator returns a Boolean based on the result of the comparison. And to keep the theory simple, a comparison would be something such as if you're trying to see if one value is greater than another. So if you're comparing the value of 5 to 1, 5 is going to be greater than 1. So if we tell Python we want to perform that comparison, then Python is going to say, yes, that comparison is true. So let's get started by defining some values. First, we're going to have a of type integer, which will equal 1. Then b, which will equal 5, c, which will equal 10, and d, which will also equal 10. So we have some variables that we can compare here. Now, the first comparison operator I'm going to be showing you is the equality operator. So here we can check, is a equal to b? And to perform this operation, we're using two equal sign. So we're asking Python, is a the same as b? Does it contain the same value? And if we run this, we're going to get false as an output because a is equal to 1 and b is equal to 5. Instead, if we were to put c and d in here, knowing that they are both 10, we're going to get true as an output because c is equal to the value of d. And in most programming languages, you can easily achieve the opposite comparison check by using an exclamation mark instead of a double equals. So the way you should read this is c is not equal to d. And if we were to run that, the output is going to be false because they both contain the exact same value. But if we were going to do this comparison with a and d, we're going to get true because a contains the value of 1 and d contains the value of 10. So that's an easy way to check whether two values are the same or are not the same. But what if we want to check whether a value is greater than or less than another value? Well, in programming, it's quite straightforward. If you ever attended math class, it's going to be very similar to what you would do in math class. So for example, let's check that b is greater than a. And to do that, we use the right arrow. So if we run this, we're going to get true as a result because b is greater than a. We can also switch these around and say that a is greater than b, and the output is going to be false because a, of course, is not greater than b. But what's going to happen if we have two values that are exactly the same? So if we're comparing that c is more than d, what's going to be the output? Well, the output is going to be false because c is not greater than d. They are exactly the same value. But we do have a way of checking whether a value is greater than or equal to another value. And it's written the exact same way as you say it. So is c greater than or equal to d? And the output is going to be true because even if c is not greater than d, c is equal to d. Also, it's worth mentioning that at any point you can also flip the arrow to the left side, and this will ask Python whether c is less than d. So instead of switching the variables around, you can just switch the arrow around. So here we're checking that c is less than or equal to d. And of course, that's going to return true. Or we can also remove the equals and replace this with ab. And we're going to get false because c is not less than b. And finally, the last thing I want to mention is that you can chain these. So maybe you want to check whether a value is more than another value, but less than another value. So to do this, we're going to check that b is more than a, but less than c. So actually we have to do this backwards, and that will check that b is in between these two values. Because right now we're checking that c is more than b, which of course it's true because it's 10. And we're checking that b is more than a, which is also true because a is 1 and 5 is more than 1. And if we run that, we're going to get true as an output. Up next, I'm going to be showing you how you can use logical operators in Python. So we're going to be continuing with the exact same variables from the previous lecture. And the first thing we want to do is chain two comparisons. For example, maybe we want to check that c is equal to d and that b is more than a. And that might not be that easy to chain only using comparison operators. So what we're going to do instead is use something that's much more readable and much easier to understand. So let's try to perform that comparison. Here we're going to print that c is equal to d and b is more than a. So this is the first logical operator that we will be covering. it checks that two expressions both evaluate to true. So both of these must be true for this entire expression to return true. Otherwise, it's going to return false. So if we run this right now, we're going to get true as an output because both of these expressions evaluate to true. At any point, if one of these evaluate to false, such as, let's say C is equal to A, which obviously is false, the whole expression will evaluate to false. So AND just checks that both of them are true. And you can chain this for as long as you wish. You can say AND 5 is equal to 5, if that's what you want. You can add as many ANDs as you want. But let's just remove this for now. And next, we're going to be looking at the OR logical operator. What OR does is check that at least one expression evaluates to true. So now it doesn't matter if C is equal to A evaluates to false, because B is greater than A will return true. So this whole expression is going to return true to us, as you can see in the output. But if both of these return false, the output is going to be false because both of these expressions return false and OR checks that at least one of them is true. So now if we run this, we're going to get false as an output. And finally, the last logical operator I'm going to be showing you is the negation operator. And in Python, we use not to negate anything we're doing or to just reverse that check. For example, here we're going to check that A is not more than B or not greater than B, which, as you can see up here, is the case. A is not greater than B. So if we were to run this, we will get true as an output. Otherwise, we can also check that C is equal to D. So whatever this evaluates to, this is going to check the opposite. As you can see, C is equal to D is true. So with not, we're just checking that C is not equal to D. Now keep in mind that this is a very basic example. I'm just showing you what not does, because in a case like this, you could easily just replace the equals with the exclamation mark, and that will perform the exact same operation. But later on in the course, I'm going to be showing you exactly where we can use not, because it actually has other use cases while following the same rules. Anyway, there are still some operators that we need to cover, but we're going to be covering those later on as we progress through the course. Now that we've covered the numeric data types and a lot of the common operators, let's continue learning about the other data types. Up until now, we've been using a data type that allows us to represent textual data. And you've noticed this when we are printing some text. We use some quotation marks, and by using these quotation marks, we define it to be of a certain data type that represents this text. In Python and many other programming languages, we refer to this as a string. And the reason we call it a string is because it's technically a string of characters. So, for example, A is connected to B, which is connected to C. It becomes a string of characters. Now in Python, if you want to create a string, all you have to do is use some quotation marks, and these can be either single quotation marks or double quotation marks. So for example, here I'm going to add a name of Mario, and I'm going to create a fruit that's called banana. Whether you use double quotation marks or single quotation marks makes no difference to Python. Python does not care about which one you use. So it's really up to you to come up with a preference. I personally love the single quotation marks because it just looks a lot cleaner, and that's what I got used to. But you do have one benefit of using double quotation marks and single quotation marks in certain scenarios. And the scenario I'm talking about is if you want to use one of the quotation marks in the other quotation marks, it's going to be much more rough if you use the wrong outer quotation marks. And that was a very confusing sentence. So what I'm trying to say is that pretend you want the bananas to own something, so you type in bananas with a small quotation mark. This would not be that simple if you were to add this in Mario's, because the string will think you're terminating it here, when in fact you want it to end here. Now to actually make this work with name, we need to add a backslash, and this is known as an escape. And all it's saying is that this quotation mark here is not the end of the string. It should not be interpreted as the closure for this string. So as you can see, if you need to use single quotation marks a lot in your string, you might want to opt in for the double quotation marks, because with double quotation marks, we can add as many singles as we want, while with single quotation marks, we're going to have to escape each and every single one of them if we want this to work. But the same thing also goes for double quotation marks. Maybe you want to insert a quote in your string. For example, you can say quotes, and then you add some double quotation marks and you say, hello there. As you can see, it's not going to interpret this very well, because now it's going to think that here we have a string and here we have a string, but everything in the center is something random. So of course it's confused. What we have to do again is add the backslash here, and then it will work just fine. So that's practically the only thing you need to keep in mind when you're deciding whether you want to use single quotes or double quotes. Now with strings, you also have the opportunity to add them together. For example, here we can add the name to the string that says eats a with some spaces plus the fruit. And when we run this, we're going to get that Mario eats a banana. And what we did here is called string concatenation, which just means we're adding these strings together. So that's one operation we can do with strings. You can also create multi-line strings by using triple quotation marks. For example, you might have a poem of type string, and here we're just going to add triple quotation marks. And by doing this, we have the freedom to write whatever we want on as many lines as we want. And it's going to preserve this order. Now, instead of writing nonsense, I'm going to copy and paste in my poem, which says roses are red, violets aren't orange, I can't find my keys, the end. But watch what happens when we print this. The order is maintained. We get everything inside the string in the correct order. Although you might have noticed we also have an empty space at the top. And that's actually my fault, because I skipped this line up here. The reality of what this should look like is like this, which I find a bit ugly, but as soon as you run this, you'll see it's not going to have that space anymore. And once again, you can also use single quotation marks here, if that's what you want. And it will work exactly the same way. And I'm going to be showing you some very good use cases for multi-line strings as we progress through the course. But for now, all you need to know is that strings are one of the primitive data types that allow us to represent textual data in Python. In this lecture, I'm going to be teaching you the concept of type conversion in Python, because sometimes you're going to have two incompatible data types, but you're going to want to perform an operation with both of them. And the only way to achieve this is through type conversion. So let's create two values. One's going to be a text value of type string, which is going to equal the string of 100. Then we're going to have an integer value, which will be of type integer, and that's going to be 50. Now suppose we want to add both of these. Well, if we were just to type in print text value plus int value, you know very well by now that this is not going to work because they are of incompatible types. You cannot add an integer to a string without converting it to the appropriate data type. So here we actually have two options, and these two options are going to give us completely different results. The first option is converting the text value to an integer. And in Python, it's quite straightforward. If you want to convert something into a data type, all you need to do is wrap it in parentheses and put that data type in front of it. So here we have integer, but we can also choose to turn it into a float, or we can even turn this string into a string, or whatever data type you want. All you need to do is put it in front of the parentheses and insert the value inside the parentheses. So this line of code is going to attempt to convert this string into an integer, which means the next time we run this, we're going to get 150 as an output because it was able to convert this into an integer and perform the appropriate operation with the addition operator. The second option we had here was to convert our integer value into a string. So let's wrap that in parentheses and add string in front of the integer value. Now, once again, they're going to be of compatible types, except this time we're going to get a huge number, which is actually just a string of 150. But here it's going to be 10,050 because we added the string of 50 to 100, which means in reality, what we have now is this string over here. And as I mentioned earlier, some data types will be compatible even if they are different, such as floats and integers. For example, we can type in 5.5 plus 1. These two data types are completely compatible, but one of them is going to cause the other one to implicitly turn into that data type. In this example, we have a float and an integer, so by performing this operation, we're turning this result into a float. And we can easily also print the type of that, so 5.5 plus 1. If we were to run this, we're going to get 6.5, and the result is going to be of type float. One thing I should mention is that if you try to perform a type conversion on a type that's incompatible with the type we're trying to convert it into, Python is going to give us an error. For example, maybe we want to convert the integer of the English word for 10. And obviously this doesn't really convert that well to a number. Python doesn't know that 10 in English means 10 as a number. So what we're going to get is a value error. And that's because this cannot be converted into an integer. So it's important you insert values that are compatible, such as 100 or 5 and so on. It has to be a compatible value for it to actually work. By this point, we've learned enough of Python to create our very first program. So what we're going to be creating is called simple adder, and all it does is add two numbers together. But this time, we're going to allow the user to specify which numbers are going to be added. So first, let's create some nice welcome text, and this one will say, welcome to your simple adder. And we will also format this with some dashes, so it looks quite nice. Next, we're going to be learning about a new built-in function that comes with Python that allows us to actually grab the input from a user. And to do this, we're going to create a variable called a, which will be of type string, and that's going to equal input. And what input takes as an argument is the prompt that we want the user to see when we have to insert a value. So here we can type in enter a value for a. And when we run this, you'll see inside the console that we're going to get the prompt down here to enter a value for a. So we can enter something such as 10, and it will grab that value and store it in the variable of a. But we also want to do this for the second value. So I'm going to duplicate this line and change a to b. Then I'm going to copy and paste this print statement right below it. Now, the last thing we have to do is print the actual result. So to do so, we're going to print that the result is, and we'll insert a comma, and finally type in int of a plus int of b. Because input grabs whatever the user inputs as a string. So we need to convert that user input to an integer before performing that operation. Input will always grab whatever the user inputs as a string. Now, optionally, you could wrap input with the integer converter, and that would work perfectly fine. Just remember to update your type annotations so PyCharm doesn't complain. But in this example, I'm just going to leave it as is. Anyway, once we run this program, we can get started with using it. So enter a value for a, we're going to put 100, and enter a value for b, and this one will be 50. The result will be 150. So now we successfully created one of the most simple calculators in the universe. There's still a lot that we could improve with this project, but we will save all of that for when we learn more about Python. The next data type that we're going to be covering is called a Boolean. And Booleans in Python are used to represent true and false values. These are the only two states it represents. For example, we could have a variable called isConnected of type Boolean, and that's going to equal true. So the user might have a connection or might not have a connection based on this Boolean. Otherwise, we can check if my bank account has money, which obviously will be set to false because there's no money there. And by this point, we've already seen Booleans a lot, especially when we were working with operators. For example, if we were to check that 10 was more than 5, this would return to us a Boolean. As you can see, when we run this, we get true as a return, which is a Boolean. Now, there's one thing that's very interesting that I need to mention before we move on, and that is that true and false are just constants for the integers 1 and 0. For example, if you were to print the int of true and the int of false, you would get 1 and 0 back. These are just constants that we use in Python to denote whether a value is turned on or a value is turned off, or in other terms, true or false. But with this kept in mind, we can perform some very silly operations, such as print true plus true. And even if you will never see this in a real project, this is a perfectly valid operation because, once again, these are just constants for the integers 1 and 0. So running this, we're going to get 2 as an output because true, which has the value of 1, plus true is going to give us 2. Later on in this course, we're going to be learning how we can perform Boolean checks to make sure that certain conditions are met before performing certain actions. For example, here we can check if we are connected to the internet, then we're going to print there is internet. And since this is set to true, it's going to print the result. Otherwise, if this was set to false, we would get no output because this condition was not met, which means this block of code will not be executed. But don't worry about this block of code for now. We will cover that later on in this course. Up next, we have the list data type. Lists allow us to create structures that hold elements that we can manipulate as we please. And in Python, lists are incredibly flexible. But let's get started by creating an example of what a list looks like. So here we have a variable called myList, which will be of type list. And to create a list, we use square brackets. Now, everything we include inside here will be part of the list. So for example, we can include 1 as an element, we can add a Boolean value, we can add some strings, and we can even add another list inside this list. These are all valid elements. You can literally include any data type you please as an element. To keep this lesson simple, we're going to be creating a list of type string, and it's going to contain the names of people. For example, we might have Bob, James, and Tom in our list. And note that with the type annotation, I used the list type followed by the type that we have inside the list. If you used integers instead of strings, you would just pass in integer, and that would make it a list of type integer. But since we're using strings, we're going to call it a list of type string. Anyway, let's look at how we can access elements from this list. So to do so, first we're going to refer to the list, and then we're going to include some square brackets and then access the element we want via its position. So maybe we want to access Bob, which means here we would have to insert 0 because Bob is located at the position of 0 or at the index of 0. And this is incredibly important to remember, but in most programming languages, you're going to have indexing that starts at 0, which means Bob will be at the position of 0, James at the position of 1, and Tom at the position of 2. So just keep that in mind when you are trying to access something via its position. If we were to access Tom, on the other hand, we would have to insert 2 because Tom is at the index of 2. But now when we run this, we're going to have both Bob and Tom printed to the console. But let's remove that. And what I'm going to do here is just print the original list. So here we'll type original, because I also want to show you how we can perform some basic operations on this list to show you how flexible it actually is. So right now, if we run this, we're going to have the original list with these elements. But we also have the opportunity to append an element to this list. So maybe we want to add a person after we've created it. And to do so, we would type in people.append and the value that we want to append to this list, such as Jeremy. And the next time we print these people, we're going to have Jeremy as part of the list. And I'll also add some comments here. But in some cases, you might also want to remove people or remove elements from your list. So here we'll type in remove, and we will type in people.remove with the element that we want to remove. So maybe we don't want Bob to be part of these people anymore. And the next time we run this, Bob is not going to be part of the list anymore. As you can see, we have James, Tom, and Jeremy. We also have the option to remove the last element from a list using the pop method. So here, just type in pop, or actually that's just a comment, but we can type in people.pop. And the next time we print our people, you'll see that Jeremy is not going to be included anymore because we popped the last element from our list. At the moment, we have two people in our list. We have James and Tom. But what if we want to change the value of James? Well, to do so, we can refer to that value by calling people at the index of 0 and just assigning it a new value, such as Charlotte. So that the next time we print these people, it will contain Charlotte instead of James. And also, if you ever want to insert an element at a certain position, you can do so by typing in people.insert. And here, first you need to start with the position of where you want to insert the element. So suppose you want to insert an element between Charlotte and Tom. To do so, we have to insert the value of 1. So we want to insert this new value at the index of 1, and the value that we will insert will be called Timothy. And I will add a comment that says insert, so that the next time we print these people, we will have Timothy at the index of 1. Now, the final operation that I'm going to be showing you in this lesson is the clear operation, because maybe you messed something up, or maybe you don't care about any of the elements anymore, and you want to completely clear the list. To do so is super simple. All you have to do is type in people.clear, and you'll notice that the next time you run your script, we will have no people left in our list. So as you could see, there were many operations that you could perform with lists. And one thing I absolutely recommend you do before moving on with the course is playing around with this. It might be hard to remember all of these methods, but with a powerful tool such as PyCharm, you're always going to have suggestions from the code editor, which means everything I showed you will show up in your suggestions when you refer to the list. So in case you want to play around with anything, just add the dot and read all of the suggestions that come after. And one more thing that can actually help you a lot with learning Python is hovering over the new methods that you are using. Here you're going to get some very basic documentation, and usually it will tell you how it works. So here we have a function that allows us to insert an object, and then it tells you exactly what it does. And unfortunately, documentation isn't always going to be straightforward. So sometimes it's going to say something quite complex, but I'm going to do my best to make sure that you understand how these things work, so that when you have to code by yourself, it won't be such a shock to read this documentation. But that's all I'm going to cover in this lecture. Later on in this course, we will be creating a few projects that will take advantage of this functionality to create some very cool programs. So you'll definitely have the opportunity to see how lists work in real-world projects. In Python, we have something that's very similar to a list, and this is called a tuple. The major difference between lists and tuples is that tuples are immutable, which means once created, they cannot be modified. This makes them more memory efficient as a result. And when I was introducing all the data types, I told you that to create a tuple, we had to use parentheses. And that was a mistake on my part, because the parentheses do not define a tuple. The comma is going to define the tuple. For example, we can have some items of type tuple, and here we're going to have 1, true, and text. As you can see here, we didn't have to insert any parentheses. This will be considered a tuple, and you can verify that by printing the type of these items.
As an output in the console, we're going to have a tuple. Although in many cases, you're going to see tuples wrapped in parentheses because it's just easier to read. But I just want to mention this very early on because a lot of beginners mix up the fact that it's the comma that creates the tuple, not the parentheses. So if you ever have a tuple of one element, it's going to look like this. I know it looks kind of funny, but if you were to put it like this, it's going to be interpreted as an integer, because this will just be seen as some order of operations. So anytime you want to create a tuple, make sure you use the comma. Now, since tuples cannot be modified after creation, usually you would use it for something such as coordinates, for example. Here we have coordinates of type tuple, and that's going to equal 1.5 and 2.5. And that would be a very simple example of a tuple. And I'm also going to show you that they cannot be modified by referring to the index of the first element and trying to reassign a new value to it, such as 10. If we try to print these coordinates now, we're going to get a type error that tuple object does not support item assignment. So there isn't any way to change the tuple without creating a whole new tuple. And if we use dot notation, you'll see that the only two methods we have is count and index, and these do not modify the tuple. Otherwise, if you want to see what the tuple looks like when we run this code, as I mentioned earlier, you're probably going to see it with the parentheses. Python does this to make it more readable. But again, make sure you have that comma in there because that's the true way to define the tuple. But what if you want to create an empty tuple? So let's create a variable called new tuple of type tuple. And to create a tuple is quite straightforward. You can just add in an empty pair of parentheses. It only becomes more complicated when you want it to start with an element, such as 1. Then you need to include the comma. But if you just include the parentheses by itself, this is going to be of type tuple. So we can print the type of this new tuple, and as an output, we're going to get that tuple. Also, let's go back to the coordinates example, because I have something else I need to show you. And that's how to properly annotate tuples. Because with lists, we could just pass in the data type such as integer, and that would be enough. With tuples, it's slightly different. If you want to correctly annotate these types, you're going to have to do it by position. So here we have two elements of type float, and I already messed up by typing integer, but what you have to do here is type float and float. You need to include one for each element in the correct order. And that would be the correct type annotation for this float. But to sum it up, all you need to remember is that if your data is constantly changing, you will probably want to use a list because you can perform add operations, you can remove things, and so on. Otherwise, if you know the data you are using will never change, you should opt in for a tuple. At this point, we've covered both lists and tuples. Now moving on, we're going to start looking at sets, which are another list-like data type that allow you to store values in Python. The difference though with sets is that they have no guaranteed order and they cannot contain any duplicates. But you can still mutate a set, which in other words means you can add and remove elements as you please. So to create a set, we're going to start off with a variable called elements, and it's going to be of type set. Then here, we're going to include the value of 99, true, and Bob. So all we had to do here to create that set is include some curly brackets and insert the values inside these curly brackets. Now when we print this, what you should see in the console are the elements inside the set. And as I mentioned earlier, they have no guaranteed order, which means true can be at the index of 0 or at the index of 2. It's going to be random each time you run your script. But again, we can mutate sets with some very common operations, just like we did with lists. For example, if we refer to our elements and we want to add something, all we have to do is type in add and the element that we want to add, such as not Bob, because there's already Bob, but James. And I will also add a comment, add elements, so that the next time we print this, what we should notice is James added to our set. But once again, it's not going to be in any particular order. Otherwise, we can remove elements using the remove method. Elements.remove We don't want Bob anymore, so we're going to remove Bob. And then we will print those elements. And what we should have left is a smaller set without Bob. We also can choose to remove a random item from our set using the pop method. So here we'll type in pop and elements.pop. We can't really select what we want to pop, so of course it's going to be random. So if we print the elements now, one of those elements are going to disappear. If we rerun that, the order is going to change, but it's never going to be guaranteed. As you can see, sometimes it's going to pop something different. And finally, if you ever want to clear your set and make it empty once again, all you need to do is refer to your set and use the clear method. After that, it's going to be completely empty. As you can see here, we have a set without any elements. And you might be wondering, why is it written as set instead of just containing an empty pair of curly brackets? Well, to explain that, I'm just going to remove everything and start from 0. So to create an empty set, we need to use the set constructor. And that just means we use set with the parentheses. And you can do this also with the list data type or with the tuple data type. That will work for all of them to create a new empty data type of that data type. Here, of course, we have some syntax highlighting because we're using the wrong type. But if we wrote tuple here, the errors would go away. Anyway, going back to what we had earlier, to create an empty set, we are forced to use the set with the parentheses. Because if we were to write this would end up creating what we call a dictionary in Python. And that's a different data type, which we will soon cover in this course. So that's why you'll see an empty set being written as such. And if we print this empty set, we're going to get exactly what you see. And finally, I just want you to note that because sets are so random, we cannot refer to anything specific, which means we cannot index them. For example, if you want to get the first element, you cannot use this syntax. It's not going to work. It's going to raise a type error that set object is not subscriptable. And you'll probably see this error in other places, but all it's saying is that you're trying to perform an invalid operation with that data type. I mean, you should get the exact same error if this was an integer. If we try to refer to the index of 0 on an integer, that doesn't make sense. And what we're going to get is this type error that int object is not subscriptable. There is one special data type that you probably won't use that much in Python, but eventually I'm sure you will use it, so we are going to cover it. And this is the frozen set. And frozen sets are exactly the same as sets, except you can't modify them after creation. They are immutable. They are also considered to be slightly more memory efficient, just like when you use tuples instead of lists. So if you know that your data isn't going to change later, feel free to use a frozen set. And to create a frozen set, all you need to do is use the frozen set data type. So here, frozen set, and pass in a regular set, and that's going to freeze it. So in this example, we can have 99, true, and Bob once again. And the contents of a set can be of any data type, and that's all I'm showing you here. But it can also be something such as 1, 1, 2, 3, 3. And I should have showed you this in the previous lesson, but if you try to include duplicates, it's going to remove those duplicates for us. Anyway, I'm going to show you that through this, whether it's a frozen set or a regular set, it's going to remove the duplicates. But let's print this frozen set. And what we're going to get as an output is the class of the frozen set, because this is not what I wanted to print. I wanted to print the things. And as you can see here, we'll have the frozen set with the elements of 1, 2, and 3 inside that set. Also, watch what happens when we try to add an element to the frozen set. If we were to type in things.add and we try to add Bob to this set of numbers, we're going to get an attribute error. That frozen set does not have this attribute. And all it's saying is that with a frozen set, we do not have the option to add anything. It's not part of the functionality of a frozen set. So once again, frozen sets are immutable, which means they cannot be changed once they have been created, which is incredibly useful for developers who do not want their code to change after it has been set. Otherwise, there isn't really much else to say about frozen sets other than that they are identical to normal sets in every way, with the main difference being that they are immutable and should be preferred if you know your data will not be changed. And again, you will probably rarely run into this data type, but it's good to know about it in case you need it. In Python, we have another data type that allows us to store data using a key value pair structure. You will see this structure being used a lot when working with data, especially if you're retrieving some data from a cryptocurrency website, or if you're trying to retrieve the latest weather information, you will probably always get it back in this key value pair like structure. To work with key value pairs in Python, we use the dictionary data type. So let's get started immediately by creating an example of a dictionary. So here we'll have some users of type dictionary, and that's going to equal these curly brackets. But this time we're going to be inserting key value pairs. So it's not going to be considered a set. Python's going to know immediately that we're creating a dictionary. For example, we might have a user named Bob with the ID of 1. And this follows the structure of a key and a value pair. You could even flip these around and say that Bob is the value and 1 is the ID, and that would work just fine. But let's continue by adding another user. And to do so, we're going to add a comma and add another key value pair named Luigi. So now we have two users here. And as I mentioned in the set video, if you want to create an empty dictionary, all you need to use is the curly brackets. And this will default to creating an empty dictionary, not a set. Anyway, let's print both of these and see what happens. So print users and print empty. And what we should get in the console first is our dictionary back, and next is an empty dictionary, which is just an empty pair of curly brackets. But next, let's look at some of the common operations we can perform with dictionaries. One of them is retrieving elements. And to do so, we refer to the key if we want to grab the value. So here we're going to print, let's say, the users with the key value of 2. This is not the index, this is the key value. So once we run this, we're going to get Luigi back. If we try to provide a key value that doesn't exist, we're going to get a key error because that does not exist. And this is a very simple example of how we can access elements. But what happens if we have a dictionary inside another dictionary? So let's recreate this example, but this time it's going to be some weather data, and that's going to be of type dictionary. And the first key is going to be the time, so at 12 o'clock. Then I'm going to add a comma and just go down a line. As long as we're inside the curly brackets, it doesn't matter how we format this, but this will make it slightly more readable. So then we're going to have the weather, which is going to be a dictionary. And inside here, we're going to have a key called morning for the morning weather. And here it's going to rain. Then below that, we're going to have another key called evening, and it's going to be more rain. So that's going to be the structure of our data. And if we were to print this weather, you'll see in the console that it's going to flatten out and look like this in the end. So if you want to format it just regularly on one line, that's perfectly fine. In this case, I'm going to keep it like this so it fits on the screen. Next, let's try to access the values. So right here, first we're going to access the time. So we need to insert the key of time, and that will give us 12 back. Now let's duplicate that and access the weather. Once we run that, we're going to get another dictionary back. So at this point, if you want to get one of these values, you probably already know what we have to do next. Let's duplicate this line, and since we know this returns a dictionary, we can add another pair of square brackets. And we can say we want to get the value for morning. And that's going to give us back the rain. It's going to give us the value in that dictionary. So you just have to keep on nesting these each time you have another dictionary inside your dictionary. But let's go back to what we had earlier with our users, because I also want to show you how you can add key value pairs to the dictionary. And to do so, all you have to do is type in users or whatever your dictionary name is, and just type in the name of your new key. So users with the key of 3 is now going to hold this new value, which is called Mario. And if we were to print that, we're going to have Mario with a key of 3 and a value of the string of Mario. And just like this, we also have the option to modify an element. So in case we want to modify the user with the ID of 1, we can do so by typing in users with the ID of 1, is going to now equal James. And as soon as we print these users, James is going to replace Bob. In case you want to delete a value from a dictionary, you can refer to users.pop, and here you need to insert the key. So let's delete Luigi in this case by inserting the key of 2. And the next time we print these users, we should have a dictionary with only Bob. Otherwise, another way to do this, which is quite similar, is using the delete keyword. So here we can type in delete users with the key of 2, and it will achieve the exact same thing. And finally, just like with anything, we can use users.clear to completely clear the dictionary. So if we run this, we're going to get an empty dictionary as a result. So up until now, we've covered the most common functionality that we will be using with dictionaries. But later on throughout this course, we're going to be using the dictionary type a lot. So again, there's going to be plenty of opportunities to see how it works in real world projects. While there are many data types in Python, one that you'll see around a lot is the none type, and it looks like this. In all simplicity, it's there to represent nothing. It's not supposed to be any value, it just represents literally nothing. There is some functionality in Python that returns this type, and all it tells us is that we got nothing back from what we tried to get. But let's take a look at a few examples on how we can use none. So for example, we can create something called no value, and that's going to be of type none. And we can set that to none. And that literally means again that we have nothing there. So let's print this no value and print the type of this no value. And what you should get back first is none itself, and then the none type. One example of where you're going to see this is with dictionaries. You might have some users of type dictionary, and that's going to equal 1 Mario and 2 Luigi. And maybe you want to get a user back. So what you're going to do is type in users with the key of 3, because you don't know there's no third user. So you're going to attempt to try to get the user back that has a key of 3. And obviously this is going to raise a key error. But dictionary has some other helper methods that help us avoid getting this exception. And one is called get. So with get, we can insert a key that we want to try to retrieve the value for, and if it can't find that, it's going to return none. For example, if we insert 3 here, instead of getting an exception, it's going to say that key doesn't exist, so none was found. Or in other words, we got nothing back for the key that we provided. As soon as we insert 2, we're going to get our value back. But again, what's important to note here is that Python returned the none type for a key that didn't exist. Also, the none type is also used to define optionals. And optionals are just values that might or might not contain a value. For example, we might have something called possible user. And here we're going to say that this is of type string or none. And here we use the pipeline to create what they call a union type. And a union type just means that it can be either one type or the other. So this doesn't have to be none. This can also be an integer, or it can be a list. It just says that both of these types are acceptable for that value. Anyway, to create an optional, we combine any data type with the none type. So possible user is going to equal users.get. And once again, this might return none, or this might return a value, which is going to be of type string. So here what we're going to do is insert 3. Then we can print this possible user. And what we're going to get back is either a string or none, depending on the key that we insert. So if we insert 2, of course, we're going to get a string back. Otherwise, if we insert a key that doesn't exist, we're going to get none back. And in this documentation for get, you'll see at the end where there is the arrow that we either get a value or none back. So those were the basics of the none type. And this isn't really a type I can really explain much of without teaching you the Python language first. So we're going to end this lesson here, but don't worry, because you're going to see this type being used a lot throughout this course. So you're definitely going to get the opportunity to see more of how it works in Python. For our very first project, we're going to create something called Mad Libs. And Mad Libs is a story-based game where you ask the user for some nouns, some names, some verbs, and then you insert that into a pre-made story, and what comes out is some very random story. So let's get started immediately with creating this. And first I'm going to create a name of type string, which is going to equal the input of enter a name. Then we're going to create something called noun a of type string, which will equal the input of enter a noun. And since this is going to be very repetitive and you're not really learning anything by seeing this, I'm just going to copy and paste in the rest. So I'm repeating the same process, except here I have something called verb A, and then noun B, then verb B, then number A, and number B. And all the prompts kind of fit that variable name. So enter a name, enter a noun, enter a verb, enter a noun. It's going to continuously prompt the user to enter some values. Now, the real part of Mad Libs is the story part. So here we have a story of type string, and that's going to equal this multi-line string. And this just makes it much easier to edit the story. So first of all, I'm going to create a divider, and that's just a bunch of dashes. Then while we're here, it's also a good opportunity to teach you about the f string, because previously what we did when we wanted to add a variable to a string is print the text plus the variable name. And that's how we would concatenate this text. But Python has an even easier way of doing this using f strings. And the way this works is by putting an f in front of the quotation marks. So now we can type in something such as text, and by using curly brackets, we can insert Python code directly. So now we can insert the name inside here instead of using that string concatenation. So we're going to be using this concept inside our story, which means we need to add an f in front of our triple quotation marks. And that's going to convert this all into a formatted string. And while I'm here, I'll also add the divider at the bottom. So the story is going to go inside here. This is a story about name, a strong and beautiful noun A, who loved to verb A. So at this point, you probably already see where this is going. Just to demonstrate how the script works, I'm going to actually remove everything up until verb A, and I'm going to run this script. So now it's going to ask to enter a name, I'll say potato, enter a noun, we can say hammer, and enter a verb, and as a verb I will say swim. And I actually forgot to print the story, so of course we're not going to see anything. Down here we can type in print story. And then let's run this again, potato, hammer, swim. And we're going to get the story as an output. This is a story about potato, a strong and beautiful hammer who loved to swim. So just like that, we were able to take that user input and generate a story based on it. But let's insert the rest. So we had noun B, verb B, number A, and number B. Below the first sentence, we're going to add this line here that says name once verb B and won a noun B as a prize. Isn't that incredible? And the next line is going to say today, name is, and next we have two numbers that we want to insert into our story. But as you know by now, input takes everything in as a string. So to actually use these as numbers, we need to use the int converter. So int number A plus int number B. Years old and has retired from all adventures. But the story will live on forever. So now we have a very silly story with a lot of user input. But let's give this a proper run with all the variables. So here we'll enter a name, and it's going to be Bob. Then we're going to enter a noun, which is going to be apple. A verb will be sing. Another noun can be bird. And then we need to enter a verb past tense, and that can be ran. Then we'll enter a number such as 2, and another number such as 100. And at the end, we're going to get this very funky story. This is a story about Bob, a strong and beautiful apple who loved to sing. Bob once ran and won a bird as a prize. Isn't that incredible? Today Bob is 102 years old and has retired from all adventures, but the story will live on forever. So that was Libs, a very simple project you can create in Python. Now, as homework, I recommend you create your very own story and introduce your very own variables, and then try to get a friend to fill it out. Learning about data types wasn't really the most interesting part of programming in Python, even though it's incredibly important to know before we actually move on with learning Python. But now we can finally start having fun by moving on to the logical part of programming. In this lecture, we will be covering the most basic control and flow functionality using if, elif, and else to make decisions based on certain conditions. To get started, we're going to create a variable called age of type integer, which is going to equal 30. Now, what we want to do here is create some logic that checks the person's age so we can verify that they are old enough to enter the club or not. And to do so, we're going to use the if-else statement. So here we'll type in if age is more than or equal to 21, then we're going to print the following statement. You may enter the club. And as we discussed earlier, this is an expression that's going to return either true or false. If this evaluates to true, this code will be executed because this will satisfy the condition for this to be executed. One thing that's very important to note, which I have not covered just yet, is that in Python, we use indentation to define code blocks. And in general, we use tab to define this. In PyCharm, we can go to this bottom toolbar to see how we defined it in PyCharm. And here it's going to say that an indent is 4 spaces. Anyway, all that you need to know is that it's important that we indent properly. We cannot execute this code like this, because this requires a block to be executed. This has to be inside the block. So here we're going to insert it by adding a tab. And as you can see, if you tap on enter, you can also add other code. As long as it's on the same indentation level, all of that's going to be considered part of this block. But we also want to add a condition in case the person is not older than 21. So we're going to type in else and create a new block. And here we can print you are not allowed in, so that the next time we run this code, it's going to be able to check the person's age, and if they are old enough, this line of code will be executed. Otherwise, if we change it to 20 and rerun the script, the else block is going to be executed. In this example, we had a very simple check with only one condition to check for. But in more complicated examples, you can have many conditions to check for. For example, we might have some weather of type string, which is going to equal cloudy in this example. Now, what we're going to do is check if the weather is equal to clear, then we will print it is a nice day. And then using the elif statement, we can check for another condition, such as if the weather is equal to cloudy, we're going to print that the weather could be better. Elif the weather is rainy, we will print what an awful day. Else, to cover all the other conditions, we're going to print unknown weather, because our program doesn't know what that is. And you can add as many elif statements as you want. But now let's test this out by running it. So since the weather is cloudy, it's going to trigger this statement over here that tells us that the weather could be better. If we were to change cloudy to rainy, we're going to get the rainy condition triggered. What an awful day. Otherwise, if we type in something completely random, such as dry, we didn't really create any functionality or any conditions to handle that. So when we run this, we're going to get unknown weather. One thing that's very important to note is that the order of these does matter, because each one of these are executed in order. And one place you'll see that this actually affects your code is, for example, if we have an age of type integer again, and that's equal to 19. And here we're going to add if, elif, and else to check the age to verify how old the person actually is. So if age is more than 12, then they are a teenager. Elif age is more than or equal to 18. I guess you're still considered a teenager, but here we're going to type in young adult. And below that, we can check if the age is more than or equal to 21. We will just print adult. Else, it's going to be an unknown age. So, if we run this, what we're going to get back is teenager. Because the way this works is that first it checks the first condition, and since this returns true, it stops here. It returns teenager, when what we were supposed to get back is the young adult. Because here the age is 19, which means they should be considered a young adult, not a teenager. And that's why the order actually matters. What we should have done here is check for the older age first, and then make our way downwards. So now we're checking if the age is more than equal to 21, and if that fails, we check for if the age is more than or equal to 18, and if that fails, we check if the age is more than 12. We do this in the reverse sense. Which means now when we run this, we're going to get you are a young adult. And if we change this to 100, it's going to work as you are an adult. Going back to what we had earlier, where we had 12 as the first condition, if this was set to 100, we would still get teenager because this was satisfied first. And once we execute the code from an if, elif, else statement, it stops at the condition that was satisfied and ignores the rest. In Python, there are many places where we can shorten our code by using some alternative syntax. I must stress though that your priority should always be readability, and that while shortened code might look cool at first, in the long run it will absolutely waste everybody's time when you are trying to figure out for half an hour what that line of code actually does. It's up to you to decide whether it's readable or not. And in general, you will know it's readable if you can come back to your code months later and understand it immediately without having anyone or any comments explain it to you. Anyway, what I want to show you here is something that's called a shorthand if-else statement. And you will see this being used to simplify simple Boolean expressions. For example, we might have a number of type integer, which is equal to 0. And here what we're going to do is create a variable based on if this number is greater than 0 or less than 0. So if the number is greater than 0, the result is going to equal the string of above 0. And this will be of type string. Else, the result type string is going to equal 0 and below. Now, if we try to print this result, you'll see that we will get 0 and below back because the number is 0. If we add 10, we will get above 0 back. Now, while this was a perfectly acceptable solution to creating this result based on the number, there is a way to shorten this into a one-liner, so we don't have to use an additional 3 lines of code for something as simple as this. So instead of writing these 4 lines of code, we're going to write one that's called result of type string is going to equal above 0 if the number is more than 0. Else, we're going to type in 0 and below. And this one line of code will replace these 4. So what this does is return this result if this expression evaluates to true. Else we return this result. So that's what we call a shorthand if-else statement. And now we can actually remove this. And when we run our code, we're going to have the exact same result, above 0 for any number above 0. And we're going to get 0 and below for any number that's 0 and below. And I'm just going to type it out one more time in a way that might make it easier to understand. Here we're going to have a condition of type Boolean, which is going to be set to true. And then we're going to create a variable of type string, which is going to have the value of true if the condition is true. And in Python, we don't need to type in if condition is equal to true, because that's what we consider redundant. All we need to do is type in if condition, and this will check if the condition has a value or if the condition is true. So true if the condition is true, else we're going to return what happens when the condition is not true, which in this case is going to be false. Which means right now, if we were to print this, since the condition is true, we're going to have true returned and assigned to the variable. But if this condition ends up being false, we're going to have false assigned to this variable because the else block was executed. And the condition can be any Boolean expression. So it can be if 10 is more than 5, or if some text variable is equal to hello. Of course, this variable doesn't exist, but you get the point. It just has to be an expression that can evaluate to either true or false. So if condition is perfectly acceptable for this scenario. And I'm going to rewrite this one more time in its alternative form, which is if condition, we're going to create a variable of type string, is going to equal true. Else, a variable of type string is going to equal the string of false. Now we can just remove that and paste it right under. Both of these achieve the exact same purpose, only this one was a bit more simple and might even be considered more readable because it only took one line of code. But again, if this ever becomes too confusing, I recommend you opt in for this version, because once again, readability should always come first. Wasting your time trying to figure out what you did here, a couple months after you've created it, is a huge waste of time. But in some places, this will be much more readable than doing this. Although the benefit of using blocks is that, of course, we can add extra code, such as print hello. Now, this is complete nonsense, of course, but as you can see, we can add code blocks, while with shorthand statements, we cannot. It's time we take a look at the most fundamental looping functionality in Python, starting with the for loop, which allows us to iterate through any iterable and to execute code on each iteration. But of course, to explain all of this better, I'm going to create some examples so you can see exactly how it works. So to get started, I'll create some text of type string, and that will equal hello world. Now, suppose you want to print this 3 times. Well, one thing we can do is print this text and duplicate it 2 more times. And that will achieve exactly what we want. As soon as we run this script, we're going to have hello world printed to the console. But now suppose you want to do it 10 times. Are you really going to sit here and try to count each time you're printing it? Because eventually this becomes unmanageable. 10 is still doable, but what if you want to do it 100 times or even 1,000 times? It will just not make sense to do this line by line. So what we're going to do instead is create a for loop. So for I in range 3, we're going to print the text. And the syntax goes as follows. We start with the for keyword, and then we insert the variable name that we want to use for each iteration. Then we use the in keyword to tell Python that we want to loop through this iterable. And range just creates a range of numbers from 0 to 3. And the 3 is exclusive. So in theory, it's going to generate a list-like object that contains the values of 0, 1, and 2. So we're going to iterate through each one of those values, and that's going to print the text 3 times. If we want, we can also use I. So let's recreate this print statement, and this time we're going to insert I for each iteration, and the text, using a formatted string. Now the next time we run this, we're going to have 0 hello, 1 hello, and 2 hello. And if we wanted to create 10 iterations, we could also change the range to 10. And then it would print hello world 10 times, from 0 to 9. And that's much better than manually copying and pasting this 10 times. Now, this also works with lists and anything else that's iterable, such as a tuple. So here we'll create something called people, which will be a list of type string, and it will contain some people, such as Bob, James, and Maria. Then what we're going to do here is loop through this iterable. So here we can type in for person in people. And once again, this can be any variable name you want to give it. We're going to print that person. And when we run this, we will have each person printed to the console because it was able to loop through this list one element at a time. And eventually you can even add some more custom logic, such as if the length of person is more than 4, we can print that that person has a long name. So here I'll type in the formatted string of person has a long name. Else, we're going to print that the person has a short name. And when we run this, you'll see that Bob will have a short name, James has a long name, and Maria has a long name. We were able to define some custom functionality for each iteration in this for loop. And this was a lot more efficient than manually copying and pasting this 3 times for each one of these people. So in Python, we used the for loop to iterate through a finite amount of elements. Everything we were iterating through theoretically was finite, meaning that it was a fixed amount. When we were iterating through those people, we only had 3 people. So the for loop was perfect for that situation because we're telling Python that we want to iterate through each and every one of those people and that eventually it should stop. But Python also provides us with another way of looping. And this time it's going to loop indefinitely as long as a certain condition is satisfied. So let's take a look at how we can create this infinite looping functionality. And in Python, if you ever want to create an infinite loop, you would use the while keyword followed by a condition that you want to satisfy. So this can easily be something such as while x is more than 5, do the following. We didn't define x here, so of course that's going to raise an exception. But to create a truly infinite loop, I'm going to type in while true. Now, if we were to print something such as hello, this script would run indefinitely forever. And that's because we defined a condition that will always be true, no matter what happens. So in general, you will always want to specify a condition that allows you to exit the loop. One way of doing this is to create an integer, which can equal 5, for example. And here we can type in while I is more than 5, or not more than 5, but more than 0, we're going to print hello, followed by the iteration, or followed by I. And on each iteration, we're going to decrement I by 1. And it's important you remember this, because eventually this will lead to this condition becoming false, which is very important if you want your loop to end eventually. So now if we were to run this, you would see in the console that it would start with 5, and then 5 iterations later, it would get to 1. And as soon as I becomes 1, the next time it decrements, it's going to become 0, which means this condition will evaluate to false, resulting in this loop to exit. Now for a real life example, you would probably see this in a different context, such as you might have a connection, and here we have a Boolean that's checking for that connection. So right now, if there is a connection, we're going to set that to true. But you might want certain functionality to only work while you have a connection. So you'll type in while connected, do this certain task. And we can just print using internet. Then I'm going to make our program sleep for 5 seconds by typing in time.sleep. And you'll notice that it's going to import a built-in module that's included in Python that allows us to stop our program for whatever amount of seconds we decide to put in. And I will explain how modules work in a different lecture, so don't worry about that just yet. All you need to know is that we're making the program sleep for 5 seconds here by using time.sleep and inserting the amount of time. But after 5 seconds, we're going to set the connection to false. And this will simulate that the connection was lost or something went wrong, so the connection failed. Anyway, under the while loop, we're going to print connection ended. Now, when we run this, it's first going to use that internet, then it's going to sleep for 5 seconds, and the Boolean is going to eventually change to false, which means since the connection will no longer exist, this will evaluate to false, exiting the while loop. And that means we can move on with the rest of the code. And I'm going to be giving you one more example on how we can use the while loop. And this is for creating a program that continuously asks for user input. So here we'll type in while true, and we will take some user input, which will be of type string, and that will take some input with the prompt of u. If the user input is equal to hello, then we will print that the bot says hello there or hey there. Else we will print that the bot says yes, that is interesting. So here we created our very first chatbot. And you'll see that by providing a while true loop, we're going to be able to interact with this bot continuously for the rest of our life, or until our computer shuts off or the universe ends. But if we were to run this, it's going to prompt us with the input, and here we can say something such as hello, and the bot will respond, hey there. If we type in anything else, such as today is my birthday, that will trigger the else block, and the bot will say, yes, that is interesting. Of course, this is a super simplified example of a chatbot, but as you can see in the console, it's going to continuously ask us forever, simulating a full program. In both while and for loops, we have the option to skip certain sections of code or to even end the loops prematurely using some simple keywords provided by Python. What we are about to cover is called break and continue. So first, let's look at how the break keyword works. And to do this, I'm going to create a number, which will be of type integer, and that's going to equal 5. Now, while the number is more than 0, we're going to do the following. First, we're going to decrement the number by 1 for each iteration, and then we're going to check if the number is equal to 2, we're going to break. And all break does is tell Python that it's time to exit the loop. So this will prematurely end the while loop as soon as this condition is satisfied. And below at the bottom, until that condition is satisfied, we're going to print the number. And here we can also type in print breaking at 2. Now, when we run this, you'll notice that once it breaks at 2, it stops the loop completely. It doesn't continue with 1 and 0, it just stops there. If we were to remove this, it would print down all the way to 0. But with the break statement, we're telling Python, okay, it's time to exit the loop. And it probably would be better to print something at the bottom, such as done, because now you can see that it starts at 4, moves on to 3, then it hits 2 and breaks, and moves on from the while loop to the next line of code. And you're not required to put this inside an if check, but it doesn't really make sense to use it without an if check. Because right here, if you were just to insert break after the decrement, it would just break immediately and it wouldn't execute any code after. So in general, you would want to use this inside a condition. But going back to what we had earlier, this was a great example on how the break keyword works to end our loop prematurely. But now let's look at what continue does. So instead of typing breaking at 2, what we're going to do is type in skipping 2. Because what continue does is tell Python that once we run into this keyword, to not worry about the rest of the code, but to just move on to the next iteration. Which means as soon as number is equal to 2, it will print that we are skipping 2, and then it will hit this keyword and move all the way back to the top on the next iteration. So if we were to run this one more time, it would start at 4, then it would go to 3, then as soon as the number is equal to 2, it would execute that line of code. But as you could see, it did not print the number 2 after it skipped 2. And then it completed the rest of the iterations. If we were to exclude continue, it would print skipping 2, but it would still print 2 after, which is not what we would want in that scenario. So with continue, we can just prematurely end that iteration. But now that we have an idea on how both of those work, let's move on to a practical example. And here I'm going to have a total of type integer, which is equal to 0. And I'm going to use the while true loop to create an infinite loop. Then inside here, we're going to type in user input. And this time it's going to be of type integer, because I'm going to try to convert the input to an integer, since here we're going to create a calculator. And all we're going to type in is enter a number. And actually, before we do that, I want to add some instructions for the user. So here we can type in welcome to Calc Plus, which is our calculator app name, add positive numbers, or insert 0 to exit. So this will be a calculator that only adds positive numbers, and if the user enters 0, it will exit our program. And first we want to check if the user input is less than 0, then we will print a warning message that says, please enter positive numbers only. And since we don't want to add any negative numbers to the total, we're going to use the continue keyword here so that it will not continue with the rest of the code and will just continue from user input once again. Otherwise, if the user input is equal to 0, we will print the total. So total is going to equal the total. And once we print the total, we will break out of this while true loop so we can terminate the program. And of course, at the bottom, in case it's a positive number, we're going to want to add that to the total. So let's add the user input to the total on each iteration. But let's run this code and see what happens. The first thing it's going to say is welcome to calculator plus, add positive numbers or insert 0 to exit. So now we can do something such as 10, 20, -5, and -5 will give us a warning. And once we run into this warning, of course, it's not going to continue with the rest of the code. So luckily, it's not going to add that user input to the total, or else we would have some unexpected output. But continuing, we can also do 30 and 25. And finally, let's type in 0. And as soon as we enter 0, it's going to trigger this block here, which prints the total and ends our for loop by exiting out of the for loop. And at this point, I only showed you how to use continue and break with the while loop, but the concept is exactly the same with for loops. At any point in a for loop, if you use continue or break, it's going to have the exact same behavior. With both for loops and while loops, there's one small bit of rare functionality that you will probably never see being used, because this functionality is considered to be quite confusing and unintuitive. But I'm going to be showing you how to use this functionality, not so that you will use it, but so that you'll be able to recognize how it works when someone else uses it. So what we're going to do here is create a for loop using I in range 3. And what we're going to print is the current iteration, like this. So iteration followed by the current iteration. And right now, if we were to run this, we would get all 3 iterations printed to the console. So this for loop managed to finish successfully. But now let's use the special syntax or the special functionality that I was talking about in the intro. And this is the else block on a for or while loop. At this point, you probably understand that it's not that intuitive. I mean, can you guess what this does? The answer for most people is going to be no. But what the else block does is act as a success block, which practically means that if the for loop successfully goes through all the iterations without encountering an error or without encountering the break keyword, this code is going to be executed. So what we can do here is type in success. For example, it will have completed all the iterations without any interruptions. So if we run this, you'll see iteration 0, 1, 2, and success. But at any point, if we were to add a break, this is going to prematurely end the for loop, and the else block is not going to be triggered as a result because it did not successfully go through all the iterations. So now if we were to run this, we would only get 1 iteration before hitting that break, meaning that the success block will not trigger. And the first question is, what's the difference between doing this and completely removing the else block and printing it on the outside? Well, the difference is that if we were to put this on the outside, this success statement will be printed no matter what happens, which means even if we break out of this for loop, we will still have success written at the bottom. So it does not do the same thing as the else block, because this line will execute regardless of what happens in here. While with the else block, this will only execute if we successfully iterate through all the iterations. And the exact same concept goes for while loops. For example, here we can create an integer, which will have the value of 3. And while I is more than 0, we're going to decrement I by 1. And we're going to print OK. And if this loop naturally ends, meaning this naturally evaluates to false, we can add this success block that says success. We naturally terminated the while block by making the condition evaluate to false. So if we run this, we'll get OK, OK, OK 3 times, and the success block will be executed. But once again, if at any point you break this while loop, the success block will not trigger because theoretically, this condition never evaluated to false. We interrupted the program while it was looping, meaning that it did not successfully complete its loops. So as a result, the else block will not execute. Anyway, you will probably never see this functionality being used because a lot of developers despise how hard it is to read. But again, it's good to know about in case you do run into it. It's time we build another project in Python. And this time we're going to be building Rock, Paper, Scissors, a classic game with some very basic AI. And here we're going to be able to do things such as interact with a bot that asks us whether we want to throw rock, paper, or scissors. Here I'm going to throw rock, and the AI will also have thrown rock, so it's going to end up being a tie. If I throw rock again, the AI seems to love rock, so I'm going to try going for paper. And this time I will have won because paper beats rock. Then we can do something such as scissors, and it's going to be a tie because the AI knows me very well by now. So I'll try doing rock again, and it looks like the AI threw a fast one on me because I lost this round. Anyway, let's take a look at how we can build that in Python. So first of all, we're going to get started with some imports. And once again, I will go over what imports are later on in this course. For now, just know that we're importing some external functionality into our script so that we can perform some extra operations. Anyway, let's import random and import our system. Then for step 1, we're going to want to provide some starting information. So first of all, let's welcome the user. Welcome to RPS, Rock, Paper, Scissors. Next, we need to define all of the available moves. And this will be a dictionary, which is going to equal rock, and rock is going to translate to the emoji of rock. On MacBook, I have a special button that allows me to insert emojis, but I wouldn't be able to say how you can do it on your computer. So you would probably have to go and search for the emojis online. But here I'm going to first start with rock and copy this rock here. And I'm going to do the same thing for the other elements, such as paper, which will contain the value of paper, and scissors, which will contain the value of scissors. Of course, I need to paste in the emojis. So scissors and paper. And I'm using emojis here because it looks quite cool. You don't have to do this. You can even just put some other text there, such as P, if you want to keep it short. Whatever you want to appear to the user should go inside here. Then we're going to create a variable called valid moves of type list of string. And that's going to equal a list from the moves.keys. So it's going to take this dictionary of moves, and it's going to take each one of these keys and create a list from it. And we can print these valid moves so you can see exactly what that is. Rock, paper, and scissors. Anyway, moving on to step number 2, let's define our while true loop because we need to create an infinite loop. So while true, and while this is true, we're going to start off by getting the user move, which is our move. And that's going to be of type string, which will equal the inputs with the prompt of rock, paper, or scissors. And what we want to do here is lower it. So whatever input the user enters, whether it is rock with uppercase letters, or if it's capitalized, it will always be interpreted as a lowercase rock. And this just makes it much easier for our Boolean checks, because when we receive the input of rock, we want to check that it's equal to the string of rock. And of course, if this rock has an uppercase character, uppercase rock is not equal to lowercase rock. But moving on, we need to perform some checks. The first one is going to check if the user wants to exit the game. So if user move is equal to exit, then we're going to print thanks for playing, and we're going to call system.exit, and this will terminate our program. Below that, we want to check that the user is selecting a valid move. So if user move is not in the valid moves, that means the user is selecting something that doesn't make sense. So we're going to print invalid move. And we're going to continue with our loop, because there's no point in continuing with the code if the user is inserting a move that doesn't exist. Now below that, we can finally move on to the AI deciding what to use. So here we'll type in AI move, and I'm going to add a comment above that that says AI decides, and this will be of type string, will equal random.choice, and we're going to insert our list of valid moves. So choice is just going to randomly select an element from our list, and we're importing this functionality from random. And below this, we're going to display the moves, and I'm going to format that using first some dashes, then I'm going to print the formatted string of u, which is us. And since we want to display the emoji, we're going to insert our dictionary and use the index of the user move to get that emoji. So if the user move is set to rock, it's going to find the key of rock in the move set, and it's going to return to us this rock here. And we're going to do the same thing for the AI. So moves, and we're going to enter the AI move. But of course, remember to change this to AI. And I'm going to copy and paste this dashed line directly under. Now the last part of this is creating the logic. What happens when the user move is the same as the AI move, and so on. So here we'll type in check moves. And to start this, we're going to check if user move is equal to AI move. That means it's a tie. It is a tie. If the user move is equal to rock and the AI move is equal to scissors, that means we win. So you win. And all we have to do here is cover the cases where we win. Meaning we can also type in elif user move is equal to scissors and AI move is equal to paper, you win. Then finally, we have only one more winning combination. So if user move is equal to paper and AI move is equal to rock. Paper beats rock, so we win once again. And for the rest of the cases, the AI will have one. Print AI wins. And since we're unhappy, we're going to use this ellipses to show that we didn't want that. So that covers the logic of our rock, paper, scissors bot. But with all of that being done, we can actually test this bot by running it. So first, let's try giving it an invalid move, such as banana. Luckily, it's not going to register that, and it's going to ask us to try again. So what we're going to do next, since we threw the bot off, is insert scissors. And this always works. If you throw banana the first time, scissors will always win. Although I do not recommend you try that in real life. But let's try with paper next time, and looks like we win again. And what if we insert rock? And this time the AI won. But let's try rock again. And this time it's a tie. But at this point I'm tired of playing this game, so I'm going to type in exit. The bot is going to say thanks for playing, and it's going to terminate the program. So that was the entire project. But I do have a bonus assignment for you if you really want to master your Python skills. Right now we have a bot that you can play rock, paper, scissors against, which is quite cool and all. But one thing that could really improve the experience of playing with this bot is adding a scoring system. One that keeps track of all the times that the bot won, and one that keeps track of all the times that you've won. When you are programming in Python, the two most important things to keep in mind is readability and reusability. Up until now, we've been writing everything line by line, even repeating certain bits of functionality, which isn't really that smart if we want to be able to scale our program someday. So what we will be doing next is learning how we can use functions in Python so that we will be able to create clean, reusable, and maintainable code much more easily. To create a function in Python, we use the def keyword, and this stands for define. So we are defining a function in Python. And then following the def keyword, we need to provide a function name. So this can be something such as greet, and then we can insert our block of code. So here we can type in print hello. Now, each time we want to use this function, all we need to do is refer to it using the function name and the parentheses. This will call the function. And by calling the function, I mean it's going to execute the code from that function. So if we were to run this, we would get hello printed to the console. Now we can duplicate this 2 or 3 times, and it will execute that code 2 or 3 times. The cool thing about this is that we only need to edit code in one place, and the changes will be applied throughout the program. So maybe here we want to add another line of code, such as, let's say, 4 dashes. Now editing the code here will update it throughout the rest of our program. And if we were to run this, you'll see that we will get hello with those dashes printed 3 times. Or maybe you even want to change the language. You can change this to ciao, if that's what you want. And once again, it will update it everywhere. A more practical example would be with getting the current date and time. So from datetime, I'm going to import datetime, and I'm going to create a function called showTime. Now, the first thing we need to do inside here is get the current date and time. And to do this, I'm going to create a variable called now, which will be of type date and time. And that's going to equal datetime.now. Then I'm going to print that the current time is the following formatted string. And inside here, I'm going to insert now, followed by some formatting. Note that I'm using a colon here before adding this special syntax. Now, what I'm about to show you isn't Python specific. It's just a very popular date and time formatting syntax. For example, if we want to get the hour in 24-hour format, we're going to use the % plus an H. Then I'm going to use a colon to separate it and use the % plus M to get the minutes. Then another colon and the % with S to get the seconds. So this will give us back the date time, and this will format it the way we see it. And when we run this, what we're going to get back is the current time. Now I'm also going to import time so that we can make our program sleep for a moment. And here we can type in time.sleep. And we will make it sleep for 2 seconds, and we will show the time once again. And this will grab the current time each time we use this function. So we run the program, waits 2 seconds, and after 2 seconds, it will display the new current time. So that is the beauty of using functions in Python. It promotes reusability and makes it much easier to edit our code throughout the program. But that was the basic concept behind functions. There's still a lot we can do with functions. So throughout this section of the course, we will be covering all of the possibilities and all of the options that we have with creating and using functions in Python. When you are programming, it's going to be quite common that you will have a general idea of what your program should do, and sometimes you'll create functions before you create the actual functionality. But if you create a function and don't insert any code, Python will give you an error. So we need to use some special syntax in order to avoid that. And this is used for placeholders in Python. For example, you might have a function called getStatus. And you will have no idea what kind of code goes in here just yet. All you know is that your program needs this function. So what you might do is type in a comment that says gets the status, but this is not enough for Python. If you run your script, it's going to give you an indentation error because it expected you to have some code inside there. You might get tempted to insert some random code as a placeholder, but that's not really the best solution for code that you have not implemented yet. So what we're going to do here, instead of all of this nonsense, is use the pass keyword. It tells Python that you should essentially do nothing here. you should just ignore this line of code. It doesn't do anything, but it allows Python to continue to behave properly. And we might have another example, such as connect to internet. And again, we don't have the functionality figured out just yet. So what we can do is pass in pass. And Python will still work. So you can still get a general idea of what your program should look like without implementing all of the functionality just yet. And pass isn't only used for functions. You can actually use it anywhere that you would normally implement code. For example, if you have, let's say, a Boolean check, here we have a number of type integer, which is equal to 2. And what we want to do is check if the number is more than 0, we will pass. Else, we will pass. All I want to show you here is that you can insert it anywhere that you would usually insert a block of code. So here, of course, you would type in something usually like more than 0. But if you don't know what to type in just yet, you can easily just insert pass. Or even in a for loop, for I in range 3, pass. It doesn't do anything, but it acts as a placeholder, which allows us to continue programming in Python without any problems. One more thing I have to mention is that Python also allows you to use an ellipses interchangeably in this case. For example, here we can have a function called connect. And instead of using pass here, we can define an ellipses, which is literally 3 dots. It doesn't matter which one you choose, they serve the same purpose. But what I recommend is that you stay consistent. If you choose to use pass in your project, use pass everywhere else. Otherwise, if you use ellipses, continue using ellipses throughout your project. Make sure that you stay consistent. In all my projects, I tend to use the ellipses because I think it looks nicer and it's slightly more convenient to type than pass. In the previous lesson, we learned that we could define a function using the def keyword. And earlier we created a function that could greet someone. And here all we did is print hello. But now it's time that we explore how we can make this much more customizable. Because suppose you want to greet some specific people. Right now, using this approach, we have no way of doing that. I mean, the closest thing we can do is something such as greet Mario and type in hello Mario. But this would defeat the purpose of this function, because then we would have to create a new function for each person that we want to greet. So what we're going to be using here are parameters. So to define a parameter for a function, all you have to do is insert the parameter name inside the parentheses. For example, here we can type in name, and we can tell Python that this should be of type string. Now, every time we call this function, we will be required to insert this parameter. And here I'm going to change this to an f string and insert this name. So hello, name. And we can treat this as a normal variable. But now with this syntax, we can do something such as greet Mario. And if we duplicate this, we can also greet James. And as soon as we run this, it will greet each one of these people with the custom name that we decide to use. Also, it's important to note that when we are passing some sort of value into a function, we refer to it as an argument. So here we're passing in the first argument of Sophia. When we define it, it's a parameter, and when we use it, it's considered an argument. So in this example, greet takes one argument, which is called name. And you will hear this terminology being used a lot in Python and in practically every other programming language. They are super similar, so sometimes I mix them up myself. I might call an argument a parameter or a parameter an argument. At the end of the day, it's not the biggest mistake if you call one the other. People will understand what you mean as soon as you show them what you're doing. But just keep in mind, this is a parameter, and when we use it, it's an argument. At this point, we created a function that takes one parameter, but it's also possible to create or define a function with multiple parameters. So now let's change this function up a bit by providing a language of type string and a default of type string. So what we're going to do inside here is check if language is equal to Italian then we're going to print chow, and this should be a formatted string, followed by the name. Else, we're going to print the default message, which will be default and the name. So now we have some more parameters to play around with. But let's take a look at how we can call this function now that we have multiple parameters. The easiest way to do this is to call our function and to insert these arguments in order. So starting with the name, we will have Mario, then we will have the language of Italian, and the default is just going to be set to hello in case we cannot find this language. And if we were to run this, we would get Ciao Mario, because that's the language we defined, and it was able to find that. If we try to change this to something weird, such as ASD, it's going to use the default. Now, there are also other ways we can call this function. And another way to do it is by being more explicit by passing in the parameter names. So here we can type in name, then we can type in language, and we can type in default. Each one of these names will be associated with the value that we're passing in. And these are called keyword arguments because these are keywords that we are associating with a value. One of the benefits of using keyword arguments is that we can actually put this in any order we please. And it will work exactly the same way because it will know exactly what we are referring to. And we can also mix normal arguments with keyword arguments. So if we do not want to insert the name for Mario, we can do that. We can just exclude it. And then we can be explicit with the rest. But it's important to note that normal arguments must come before keyword arguments. If we were to remove Mario here and insert it at the end, Python would not understand what this should be associated with. So it's not going to work. You always need to start with normal arguments before using keyword arguments. But as soon as you start using keyword arguments, you can actually put these in any order you want. So we can remove the default here and insert it here instead, and that will work just fine. And the last thing I want to cover in this lesson is how to actually provide a default value. Here I created a parameter called default, but it didn't have any default values. We had to provide it each time we called the function. But maybe we want hello to always be the default. So what I'm going to do here is actually remove this keyword argument, and inside the function declaration, we're going to add an equal sign and pass in hello. So this will automatically give default the value of hello each time we use this function. Now, if we were to run this function, it would work exactly the same way. If we try to replace this with ASD, it's going to use our default automatically. So this is how you define a default value. And just like with keyword arguments, default values can only come after the ones that do not have defaults. And just because we provide a default doesn't mean we can't change it later on. We can still type in default and change it to something else like hola. And the next time we run this, it's going to use the other default that we provided up here. Functions are amazing for making code reusable, but at the moment we only use them to execute blocks of code. But sometimes we will want to get a result back from that code and use it later on in our program. So to do so, we're going to have to define a return value. And again, using type annotations aren't going to be necessary here, but I strongly advise you get used to using them. So for our first example, we're going to create a function called getLength, which will get the length of any text we pass in, which is going to be of type string. And what we want to get back is an integer. So to specify a return type via type annotations, all you need to do is use a small dash and a right arrow. This will tell Python that what we want to get back is an integer. Anyway, inside here, we're going to print the formatted string of getting the length of, and here we want to insert the text. Then to actually return the length of the text, we need to use the return keyword. And here we will return the length of the text that we have inserted. So now we have a function that returns a value. It executes code, it performs some sort of calculation, and then returns the result. So down below, we could have a name called Mario, and we want to find out how long that name is. So below that, we'll create something called length of type integer, and that's going to equal getLength for the name of Mario. Then we can use that value and print it to the console. So this time we're using that function to actually calculate a result and return it. Now when we run this, you'll see that we're getting the length of Mario and that we will have 5 as a return. And you can use this anywhere you want in your code. It doesn't have to be assigned to a value to be used. You can even directly paste it inside your print statement, and it will work exactly the same way, because this returns an integer. Also, look what happens when we change integer to string. PyCharm gives us some syntax highlighting immediately that we are returning the wrong data type, and the message will tell you expected type string, but we got an integer instead. This warning saves us a lot of trouble because now we don't have to run the code to understand that we did something wrong. We're going to have some warnings ahead of time. And that's why I strongly encourage you to always define a return type, such as integer, because that will make sure that we're returning exactly what we expect. But let's take a look at another example. So here we'll create a function called makeUpper. And it's going to take some text of type string, and it's going to return to us a string. And all we're going to return is text.upper, which will uppercase the text that we insert. So now we can print makeUpper, and all I'm going to insert is hello. And this time you'll see that it's going to return to us a new string in uppercase letters. And finally, the last thing I want to mention here is that if you ever create a function that doesn't return anything, such as connect to internet, and all we do inside here is execute code, such as connecting to internet, all functions that only execute code and don't return anything are going to return none by default. And you can verify that by trying to assign the value of this function to a variable name, such as var of type string is going to equal connect to internet. We're going to get some syntax highlighting immediately, of course, because first of all, we expected a type of string and got none instead. So none of this really makes sense, but also if we were to print this variable, you'll notice that we will get none back. And it doesn't have to be in a variable. Once again, we can just copy this function and paste it directly in the print statement. So if a function only executes code and doesn't return anything, you're going to get none back as a default. So Python implicitly adds a return none at the bottom. We can't see this, but that's what it does under the hood. And you will often see me returning none at the top because I think it's a super good habit to have, and it just makes reading this so much easier, because immediately by reading this line of code here, we understand that this function was only meant to be run and that we shouldn't expect a return type. And this is also a good example of self-documenting code that explains itself, because we did not have to add or specify a comment that this returns nothing, because this would be completely redundant. Connects to internet and returns nothing. This was obvious by what we wrote right here. In this lecture, we're going to be talking about recursion. Now, usually the best way to explain the concept of recursion is by putting a mirror in front of another mirror. What you get in the end is a reflection that reflects the same reflection back and forth in what appears to be an infinite cycle. And recursion in programming is not really any different. But let's take a look at how we can use recursion in Python. So first, let's define a function that returns none. And inside here, we're going to print recursion, and we're going to call the same function inside. So this is where your head might start to explode, because as you can see, we created an infinite loop, which also means that when we call this will theoretically run forever. But luckily, our computers usually implement a safety mechanism that prevents it from running forever. And in most cases, this will raise a recursion error that the maximum recursion depth exceeded. Because if we were to scroll up, you'll see that we called recursion many times. And in most cases, that's not something you would want, because you could easily just use a while true loop instead. So for looping like this, it wasn't that practical. So let's look at a more practical example. And for this example, we're going to create a function that attempts to connect to the internet. If it fails, it's going to try again, but with a time delay that gradually increases. So what we're going to do is import time and create our function called connect to internet. And first we want to check if there's a signal, which will be of type Boolean, and we want to insert a delay for how long we should wait until we try again. And this is only going to execute code, so it will return none. Now it's important to simulate that we eventually will have a connection. So what we're going to do here is check if delay is more than 5 seconds, then we're going to set signal to true so that we can exit out of this recursion. And below that, we can check if there is a signal, we can print connected, and that will exit out of the function. Else, we're going to print the formatted string of connection failed, trying again in the delay followed by S for seconds. Then of course we want to sleep for that delay, so time.sleep and insert the delay. And at the bottom of all of this, we're going to try to connect to the internet once again. And we're going to pass in the signal, which is the current signal, and the delay plus 2 seconds. So each time we fail to connect to the internet, we're increasing the delay by 2 seconds. Now at the bottom, we can call this function connect to internet. Originally, we won't have a connection, so that will be set to false, and the initial delay will be set to 0. Now when we run this, it's going to try to connect to the internet, then it's going to try again in 2 seconds, in 4 seconds, and eventually it will have connected. And this was possible thanks to recursion. Practically all we said is that if the connection fails, try again in a few more seconds. So we called the exact same function inside the original function using a modified argument. And thanks to this, we were eventually able to exit out of this recursive function. Previously, we covered the basics of parameters and arguments. Now we're going to be moving on to something that is called args and keyword args, or kwargs, however you want to pronounce it. And they look like this. But first I'm going to get started by showing you how args work, and that stands for arguments. And I didn't show you this just yet, but when you use the print statement, you actually have the option to insert as many arguments as you want. And it's going to absorb them, and by default, it's going to place a space between them. And we also have a special keyword argument that we can pass in called a separator. So the default is going to be that space, but we can also enter something such as a colon. And the next time we print it, it will be inserted between these elements. So the reason we can pass in as many elements as we want is because print uses args under the hood for the first argument. And anytime you're inside the parentheses of a function, you can hold down Command plus P to see the arguments that it takes. So the first one has an asterisk followed by the values. Or even if you just hover over print, you'll get the documentation. And the first argument is going to be the args that I keep on talking about. Anyway, let's try to recreate this behavior in our own function. So for this example, I will have a function called add, and here we're going to use args. And this will be of type integer, and it's going to return to us an integer. And what we want this function to do is to add all the numbers that we pass in and return the sum. So first of all, I'm going to print the args so you can see exactly what that does. And notice that I used an asterisk in front of the parameter name. Then we're going to return the sum of the args. Now to actually use this, we're going to print and we're going to add 1, 2, and 3 all together so that when we run this, we will get those arguments back and we will get the sum. So the first thing you should note is that when we use this syntax, it absorbs all the values that we pass in and converts it into a tuple. That's all that args does. Also, it doesn't have to be named args. This is just the default. You can also name it something such as numbers, and that will work perfectly fine. All that matters is that you have an asterisk in front of that variable name. But with that being said, there are a few rules that you need to respect when you are using this syntax. Or actually, it's just one rule, and that is that anything that comes after this syntax must be passed in as a keyword argument. For example, we might have a function called greet, and it's going to take a greeting of type string. Then it's going to take some people, which is going to use this arg syntax of type string, and it's going to take an ending of type string. And what it will return to us is none, because we just want to greet these people. So for person in people, we will print the greeting, the person, and what kind of ending we want. Now to actually use this, we need to do the following. First, we will pass in the greeting. This will not be considered part of the people because the first argument is the greeting. So that will absorb hello. Then everything after the greeting will be considered a person. So if we were to insert, let's say, Bob, James, and Maria, that would all go into the people. And we can do this endlessly. And that's why the only way to insert the ending is to explicitly pass it in as a keyword argument. So ending will be an exclamation mark. So now when we run this, you'll see it's going to greet each and every one of those people. Because again, this absorbs these three elements and turns it into a tuple, which we can easily iterate over. In general, I would avoid putting positional arguments in front of args just because it becomes quite hard to read and understand. I just wanted to show you that it will still work if you have a positional argument in front of it and that anything after it must be passed in as a keyword argument. But moving on, very similar to args, we have something called kwargs or keyword args or keyword arguments. It doesn't really matter what you call it. What matters is that you know how it works. So here we'll create a function called pin position. And this time we're going to use two asterisks and we're going to call this kwargs or keyword args, which will be of type integer. And this will return none. Now, all we're going to do here is print these kwargs. And next we're going to use this function. So pin position. And the way this works is that any kind of keyword argument we pass in will be absorbed by kwargs. So x equals 10 and y equals 20. These two keyword arguments will be absorbed by this variable here. And when we run this, what we're going to get back is a dictionary because keyword args absorbs this syntax and converts it into a dictionary since we have key and value pairs. So we didn't have to create these parameters in our function, we could just create them on the spot. And our function would create a dictionary from that. And just like with args, there are a few rules that you need to respect when using keyword args, and that is that it still has to follow the logical order. For example, you might have a function that has args of type string, and then keyword args, and all of this returns none. So here args must come before keyword args. You can't put anything after keyword args. You can't even put other keyword arguments. It doesn't work because everything will be absorbed by this variable here. And we can actually print the arguments and print the keyword arguments. And to call this function, we need to do the following. So here we can insert A and B for the arguments. And then we can also create a dictionary, which has A with the value of 1 and B with the value of 2. This will be the correct way to call this function. As you can see, the arguments get converted into a tuple and the keyword arguments get converted into a dictionary. You can still define some parameters in front of keyword arguments as long as they are not positional, such as you might have a function that takes a default value for some reason, and that can be of type integer, but this will have to be referred to by its name. So here we'd have to type in default equals 20. And then this syntax will work just fine. If we were to print that default, you'll see that it will work. But we cannot have this after the keyword arguments. And of course, we cannot refer to this via its position, because the args is already absorbing everything up until that point. So in this case, if we do not pass in the keyword argument for default, we're going to get an error because it cannot find the value that should be inserted inside here. And again, for both of these, you can use any name you want. This can even be something called items. All that defines arguments and keyword arguments is the leading asterisk for arguments and the double leading asterisks for keyword arguments. Sometimes in Python, you're going to notice that some functions are going to have asterisks and slashes as part of the function signature. One example will be a function that looks like this. It's going to have a variable of type string, and then a slash, and then another variable, and then an asterisk, and then another variable. But what does it all mean? So to get started, we're going to be covering what the slash does. So here we can type in def func, and here we're going to have a variable, which will be called variable A of type string, and then we will add a slash and variable B of type string. And this will return none. Then we will print variable A and variable B. So here we added a slash in between these two variables. At the moment, this is a positional argument, and what the slash does is force it to stay that way. That means that we will never be able to pass variable A as a keyword argument. So to call this function, we would type in func, we would pass in A and B for variable B. This would be the correct way to call it, and that will work just fine if we run the program. But if we ever wanted to type in variable A equals A and variable B equals B, this line of code would not be accepted because we told Python that everything in front of the slash must be passed in as a positional argument. So this will raise a type error, and it will even tell you that our function got some positional only arguments passed as keyword arguments, and then it will point out variable A. Even if we did not have variable B, everything in front of that slash cannot be passed in as a keyword argument. It must be passed in as a positional argument for this to actually work. And in general, you might see this in places where a parameter name is too long, or for older code where they recently updated the parameter names. Because in the past, they might have had a name that was a very long variable name, such as that. And of course, you would not want the user to pass in very long variable name, because this is insane. But even if they allowed you to do this, later on, they might have updated their code, which means in a newer version of Python, this might have changed to something such as short var. And that also means that if you use a more recent version of Python and you refer to it via its old name, this is going to raise an exception because that keyword argument does not exist. So by forcing this to be positional only, you can guarantee that the user will not run into issues because no matter what name you put here, you'll know that they always passed it in as a positional argument. So this can easily be anything we want, such as very long name, and the function will work exactly the same way. Now going back to our original function, anything that comes after the slash can be passed in as either a positional argument or as a keyword argument. You're free to choose which one you want to use. So of course, var b can equal the string of b, or you can just pass it in as a positional argument. But what about the asterisk? Well, if we were to replace the slash with an asterisk, you'll notice that we will get some syntax highlighting, and that's because what the asterisk does is force everything that comes after it to be passed in as a keyword argument. So now we cannot pass this in as a positional argument anymore. This must be a keyword argument. So var b is going to equal var b. So really it just does the opposite of the slash, because this must be passed in as a keyword argument, while the first one can be either. And it's also worth mentioning that you can use these in combination, which means we can do var a slash var b asterisk var c of type string, and that will work just fine. Of course, we might want to print variable c so that we use it, and the same rules apply. Everything in front of the slash must be positional. Everything in between the asterisk and the slash can be either positional or a keyword argument, and everything after the asterisk must be a keyword argument. So here we have two ways of calling this. The first one is as follows: A, B, and var C will equal C. Or we can also do it like this: var B equals B, and so on. The middle one can be both, or the one that's in between these two symbols can be either one. So that was what the slash and the asterisk does in a function signature. You might not use it that often, but in a lot of documentation, you'll see it being used, so it's definitely good to know about. It's finally time we try to code another Python project. And this time we're going to be coding a very simple chatbot. Later on in this course, we will make it more advanced, but for now, we're going to continue with keeping these projects quite simple. So to get started, we're going to import system, and we are going to import from datetime, date and time. Now, the very first function we're going to create for this bot is a get response function, which will take some user input, and that will just be some text, and it will return to us some text. So we're inserting a string, and based on the contents of that string, we're going to get another string back. And the very first thing we want to do inside here is lower that text. So we're going to type in text.lower, because once again, Python is case sensitive, which means if the user enters hello and we're checking for hello, this will return false, which is not what we want, because we want to be able to recognize hello in both cases, whether it's uppercase or lowercase. So making sure that the text is lowered just makes everything much easier. And for the rest, we're just going to use some simple if-else logic. So if the lowered text is in this list of greetings, such as hello, hi, and hey, then we're going to return hey there. Elif, how are you? In lowered, then we will return I'm good, thanks. And I did not mention this in the lecture where we covered returns, but you can have multiple returns in a single function. So based on some condition, you might have a different response as a return. Elif, we're going to check that if your name is in lowered, then we will return my name is bot, because it's a chatbot with a very creative name. And using this in keyword just performs a membership check, which means that if your name is present at any point in the text that the user enters, this will evaluate to true. And the goal is to keep this quite simple so that when the user types something, it can be easy to recognize. If we were to type in what is your name, the user will probably never type this, because they might even have a variation such as what's your name, and so on. And that just becomes too confusing and very hard to cover all the cases for if we take this approach. So all we're going to do is enter your name in lowered. But moving on, if the user mentions time in their text, then we're going to give them back the current time, which will be of type datetime, and that will equal datetime.now. And we will return the f string of the time is and the current time formatted with these date time specifiers. So %hour and %minute. Elif, the text is in bye, see you, and goodbye, we will return it was nice talking to you. And I think those are enough cases for our temporary chatbot. So we're going to end this by adding an else statement, which will just return this string in case the user inputs something that we did not cover. And here we'll just type in, sorry, I do not understand, and we will insert the text. And that's all we're going to do with our getResponse function. Now we can create a while true loop so we can interact with our bot endlessly and take some user input of type string, which will equal the input of you. Next, if the user input is equal to exit, then we will print that the bot says, it was a pleasure talking to you. And we will call system.exit. Otherwise, we're going to get the bot response, which is going to be of type string, and that's going to equal get response for the user input. Then we can print that the bot said the bot response. And that's the entire project. Now, when we run this, we will be greeted with you. So here I'm going to type in hello, and the bot will say, hey there. Then we can type in something such as, do you know what time it is? And it will give us our current time because it was able to locate time in our string. Otherwise, we can ask, how are you? And the bot will say, I'm good, thanks. And if we type in something a bit random, such as all of this text, the bot will be able to tell us immediately that it does not understand. So I'm just going to say goodbye because it was nice talking to you. And I'm going to type in exit. And that will terminate the program. Anyway, that concludes this chatbot. For homework, I recommend adding some more phrases, add your own functionality, play around with this, and see what you can do with this chatbot. One thing that would be very nice to have is a function that greets the user and asks them for their name. So instead of just starting the program with you, it would be nice to have a welcome message that says, hello, I am bot, what's your name? And then you would be prompted to enter your name. But otherwise, let's continue learning more about Python in the next section of this course. In Python, there are many things that can go wrong when you are creating a program. Logic errors, mathematical errors, syntax errors, etc., etc. In this section, we'll be looking at how we can handle them properly. First of all, I want to cover more about how we can take user input and the dangers that come along with taking user input. So here we're going to import system and we're going to create a simple calculator. So the total of type integer is going to equal 0. Then while true, we're going to take some user input of type string, and the input is going to equal enter a number. Now, if the user input is equal to 0, we're going to print that the total is the total. And we're going to exit the loop by exiting our program. But if we do not exit the program, we want to add to the total. So we're just going to type in total plus equals the integer of the user input. So let's test this out by running the script, and we can enter 10, 20, 56, and 0. And that would work perfectly fine. It added all those numbers together and exited the program as soon as we entered 0. So it looks like it works perfectly fine, right? Well, it does. Until you enter something that is not a number. And you might be thinking, who on earth would enter something that's not a number in a calculator app? Well, this might be surprising, but a lot of users will usually try to perform the most illogical operations with your application. And as a professional programmer, your job is to always assume the worst case scenario. In other words, you need to always keep in mind that everything that can possibly go wrong will probably go wrong. Never underestimate your users. And another example of how this could go wrong, I mean, we told the user they could enter a number, but what happens if they enter 1.5? That cannot be converted to an integer because it's a float, obviously. So that's going to give us another exception. Anyway, taking user input isn't always that simple because the user can literally enter whatever they like. So in this section of the course, I'm going to be teaching you how you can handle all of these worst case scenarios properly, so that even if the program raises an exception, we'll be able to handle that and continue using the program without having it crash. Up until this point of the course, I've been using a super powerful feature that we have in PyCharm that allows us to rename functions or rename variables throughout our project with one simple edit. And as for an example, I created this function that has a variable name that is used throughout it a lot. Now, of course, if you want to rename this at any point, such as renaming it to first name, it's going to be hell to change each and every one of these occurrences. So what we're going to do instead is highlight this, right click and go to refactor. And then at the top, there's going to be something called rename, and it's going to show you the shortcut for that. If you tap on that, you can now rename this to whatever you want. It can even be first name, and it will replace all the occurrences in the appropriate block of code. And I actually have a personal shortcut for this, which is Command Shift plus R. And like that, I can change that to whatever I want. It can even be fname. And it was as simple as that to rename it, because sometimes you're going to create a name that might not make too much sense at first, such as var, and you're going to wish you named it something else, because this isn't really too descriptive as of what the user should pass in. So of course, we would rather have something such as name. Now to specify the shortcut for this, go to your settings, go to the key map, and type in rename. And inside here, you'll find a section called refactor and rename. And these are the shortcuts you can use for renaming it. I recommend you set your own. I find it very comfortable to use Shift Command plus R, so that's what I'm keeping. And this also works for function names and actually any user-defined name that you have. So for get stats, we can also rename this to show stats, if you find that more descriptive, and it will rename all the occurrences in the appropriate section of your code. So here we have show stats and show stats. So that's just a very useful shortcut I thought you guys should know before we move on with this course. In the previous lecture, we tried to take some user input and found out that it went horribly wrong when the user entered something that wasn't a number. Now it's time we learn how we can handle this appropriately in Python using the try and the except block. So this is how the syntax is going to look like. First, you have a try block. Inside here, you insert the code that's quite dangerous and that might raise an exception or that might cause the program to crash. So you're trying to execute that code. And then you have an except block. And this block gives us an opportunity to solve that issue before moving on with the program. But let's put this into practice. Suppose you're performing some sort of mathematical operation. So here's a result of type float, and we're dividing 10 by 0. And in programming, if you divide anything by 0, usually computers are not happy about that. So that's going to raise an exception. But here we're going to just put it in the try block since it's some dangerous code. And we're going to accept this exception as E. So this will catch all the exceptions, and this will give us back the information regarding that exception. And here we can print error, and I'll make an F string out of this and pass in the error. So that when we run this, you'll see that the error is going to be a division by 0 error. If we were to just perform this action outside of the try and except block, so if we were to put that there and remove all of this, we would get this 0 division error. So we got the same error, except this time, this crashed our program. But using this try and except block, we were able to execute code after that exception. So here all we did is log that error by saying this was the error and printing it to the console. But thanks to this approach, we could also use some code after. So we could even type in done, and done will be executed. So here we managed to handle that error. All we did in reality is just print a message, but you can put literally any code you want inside the except block, even other dangerous code. So keep that in mind when you are inserting code here, that just because it's in an except block doesn't mean you can't raise an exception inside here, because if you try to divide 10 by 0 in your except block, you will get another 0 division error. Now, in general, it's considered a bad practice to use this base exception for everything because it just covers too many cases. And in programming, in general, we want to be as specific as possible when dealing with exceptions. And Python has many different types of exceptions that we can use. So let's try creating a different example. And in this new example, I'm going to show you how we can be more specific with the exceptions we are handling. So here we're going to create a while true loop. And what I'm going to try to do is get some user input of type string. And the input is going to say, enter a number. Now what we're going to do here is print an F string that contains 10 divided by the user input, which will equal 10 divided by the float
of the user input. So there we have some sort of silly operation that uses the user input to divide something. But of course, there's many things that can go wrong. If the user inputs 0, for example, you can't divide by 0 because that will raise a 0 division error. Otherwise, if they input some sort of letter, that's also going to be a problem. You can't convert a letter to a float. So there are a lot of things that can go wrong here. But what we're going to start with is the 0 division error. So as you can see, we can insert that as an exception, which means Python will only handle this exception if we run into it. So now we are being much more specific, and you don't always have to say as E. This is only if you want to get the information back from the error. In this case, we don't care about that, so we're just going to say except 0 division error, and we will print you cannot divide by 0. So now if we run this, we can type in 10. 10 will work fine, but if we enter 0, it's not going to crash the program this time. It's just going to tell us you cannot divide by 0, because that's what we defined to happen inside the 0 division error block. But once again, if we type in a letter such as A, it's going to raise an exception and it's going to crash the program. So what are we supposed to do now? Well, once you see this error in the console, you'll notice that this was a value error, which means we entered a value into float that was incompatible. And to handle this, what we're going to do is add another except block. So here we'll type in value error, and all we need to do is type in please enter a valid number. And now every time the value error is raised, this line of code will be executed instead of what we had earlier. So at this point, we can try running our program once again. If we enter 0, it will say you cannot divide by 0, but if we enter something such as some text, this time it will tell us to please enter a valid number. And in case anything else goes wrong, you can always use except exception. Once again, exception just covers everything, so that will cover value errors, 0 division errors, and anything that you have not caught just yet. In general, it's just considered to be too broad of a clause because again, it just covers everything. And usually when you're not so specific, it can be a problem with handling specific scenarios. So I always recommend you start with being more specific and then as a last resort, use exception to handle everything else. Something else went wrong. And then you can say as E. And you can insert E inside there. So that will give you some extra context on what went wrong during the execution of your program. And finally, let's go back to the original calculator app that we created not so long ago, where we had a total, which this time will be of type float because that makes much more sense, which will equal 0. Then while true, we'll take the user input of type string, which will equal an input of enter a number. Since this will always be a string, this is not considered a dangerous operation, so we can just leave it outside in the open like this. Now, if the user input is equal to 0, we're going to print the total or the f string of the total with the total, and we're going to call system.exit. And that should import it at the top. But moving on, we're going to try to update the total with the float of the user input. Now that's a dangerous operation because once again, users can enter literally anything they want. There's always going to be a huge chance that someone will enter something that you do not expect. So never take user input lightly. And that's why I'm wrapping it in a try and except block. And of course, the major error we're going to have here is a value error. Because if the user types in something such as hello or adds some sort of value that does not make sense to float, this will be triggered. So here we're going to print, please enter a valid number. And this is really the only exception they should run into when they are trying to add numbers. There's not much else that can go wrong with float. So let's give our program a run. Here we can type in 10, 20, 0, and 0 exits it, and I forgot about that, so let's try that again. 10, A, and there it says to add a valid number, 9, minus 10,
100, and 0. And what we will get as an output is 109. But this time entering a value that does not make sense did not crash our program. In the previous lesson, we learned about the basics of exception handling in Python. But there are a couple of more keywords that we can use with try and except blocks, which I will be covering in this lesson. And these keywords are else and finally. So let's take a look at how we can use this. And in this example, I'm going to create something called user input, which this time is going to be a hard-coded value. So I'm not going to take input. And here we're just going to enter something such as 10 to begin with. We will change that later, but for now, it's just going to equal the string value of 10. Now, what we're going to try to do here is get a result, which will be of type float. And that's going to equal 1 divided by the float of the user input. So once again, we're trying to perform an operation that can raise an exception because the user input can literally be anything. It can be a letter, it can be the number 0, and in any of those cases, this will raise an exception. Then we can print that 1 divided by the user input is going to equal the result, if everything goes smoothly, of course. But here we have two things that can go wrong. Of course, one being the value error in case the user enters a letter or something. So here we should handle that by saying you cannot use user input as a value. And the other one being the 0 division error. And here I'm going to copy and paste in, don't be silly, you cannot divide by 0. So let's test this by starting off with the user input of ABC. If we run that, it's going to say that we cannot use ABC as a value. Otherwise, if we enter 0, it will tell us, don't be silly, you cannot divide by 0. But if we change this to 10, it's going to work just fine. So that's what we covered in the previous lesson. But moving on, we have that infamous else block. And once again, you will rarely see this being used. In most cases, it's recommended that you don't touch this because it's really hard to read and most people will not understand what this is without having to read your comments or documentation on this block of code. So in general, this is considered a waste of time, but again, you might see this being used by some inexperienced developers, so it's really good to know how it works in case you run into it. Anyway, the else block once again works as a success listener, which means if all of this code is executed successfully, the else block will execute whatever we put in this block of code. So we can say, success, there were no exceptions encountered. And if we run this with the value of 10 and our code successfully runs, you'll see that this block will be executed. Otherwise, if we have ABC as a user input, the else block will not be triggered because the code failed at this line of code, meaning we did not complete everything in the try block. And finally, we have something called finally. And this block of code will be executed regardless of what happens. So here we can type in, I am always executed. And I'll even add the word finally in front. So regardless of the user input, we're going to have the finally block executed. As you can see, you cannot use ABC as a value, but the finally block was always executed regardless. If we add 10, that's a valid operation, so we'll get the else block executed and the finally block executed. So finally will always be executed no matter what happens, even if we run into an exception. So for example, if we remove the value error, this time when we run the program, ABC should raise the value error exception, which means theoretically the program should crash. But before it crashes, it's still going to execute the finally block. So finally will be executed no matter what happens, even if we encounter an error that crashes our program. Errors are a natural part of programming, and the more comfortable you get with them, the better at programming you actually become. In other words, if you know about everything that can possibly go wrong, then you will know exactly how robust your program really is. Anyway, there are going to be situations where you're going to want to raise an exception manually,
because Python's not going to understand that something went wrong in that situation, which means it's up to us to trigger it manually. And in Python, to raise an exception manually, we need to use the raise keyword. So let's create an example using it. And in this example, we're going to create a function called checkAge. And the age is going to be of type integer, and it's going to return to us a Boolean. So first of all, we're going to check if the age is less than 0, then we're going to raise a value error, because that's not a valid age. At least not in my book. If you are less than 0 years old, I don't know what that means. I honestly don't know what that means. So I'm going to raise a value error. Elif the age is more than equal to 21, we will print you are old enough to do whatever activity it is. And we will return true. Else we will print you are not old enough. And we will return false. So now we have a function that can manually raise an error in case we provide a value that doesn't make sense. And I just realized I didn't mention this, but the syntax goes as follows. Raise the kind of error you want to raise, and in parentheses, you can specify the message for that. And it's not required that you specify a message. Usually it's just good because it gives whoever is working with this extra context on what went wrong. But now we can test this out by checking the age for someone who's 30 years old. Whoever that is old enough. If we change this to 10 years old, they are not old enough. And if we change this to minus 10 years old, that's not even a valid age. So we're going to raise a value error, which is exactly what we want in this scenario. And again, you also have the option to raise a general exception just by using the exception type. And this one is a general exception. I do not recommend you use this too often because it's very broad. It can mean anything. Try to be as specific as possible when you are using exceptions. But when we run this, we will get the exception raised and you will get the message as an output. Also, if you're curious about more of the exceptions that you can handle in Python, then check out the link that I've included in the resources section of this lecture. This will take you to the Python documentation where you can read more about the built-in errors that come with Python. But we will be running into a lot of exceptions throughout this course, and just keep in mind that running into exceptions is a natural part of programming. The more problems you run into, the better a developer you're going to be. The difference between a beginner and a professional is that a professional has run into practically every error that has ever existed, meaning that if something ever goes wrong in a program, they're going to be able to identify that error and fix it immediately because they know exactly what it was due to their experience with all these errors. So always look at it as a learning experience if you run into an exception. And my professional advice for every new exception you run into is to do a quick Google search. You need to get used to using Google. Even developers who have 20 years or 30 years of experience rely on Google or on the internet to find out more about the exception that they are encountering. What do you do when you encounter an error that you weren't expecting? Or even worse, how do you handle errors that you were never expecting in the first place? Well, there are a few ways to deal with potential errors. And in general, when you're using an app and it crashes or something goes wrong, it sends a report to the developers of the app with all the information leading up to that crash. And then the developers try to fix it. In general, it's going to be really hard to foresee all the things that can go wrong with your program as it grows in complexity. So what we're going to do here is create a default way of handling all the exceptions that we do not expect. So for this example, I'm going to create a while true loop, and we're going to take some user input of type string, which is going to equal the input of enter a number. Then what we're going to try to do here is convert that input into a float. So here we can type in number of type float is going to equal the float of the user input. And if that works, we're just going to type in that you entered and we're going to pass in that number. So at this point, we know we're trying to perform a dangerous operation such as converting user input into a float. And while this is a very simple example, and we already know by now that this would probably raise a value error, sometimes it's not going to be that simple and you will have no idea what it can potentially raise. And if you don't want your program to crash, the easiest way to fix this is to use accept exception as E. And inside here, we can type in something such as program encountered a new exception. Something that we did not expect. We can print also the error message, which is going to be E. And we can also print the type of error message. So type, and inside here, we'll type in type of E. And I'm actually going to switch these two around. But now watch what happens when we run our script. Here we can try to enter a number. If we enter 10, it will say we entered 10. And as you can see by the decimal, it successfully converted it to a float. If we do 10.5, that works as well. But if we type in 15 as text, we're going to run into that value error because a string cannot be converted into a float. So our except block, which handles absolutely everything else, is going to tell us that it encountered a new exception, the type of exception, which is a value error, and the error message could not convert string to float for the current value. And then of course we can continue with our program and everything else will work smoothly. But this information is what usually gets sent to the developer when you are using an application from the App Store or some sort of program that you downloaded from the internet. And once you find out what error you encounter, of course you can add it to your program and do your best to handle it so that the next time the user encounters this error, you'll have a more personalized way of handling it. So here we can insert value error and we can print that the value you entered, and inside quotation marks, we'll do this, and we'll insert the number, is invalid. And here we're actually getting a very good message that the number can be undefined, and that's because I meant to enter the user input. Because it's true, if we were to enter the number inside the except block, there's a chance it doesn't exist because this might not exist in the first place if this raises an exception. So it's a very good error message. Anyway, with this, we were able to find the exception without crashing the program, so it didn't disturb the user's experience. But we were still able to get that information so that we could later fix that issue and then update our app so that the next time they run into that issue, they actually get a personalized error message that tells them exactly what happened. So the next time we run this, we can enter a number, we can enter ABC, and this time we're actually going to get the personalized message back. The value you entered, ABC, is invalid. And that should work for literally anything you enter that's invalid, such as 0.01. That's not a real decimal in terms of Python code, so we're not going to be able to convert that into a float. Now that we have a good understanding on how exceptions work in Python, let's try to create a small project that uses them. So what we're going to be creating here is a project that checks that what the user inputs is letters only, which means if there's a number or a symbol, the program is going to tell us that, hey, that is not letters only. There's some symbols and there's some numbers, which of course are not letters. So to get started, we're going to import a module called string, and we're going to get started by creating a function called isLettersOnly. And this will return none, because all it's going to do is print a message telling us whether it is letters only or not. Optionally, of course, you can also return a Boolean and use this later. But in this example, we're just going to print the message inside this function. And here we're going to create an alphabet of type string, which is going to use this string module, and it's going to take the ASCII letters plus the empty space, because we want to consider empty spaces as part of the alphabet in the strings that we insert. And I actually forgot to add the text that we want to scan. Anyway, real quick, I want to print this alphabet so you guys can see what it is. And if we type in isLettersOnly and pass in hello, you'll see that what string.ASCII letters does is give us the string of the whole English alphabet back. And that's just much more convenient than typing it all out by hand, because that can take ages and you might even miss a letter. So I just prefer to use the string module for that. So string.ASCII-letters. And going back to our function, the next thing we want to do is check for each character in the text. And here we want to check if the character is not in the alphabet, then we're going to raise a value error. Text can only contain letters from the alphabet. Otherwise, if it passes this test, we can print that the text is letters only. And that's all we had to do inside this function. Next, we're going to create a main entry point to our program. And you're going to see me doing this a lot in Python. This is where we will insert all the code that we want to run. And to define a main entry point, by convention, you would usually just type in def main, and this will return none. In Python, it's not required you have a main entry point, but you'll see this being used in a lot of programs. And as a personal preference, I enjoy using it as well because I think it's very clean and it's a very good place to insert the code that you want to execute. So with this main entry point, we're going to insert while true, and I'll make some space. And what we want to do inside here is try to get the user input of type string, which will equal the input of check text. Then we can use our function immediately under. And as always, since we're using user input, this can be considered a dangerous line of code. So we're going to insert that in the try block. And we're going to insert the user input. And to handle this properly, we know that the main exception we can encounter is a value error. So here we can print, please only enter English letters. And for anything else that happens, we're going to accept exception as E. And we're going to print encountered an unknown exception with the error message. But usually you would log this somewhere and it would be sent back to the developer. And I actually want to also log the type of message. So we'll also add type E. But with all that being done, we can just use our main function to run the code and test it out. So now when we run this, we can enter some text such as hello world. And hello world is letters only. Good job. But if we do hello 1, 2, 3, it's going to ask us to only enter English letters. And that concludes this mini error handling project. But as always, play around with Python and try to encounter as many errors as you can, because that's what's going to make you a professional developer. In this lecture, we will be learning about what modules are in Python. Modules are a single file containing Python code. And a module can define functions, classes, and variables, and is meant to be imported and used in other Python scripts. For example, I've been using a lot of modules up until this point, such as the time module. This is functionality that comes from a different Python file. And if you either hold Command or Control plus click on Windows, you can tap on that and you'll see it's just a regular Python script with some other functionality. And to use it, we just need to refer to the module name and the function that we want to use. So if we want the program to sleep, we would use sleep and pass in the amount of seconds. So time is nothing but a Python file that contains functions, variables, classes, etc., etc. that help with time-related operations. But as our programs grow in complexity, it's going to start making sense to create our own modules. So to create a module, go to your project folder, and right now make sure you are in your project folder, and hold Command plus N or Control plus N to create a new file. And here you want to tap on Python file. And then we need to give our module a name. And in this example, we can call it greetings. So this will be the greetings module. And up until this point, we've been doing everything in main.py, which is our main file. So usually that's where you would run code and import all the modules you need. Anyway, let's define some functionality inside this module so we can import it into our main script. Now for this example, I'm going to import from typing the final type. And this is just another type annotation we can use for constants to tell PyCharm and other static type checkers that what we're creating now is a constant. So earlier I showed you that you can create a constant using a naming convention, which is just uppercase characters, but we can also define it to be of type final and the data type that we want it to be. So this is a constant of my name, and we're telling Python that this is constant with the final type. Then we'll also put a version number for this script. So final of type integer, and that's going to equal 1. Then I want to include also one function, which is going to be greet, because this is a greetings module. So we're going to want to have some functionality that does something related to that name. And here we can enter a name of type string and return none. And we will print hello name. And that's all the functionality this module is going to contain for now. So let's go back to our main.py file and try to use it. So let's get rid of all of that and let's import greetings. And with that, we can actually use whatever's inside here. We can type in greetings.greet and we can pass in a name such as Mario. Or if we want to print the version number or the author name, we can do that by typing in greetings and tapping on author. Now, if we were to run this script, we would get hello Mario and the author's name. And suppose the name is too long. You also have the option to give it an alias. For example, you can import greetings as G. Now you can replace all of these occurrences with G and it's going to treat it as the same thing. Now it's much shorter and still performs the same actions. Also, to avoid clutter, you also have the option to make only certain functionality visible by importing those names directly. So imagine that all we want to get from this greetings module is this greeting functionality and that we don't care about the author. Well, one thing we can do is type in from greetings import greet. And this will be ultra specific with what we are importing. Now we're not going to have the option to use author anymore, but we are going to have the option to use greet directly without dot notation, because we explicitly said we want to get that functionality from the script. So now when we run it, we're going to get the output of hello Mario. And it's important to mention that just because you import specific functionality doesn't mean you're saving on memory or performance. Some people think that by importing only specific parts of a module, that they are saving on memory because they're not loading the rest of it. But as soon as you import from a module, it runs the entire script so that it can actually give you back the information you are searching for. So whether you import only one piece of functionality or the entire script makes no difference in Python. This syntax is just to be specific so that we don't have to refer to dot notation all the time when we are importing that module. And we actually have one more option for importing, and this is the star import. So from greetings, import star. And what that does is import everything into this namespace from that module, which means now we can use greet with Luigi. We can even print the author and we can print the version directly because we imported everything from that module into this script. And if we were to run this, we would get the following output. Hello Luigi, my name, and the version number. But this does come at a cost, which I will be explaining in the next lecture. Previously, I mentioned that using star imports can be quite dangerous when we are programming in Python. And the main reason we never import using that star syntax is because it often interferes with other imports. In small projects or simple scripts, it shouldn't be a problem. But as soon as you start building anything more professional or complex, you will start to run into conflicting names immediately, which will lead to funky behavior in your program. But let me show you an example. So right now in our script, we have a main.py file, which is empty, and a mytime.py file, which is user defined. And what I'm going to do inside here is paste in this functionality. So all it does is return a string that says fake time and a date that says fake date. These are just examples of functions that might be in my custom module. Anyway, let's go to our main.py file and try using the star import. So from myTime import everything. And just like that, we can use that functionality quite easily. Print the dates and print the time, so that when we run this, we're going to get these outputs back. And one seems to have an exclamation mark, so I'm just going to remove that and go back to our main.py file. But now let's import some other functionality from a different module using the same star import. So from time import asterisk. Now watch what happens when we run this script. We get different outputs because one of these modules also happens to contain the time function, which means whichever one imports it last is going to be the one that gets used. If we were to switch these around, we would get different behavior. So fake date and fake time. But let's switch that back, and that's going to give us the functionality from the time import. And this is a scenario you never want to run into. Import order should never matter because that's going to lead to funky behavior. So the moral of this story is, if you have a single module that you're importing, chances are it's not going to be a dangerous operation, because in some cases, maybe you're doing a lot of math operations. So you might type in from math import everything, because the math module contains a lot of helper functions. For example, if we type in import math and we just use dot notation, you'll see it contains a lot of functions that help you with math. So you might not want to use dot notation all the time if that's all you're doing in a script. Then it's perfectly acceptable to import everything from math. But as soon as you start using more than one import, it starts to become dangerous because the star import will override whatever you imported from other modules earlier. In a previous lecture, I told you that we're going to start using a main entry point to execute our code in our scripts. And something else that we're going to start using from now on is called if name is equal to main. And throughout the rest of this course, you will see me using both of these in combination continuously. But let me explain what if name is equal to main actually does. And to explain it, I need to create another module. So this one is going to be called connections. And inside here, we're going to import time and create a function called connect, which will return none. And here we'll type in connecting to internet. We'll add a delay of 1 second, and then we will print that we are connected, just to simulate that we're connecting to the internet. Now, very often when you are creating a module, you're going to want to test that module as you create it. Just as when we write code in main.py, we're going to want to try to execute the code in this module before we actually import it. For example, if you want to actually connect to the internet, we can try using the connect function that we just created, and then you can right-click on this file and tap on Run Connections. And we'll see that it works perfectly fine. It connected to the internet and did everything it was supposed to. So now let's go to our main.py file and get rid of all of this and import our connections. Then we can type in connections.connect. So we're going to use the same functionality in our main.py file. And actually, before we run it, it's important to note that if you use your shortcut for running the script now, it's going to run the connections.py file because that's the one that we currently have selected for running. So what we should do now is change it to the main.py file. So I'll just tap on main and run it. And it will try to connect to the internet, and then it will try to connect to the internet again. And that was not the intended behavior of our script. We only called it once here, so why did it print it twice? Well, the reason behind that is that once you import a script, it runs all the code inside the script. So all of this was executed when we imported the connections. So importing connections executed all of this. And then we called connect after that, so we executed that functionality again. So one thing you'll see being used in all modules is the if name is equal to main check. And to create it, all you need to do is type in if __ name is equal to the string of main and insert connect inside it. And all this does is check if this script is being run directly, meaning that we either right click on it and run it, use the shortcut directly on this script, or tap on the green arrow. It's checking that this script is being run directly, and the name of any script that you run will evaluate to main. So the benefit of doing this is that if we were to import connections, if name is equal to main will evaluate to false, because connections is not being run directly, it's being imported. So this will evaluate to false and connect will not run, which means now if we were to run our main.py file, we're only going to connect to the internet once. So that was the main benefit of using if name is equal to main. It prevents us from running code in a module that we did not mean to run. And it also allows us to continuously test code inside this module without having to worry about it being executed when we import it. Also in PyCharm, it gives you this nice little arrow that allows you to run it directly. So now we are running it inside the module. Anyway, going back to our main.py file, it doesn't matter what script I'm in, you're always going to see me using if name is equal to main. It's just a good habit to have because it doesn't matter where you are in your program. It will always provide that safety mechanism so that you don't import and run functionality that you're not supposed to run. Another benefit of using if name is equal to main is that it tells developers which part of the script was actually made to be run. So in this example, we have a green arrow, we have the if name is equal to main check, so everything inside here was meant to be executed. And we can run this by tapping on run, and that same functionality will be executed. But yeah, going back to what I said earlier, you're going to see this being used a lot in combination with the main entry point that I will be creating from now on. So in all my programs, I'm going to have both the main entry point plus this check over here, just to ensure that we're running this in the correct place. Earlier in this section of the course, we learned about modules. Now it's time we learn about packages. And a package is just a collection of modules in a directory. It also contains an init.py file to indicate that it's a package. And this init.py file can either be empty or it can define some initialization code for that package. And we will talk about initializers later on in this course, but just keep in mind that if you want to create a package, it must contain this file. And first of all, when you create a new project, Python gives you a lot of packages to work with. And you can explore these packages by tapping on Python 3.12. You'll see there's a lot of packages in here, such as the email package that contains some modules and some other packages that we can use in our program. But we're not going to be touching that stuff in this lecture, because in this lecture, I want to show you how to create your very own package. So to get started, we're going to create a directory. And you might notice that there's an option also to create a Python package. In general, if you want to create a Python package, go for it. But I want to show you how to do it from scratch. So we're going to tap on the directory. And we need to give this a name, which I will call my package. And at the moment, it's just an empty folder. And we can insert some modules in there, such as, let's say, the internet module, and maybe we will have a connection module or a website module. So these will be two different Py files that we will have inside this package. At the moment, it is not considered a package because it's missing that init file. So what we have to do inside here, and I'm currently using the shortcut Command+N. On Windows, it's probably going to be Control+N to create these new Python files. But what we have to do inside here is create that init file. And it's going to look like this, __init__.py. And this file is going to convert this folder into a package. And you will probably also notice a small circle inside of it if you're coding in PyCharm. And once again, this file is required to make Python consider this folder a package. Anyway, every time you import functionality from your package, this file is going to be run. So what we can do here is print that the init was called. And you'll see what this does as soon as we import from our package. But before we move on, let's give our modules some functionality. The internet module will have a function called connect, which returns none, and all it does is print connected, which is super convenient. And for a website, we'll have a function called load, which takes a website URL. And maybe it makes more sense just to type in URL instead of website. And then we can just print that we loaded the website or the URL. So now we have some basic functionality inside each one of these modules. So let's go to our main.py file and look at how we can import it from this package. So to import from a package, we need to use the from import syntax. So from my package, we can choose to import some modules, such as the website module and the internet module. And that's the syntax we should use for importing from a package. And just like that, we can refer to internet.connect, and we can also refer to website.load. And inside here, we can do something such as www.google.com. And we can pretend that's the functionality that we want to use. Now watch what happens when we run this script. The initializer will have been called, then we can use the functionality as I mentioned earlier. And that practically covers everything that you need to know about packages for now. In Python, it's going to be quite common to hear the term library being used. And libraries are actually super similar to packages. So a lot of people might accidentally use these interchangeably. It's not the biggest mistake in the world, but it's still good to know what the difference is. So earlier, I showed you that in external libraries, we have this Python 3.12 file or a folder. And I showed you that email was a package. But to be more technical, this is a library, because a library refers to a collection of packages and modules that can be used to perform specific tasks. And all that's saying is practically that here we have a package called email that contains other packages that help with performing email related operations. And that's practically the only difference between a library and a package. So to be very specific, email is a library and mime is a package inside this email library. And we can even create our own library from scratch. So right now we have a package here, but we can create a directory called library, and that should be on the outside. So I'll drag it there and we'll put my package inside here. So now we have a library with a package inside, and we can even define some other modules, such as, let's say, helper module. So this library just contains packages and modules that can help achieve a certain task, while a package will only contain a collection of modules. And an easy way to look at it is that a module can be seen as a book in a library. A package can be seen as a section in a library, while the library itself is just the entire library. So this contains the specific functionality, this groups that functionality, and this just contains different sections of both of these. Let's build another project in Python, and this one is going to be a website status project. So we're going to enter a URL, and it's going to give us a lot of information back regarding that URL, whether the website is online, whether it has some links, whether the response is okay. We're going to get a lot of information back regarding the website URL and its status. And we're going to be doing this using an external library. So what we have to do here is open up the terminal, and the shortcut should be Command T or Control T on your computer. Otherwise, as you can see in the left-hand corner, we have a terminal button here. And what we need to do is type in pip install requests, which is a library which will help simplify the task of getting this information from that URL. Anyway, once you have installed that, you can close the terminal, and then you can get started with the imports. So first of all, we're going to import requests. And then from requests, we're also going to import a specific type called the response type. Next, we're going to create a function that gets a response. So get response, and that's going to take a URL of type string, and it's going to return to us a response. And here, all we need to do is return requests.get and pass in the URL. So this will give us back a response object, which will contain all the necessary information regarding the website. And below that, we're going to create a function called show response info. And that's going to take a response of type response. And it's not going to return anything because we're just going to bloat it with a bunch of print statements. For example, here we can print status, and we're going to use the response.status code. And then I'm just going to duplicate this, keep this empty, and duplicate this line, let's say maybe 4 more times. So we should have 6 of these in total. And the reason I did that is just to make it a bit more simple. So now we can type in OK and check whether the response is OK. Then I want to check for the links, and here we can check response.links and also the encoding of the website. We can also check if it's a redirect. And it's okay if you don't understand what this information is. I'm just showing you how we can get the information back from the website using the requests library. So here we'll type in is redirect. And also, as always, you can hover over whatever method you're using to see the documentation and understand a little bit more about what you are using. And finally, at the bottom, we have is permanent redirect. And that's exactly going to be the same thing. So is permanent redirect. And that's everything we need to include inside this function. It's some very basic information regarding the response that we get back from the website. Moving on, below that, we're going to create our main entry point. And with our main entry point, we're also going to create this if name is equal to main check. I have a shortcut in PyCharm that allows me to create both of these at the same time. So don't worry if you don't get both of those. If you were to type in main into PyCharm, you'll see the same syntax highlighting, but it's not going to give you this part here. It's only going to give you this. And in case you're curious about how I did that, you can go to settings, and you need to search for something called live templates. And inside here, you can tap on Python, and there will be a section called main. And this is a whole different topic, but inside here, you can create some template text for each time you use the shortcut of main. It's going to insert this placeholder, which right now is the main entry point plus if name is equal to main. So at any point, if you need a break from Python, I absolutely recommend you look into live templates. It's not Python related, this is actually PyCharm related, but it can help speed up your workflow. Anyway, I'm going to be using that live template a lot, so every time I type in main, it's going to give me both of these. But moving on, we're going to create a website of type string, which is going to equal my website, https www.indently.io. Then we're going to try to get a response back from this website, so response of type response will equal get response with the website URL. And we want to show the response info for that response. And that's all we have to do to check for a website status. Now, if we tap on this green arrow, the program is going to send a request and wait for a response. Since the website is up and running, we're going to get a status code of 200, which means everything is working fine. And since the website's running smoothly, OK will be set to true. Then we'll get some other information such as the encoding, whether it's a redirect or whether it's a permanent redirect. And here I forgot the colon, so I'll fix that real quick. And as you can see, we got all of that information back. But now let's try with an endpoint that doesn't exist, such as indently.io. And here we can type in ABC. This does not exist on my website. So if we run that, it's going to give us a status code of 404, that page does not exist or could not be found. And it's not going to be okay because it doesn't exist, or it just wasn't able to find that. And just like that, we created a very simple website status checker. In Python, every object can be considered to be either truthy or falsy. The most obvious ones are the true and false Booleans. Obviously, true is truthy and false is falsy, but those Booleans are nothing but constants for both 1 and 0. So if we wanted to, we could also use 1 instead of true and 0 instead of false, because these both represent truthy and falsy values. And actually, it doesn't matter which number you use, as long as it's not 0, you can even use 2 or 3, and that would be considered to be truthy. So how do we know what else is considered truthy or falsy in Python? Well, let's take a look at a few examples as I explain more. At any moment, if you want to find out whether a value is truthy or falsy, you can just use the Boolean type with the parentheses to check the type that you are inserting. For example, if you want to check if an empty list is truthy or falsy, you can directly insert it inside the Boolean. And when you run this, you'll see that that will evaluate to false. So empty lists are considered falsy. But what about if we duplicate that and insert none? Well, none also evaluates to false. But as soon as we insert something such as the value of 200, that's going to evaluate to true because this is an actual value. And in general, you can consider anything that is empty or looks empty to be considered a falsy value. For example, you might have a dictionary that's empty, or a list that's empty, or a tuple that's empty, or you could even have an empty string. All of these are considered to be falsy values. And with all of that being kept in mind, pretend you have some users, and also suppose we want to do a Boolean check to make sure that we have users before performing some sort of operation. All you need to do is check if users. This will check that users actually has a value. So at any moment, if users is empty, or even set to none, or even an empty list, this will evaluate to false. So there we're checking if the users actually exist. Then we can perform this operation, which just gets the key and value pair for each key value pair in the users.items. And we will print the key and the value separated by a semicolon. So we will only perform this operation if we have users. Else we're going to print that there was no data found. No data found. Now let's run this, and what you should notice is a nice list of our users, because users was a truthy value. But as soon as we remove all the users, that's going to evaluate to false, printing no data found. So to sum this up, anything that contains a value can be considered to be truthy. Otherwise, if it's none, or false, or 0, these all represent falsy values, because 0 just doesn't contain anything, it's 0, false just represents 0, and none stands for nothing in Python. Otherwise, if anything contains a value, such as a list with one element, that's going to be considered truthy. Without the element, it's going to be considered falsy. So that was the concept of truthy and falsy in Python. In this lecture, I'm going to be teaching you how to perform operations, or actually mathematical operations, with floats appropriately, because in Python we have a little problem with floats that you should be aware of. And to keep it simple, they are just not as precise as they look, which means comparing them directly or performing operations with them directly is never really reliable if you want the precision. And an infamous example is if you were to print 0.1 plus 0.2 is equal to 0.3. Obviously that should be the case, but when you run it, you're going to get false back. So let's take a closer look at what's happening there by printing the string of, or the f string of, 0.1 plus 0.2 equals 0.1 plus 0.2. Now when we run this, you'll see that what we get back from those two numbers is a crazy decimal. And this is a whole different topic, but all you need to know here is that for floats to actually be efficient in programming, they use some hidden magic to store these numbers. Because obviously if you have a decimal such as 1/3, the decimal representation for 1/3 would be 0.33 to the infinite. And storing that would be practically impossible. It would take too much memory. So in programming, there's a lot of neat tricks that your computer is going to perform to make it more efficient. But that's going to cost us a bit of precision. And that's why we end up with some silly number like this. Anyway, let's take a look at how we can solve this issue to make sure that 0.1 plus 0.2 is equal to 0.3. And to solve this, we're going to import from the math module the isClose function. And this will check how close two numbers are to each other. And here we will create some values, a of type float, which will equal 0.999, and b of type float, which will equal 1.0. and I'll just type it like that. And to make it actually look nicer, I'll add a 0 in front of it. Not required, but at least we can compare them nicely. So let's compare these numbers in the appropriate way. Because right now, if we were to print the f string of a is equal to b, and then we were to do that comparison, a is equal to b, this would obviously return false. These are different numbers, and it just makes sense that it returns false. But in some cases, we're going to say, hey, these two numbers are actually close enough, so let's return true. And to do that, we're going to use the isClose function. And inside here, we can insert two numbers, a and b. And then we have the option to specify the absolute tolerance. So this is how much the numbers can differ and still be considered the same number. For example, we can specify a 0.001 tolerance, telling Python that if the number is 0.001 different, that's okay. It can be +1 or -1. So it doesn't have to be 0.999. It can also be 1.001. As long as it's in that range that we defined here, we're going to consider it the same number. So now the next time we run this, we're still going to get false here because I messed up. For that to actually work, we'd have to put 2 because it actually has to be greater than this threshold, which means 0.1 does not break that threshold, and that we actually have to insert 2 for this to evaluate to true. Now this is great because we finally have a way of comparing numbers that differ slightly. Now the problem with absolute tolerance is that no matter what the number is, it's only going to consider it the same if it's in this range. And that means that if we have a number such as 99.5 and 100, maybe we want to consider this to be the same number. But with absolute tolerance, it's only going to keep this into account. So it's not scaling with our numbers. It's not checking that it's at least this % close. It's giving us an absolute tolerance, which means it must be in this range to be considered the same number. And this will obviously return false. So to fix this and make it scalable, we're going to remove the absolute tolerance and insert the relative tolerance. And here we can say 0.01. And all that's saying is that as long as the numbers are not more than 1% different, they will always be considered equal, even if we change the numbers. So now if we were to run this, we would get true back because it's in that 1% range. And that also means that we can change these numbers. We can say, instead of this, 0.095 and 0.1. These numbers are less than 1% different, so it's going to evaluate to true. And of course, you can insert some crazy numbers such as 0.1, which just means the numbers have to be at least 10% similar to be considered close. Although that's not really that accurate, so I would not advise that, because now you can easily do something such as, for example, 91 and 100. And since that is in a 10% range, those will be considered the same number, which is quite ridiculous. So ideally, I would recommend having it at maybe 1% or even, let's say, 0.1%, just to make sure that those fractions or decimals are close enough. Because now with that, we can do something such as 0.9999 and 1.000, and both of these numbers will be considered the same because they are at least 0.1% similar. And if you really want to get crazy, you can even choose to define both of them. So we can add an absolute tolerance of 1 and a relative tolerance of 0.01. Then I'm going to change this to 1.5, and I'm going to change this to 2.0. So now if we run this, we're going to get true back. And even if the difference was more than 1%, with the absolute tolerance, we told Python that as long as it's within this range, you can consider it the same value. So +1, -1 doesn't matter, even if it's more than 1%. Without this absolute tolerance, this will obviously evaluate to false because that's far more than a 1% difference. Anyway, let's go back to the original problem where we had 0.1 plus 0.2 and b is going to be 0.3. Performing this operation here is going to give us that crazy result, but now we have a mechanism for actually checking that it's within the range. And I'm going to set the threshold to 0.1%. And this time, if we were to run it, we would get true back, even if these floats are kind of different. And that was all thanks to the threshold that we specified for these floats that differ slightly. It's time we start learning about the concept of scopes in Python. And to explain what scopes are, I'm going to get started by creating a variable called number of type integer, which is going to equal 999. And what we did here is define it in the global scope, which is the outermost layer of this script. And if we were to create a function called change number and return none, as soon as we enter this function, we will be in what they call an inner scope or a local scope. And here we can try to set the value for that number to 10, but what you will notice is some syntax highlighting, that this shadows the number from the outer scope and that the local variable number was never used. So what we did here is create a local variable that does not use the outer one or doesn't even know of the existence of the outer one because it's inside its own scope, which is the function's scope. And once you create a new function, you create a new scope, which means anything you create inside this scope won't be visible to the outer layer. And that's why we can't refer to whatever's inside here outside of the function. For example, you might have a variable called a. If you were to move outside of this function, you'll notice that we have no way of touching this variable because it's not in the same scope. But if you were to create an inner function, for example, and we can just call this inner, that returns none, you will be able to continue using it. But we will cover more about inner functions later. Anyway, all I wanted to state here is that we cannot change the number from the outer scope using this kind of syntax because it's in a different scope. And we can verify that by trying to change the number and printing the number. If we were to run this script, we would still get 999, even if we ran this snippet of code that assigned the value of 10 to number. One thing you should note though is that if we were to create a function called print number, which returns none, is that we can still refer to that number from the outer scope. That's not a problem. It only becomes a problem when you try to assign a new value to it. So watch what happens when we print the number. We would get the number from the outer scope printed, because this was able to grab the value from the outer scope and use it. But if we were to create a local number, it would default to using what's in the local scope and not the outer scope. So the next time we run this, we're going to get 10 as an output. And in general, you don't really ever want to have things out in the global scope because it just becomes very messy, very fast. And as you can see, you can easily confuse things if you start creating new variables in the inner scope, because now we need to worry about whether we made sure to create a local variable and use it, or whether we're referring to the one from the outer scope. It just becomes more confusing. Anyway, in the next lecture, I'm going to be showing you how you can explicitly tell Python that we want to work with the variable from the outer scope or the global scope so that we can actually change it inside the function if we want to. As we saw in the previous lesson, as soon as we created a new function, it created a new scope, which means if we had a variable in the outer scope, such as 10, inside the function, we were unable to change that variable. We couldn't change that to 5 because this was in an entirely new scope. One thing I really wanted to mention in the previous lesson, which absolutely slipped my mind, is that everything in the outer layer will always be visible to what's inside the inner layer. So if you were to type in print variable, we can refer to it because it was in the outer layer. And this applies to every new function you create. Every time you create a new scope, we can still refer to the variable from the outer scope. So we are still referring to this one over here. This only works in this direction. If we were to create a variable inside here that we can call inner var, and that's equal to 10, or actually let's change that to 1, this is only available to anything that goes towards this direction. It's not available to anything outside of it. So we cannot refer to inner var here or out here. It just won't work. Even under it will not work. We cannot refer to that inner variable anywhere else in our script unless we create another inner function. So to actually refer to this, we either have to use this function or we need to create a third inner function. It can be function number 3. Then we can refer to that inner variable because it's inside the same scope. Anyway, I just wanted to make that clear because I feel like I didn't really explain that clearly in the previous lecture. But let's get rid of all of that and create a number of type integer. Because in this lesson, I'm going to be showing you how we can use the global keyword. Right now, suppose we have some sort of number and that we have a function that we want to use to change this number. As I mentioned earlier, if you were to type in number equals 10, for example, this would create a whole new variable inside this local scope. We cannot change the number from the outer scope this way. To actually tell Python that we don't want to create a local variable and that we want to refer to the number from the global scope, we're going to have to use the global keyword. So here we tell Python global number. And this just tells Python that this is not a local variable. We're actually grabbing this from the outer source. So if we were to print number before we run this, so we will print the number, and then we were to change the number and print the number again, you'll see that first it's going to start off as 0, then we're going to change it to 10 inside the function. And that's because we actually referred to the correct number this time, the one in the outer scope. Without this, Python looks at it as if this is a number that we created inside the function. And when we hovered over it last time, I showed you real quickly that first, this variable was never used, and second, that this shadows the name number from the outer scope. And I didn't really explain that much about shadowing, but shadowing in general is never a good idea. Because once again, as I showed you in the previous lecture, if we were to refer to number, sometimes you're going to make the mistake of referring to the wrong number, because you might have created the function and you might have forgotten to actually create the number inside the script. And the worst part about this error is that the script will still run, even if we did not intend to use the variable from the outer scope. So when you're creating a new function, make sure you come up with a name that does not shadow whatever's in the outer scope. So you can even call this temp number because it's a temporary number. And this just ensures that whatever we do inside here does not touch what's in the outer scope, which is much more convenient because if we were to forget to create this variable, for example, we would get that syntax highlighting that this doesn't exist. Otherwise, if it's number, as I mentioned earlier, sometimes you're going to make the mistake of referring to the wrong number. And the worst part is, your script is still going to run like nothing happened. Anyway, if you want to refer to the variables from the outer scope, just remember to use the global keyword. So you can say global number, and this also applies to inner functions. So if you have an inner function and you still want to use the one from the global scope, all you have to do is type in global number and print that number, or use that number in any way you want. So a better example would obviously be to change the number to a different number, such as 10. This is affecting this number. Without this, we're just creating a new number inside that function. Now that we learned how we could use the global keyword to refer to or to modify the variables in the global scope, it's time we take a look at another keyword that allows us to refer/modify variables in the inner scopes. And this keyword is called nonlocal. Anyway, by this point we understand that everything in the outermost layer is part of the global scope. So to explain how nonlocal works, I'm going to create a function called outer function. And this will return none. But inside here, we're going to create a few variables, such as a name of type string, which is empty, and a value of type integer, which is set to 0. And now suppose we also have an inner function, which returns none, and that we want to use this function to modify these values. Well, right now, if we were to type in name is equal to Tom, we're going to have a completely new variable created inside the inner function. And the same thing goes for the value. Here, we're not modifying these values, we're just creating new values inside that function, because obviously this is in a different scope. And if we were to call this inner function and then print the name and the value, and then run this outer function, you're going to notice that we're going to get back an empty string and 0. We did not modify the values that we wanted to modify using the inner function. And also, I didn't really explain what an inner function is, but it should be quite obvious from what you see. It's just a function defined inside another function that you can use inside your functions. Anyway, what can we do here to solve the issue? Because if we were to use the global keyword and refer to value and name, this wouldn't fix anything. We would still get the same result. So what we have to do here is use the non-local keyword. And all this is saying is that this is not local. This is actually grabbing the values from a different scope. And as you might have noticed, we can use multiple values with non-local just by providing a comma. Otherwise, it would be quite annoying to type in non-local and name for each new value we are using. I mean, it's perfectly acceptable, Python won't complain, but it just makes more sense to use a comma in these situations. So value and name. Or it actually would be much nicer to have name and value to respect the order. Anyway, once we use the non-local keyword, it's actually going to be able to refer to the correct variables that we actually wanted to change. So now we're actually grabbing the non-local variables. So that's what the global and non-local keywords are used for in Python. In this lecture, we're going to be exploring list comprehensions. And list comprehensions might look scary at first, but once you get the hang of them, they become nearly impossible to live without. List comprehensions just make creating lists much more efficient and reduce drastically the amount of code you need to create simple lists. For example, pretend you have a list of numbers, which will equal 1, 2, and 3, and that we want to double these numbers. Now, without a list comprehension, we're going to have to create a whole new list of type integer, which is going to be empty at first. And then we're going to have to type in for number in numbers, doubled.append number times 2. And then we can print that list to see what values we got back. And when we run this, we're going to get 2, 4, and 6 back, all the numbers doubled. But we had to write a lot of code just to perform this simple operation. Now let me show you how we can do this using a list comprehension. So right below this for loop, let's remove the print statement and type in doubled LC, which stands for doubled list comprehension. And that will be a list of type integer, which will equal a list. But here we can type in number times 2 for number in numbers. And below we can print it. So once we print it, you'll see that we will get the exact same result, except this time we only used one line of code. So as you can see, this was much more convenient than what we had earlier. And the syntax goes as follows. Here you have what you want to return or what you want to add to the list. So in general, if you just want to add the numbers, you would say number for number in numbers. But since I want to add the double of each number, I multiplied it by 2 before adding it to the list. The rest is literally the loop. So for number in numbers, which is this part over here. So we kind of reversed this process because here we have for number in numbers. We're going to append the number. And instead in the list comprehension, it's going to be append this for each element in the elements. But let's practice some more with a different example. So for the next example, I'm going to have some names, which is going to be a list of string, which will contain Mario, James, Luigi, and John. And what I want to do next is get the J names, which will be a list of type string. And of course, it's going to be empty initially. So here we can type in for name in names. If the name starts with J, then we will say that this should be appended to the J names. And if we were to run this and print those J names, we would get James and John printed to the console. But once again, this was quite long. So let's learn how we can simplify this using list comprehensions. So instead of printing J names, I'm going to type in J names LC, which will be a list of type string, and that will equal this list comprehension. So once again, the result we want to return for name in names if the name starts with J. So we followed the same syntax, the element we want to return, the for loop that we want to use, and at the end we also were able to specify a condition. if the name starts with J, add the name to the list. So now if we were to print jnames lc, we would get James and John once again. And something I used to do to simplify this when I was learning list comprehensions is create new lines for each one of them. So we're returning the name for name in names if the name starts with J. Python is going to consider all of this one line, so it doesn't matter if you indent it or not, but this just made it much more readable for me because we are returning the name for the name in the names if the name starts with J. So once again, it allowed us to do all of this in a single line, or actually all of this, because we're also creating the variable in the same spot. But let's do one more example before moving on with the course. And in this example, we're going to have some numbers, which is going to be a list of type integer. And what we want to get back are the even numbers. So we'll create a list called even numbers, and initially it's going to be empty. And then we're going to create that for loop as always. So for number in numbers, if the number modulus operator 2 is equal to 0. So if the remainder of the number divided by 2 is going to be 0, that means it's obviously going to be an even number. So we're going to append that number. Then we can print these even numbers, and what we should get back are the even numbers from our list. But once again, we can shorten that drastically. So I'm going to copy these even numbers, paste it here, and just add LC at the end for list comprehension. Then we can do the same thing as from earlier. Return the number for each number in the numbers if the number modulus operator 2 is equal to 0. And this is missing a colon. And printing this should give us the exact same result. 2, 4, 6, and 10. So once again, if you want to simplify it, think about it this way. You're returning this number for each number in the numbers if the number modulus operator 2 is equal to 0. So if it's an even number. And it was as simple as that to convert this into a one-liner. In this lecture, I'm going to be teaching you the concept of slicing and also some slicing related syntax that you can use to make your programming experience smoother. First of all, let's take a look at a basic example of how we can use slicing in Python. And to do so, we're going to create a list of numbers. And that's going to equal 1, 2, 3, 4, 5, and 6. So we have 6 numbers here. And the first thing I'm going to show you is how we can get a specific section of this list back via slicing. And actually, it doesn't have to be a list. It could also be a tuple. It just has to be a list-like object, which can be indexed. So, I mean, it also works with strings, theoretically. Anyway, what we're going to do here is get the first 3 numbers back. And to do so, we're going to type in numbers from the index of 0 to 3. And 3 is exclusive, which means it's not going to grab what's here. It's only going to grab everything that builds up to here. And if we were to run this, we'd get 1, 2, and 3 back as a return. And to get the rest of the elements, we can do the same thing. We can say we want to get everything from the index of 3 to 6. And of course, there's no 6th position in this list, but we're just telling Python that everything in between here we want to get back. So if we run that, we will get 4, 5, 6 back. And you can even say something such as 2 to 4, and that will give us 3 and 4 back. So with this syntax, we were able to grab certain sections of a list-like object. If we were to exclude the 0, it would grab everything up until 3. And we can also do the reverse by typing in 3, and this will grab everything from 3 onwards. So now if we were to run this, we'd get 1, 2, 3, and 4, 5, 6. And that was much easier than doing this over here. And the reason this number is exclusive is because this was designed to make it easier to do this kind of operation if you ever wanted to create a completed list. Because right now, if we get everything up to 3 and everything from 3 onwards, this will give us the original list back, or the elements from the original list. That's why the 3 was exclusive, just to make this operation much easier. Also, if you ever want to get the last element from a list, you can easily insert -1, and that's going to go backwards. So in this case, it's going to grab 6. And if you were to type in -2, it would go 2 steps backwards. So it would end up grabbing 5. But now it's time I show you how we can skip elements or how we can use steps with elements. So here we still have our list of numbers, and this time we're going to say from 0 to 4, and we're going to use one more colon, because here we're going to define a step. So from the numbers of 0 to 4, step 2, which means we're only going to get 1 and 3 back, because it starts at the index of 0, and then it goes up 2, and grabs 3, so it steps 2 each time. And this also works quite well if you want to do it backwards. For example, if you have 4 to 0, the only way for this to actually work is to add -1 or -2, and that would work just fine. It would do everything backwards, so 5 and 3. If we did not specify the step, doing a reverse slice will give us nothing, because that doesn't really make any sense. From 4 to 0 does not make sense. So if you ever want to do something backwards, you're going to have to specify a negative step. But we can also get all the numbers back by using 2 colons and providing a step as well. So now we're stepping all the numbers without having to specify a start value. So that will start with 1, step 2 to 3, and then step 2 to 5. It's going to step 2 each time. If we were to use 3, it would give us 1 and 4 back, because here we have the first element, then 1, 2, 3, we get to the third element, and so on. And if you ever want to reverse a list, you would use colon, colon, -1. And that would give us the list reversed. And again, it's not only for lists, you can also do this on tuples and strings. So here if we were to have a name of type string called Mario, and we were to insert that name here, we could reverse that name using this syntax. If you're looping through a list, a good rule of thumb is to never modify that list while you're looping through it, because it will often lead to unwanted or unexpected behavior in your program. And in general, you will always want to use a temporary list if you decide to make any changes while you're looping through the original list, and then transfer the changes from that temporary list to the original. But anyway, in this lecture, I'm going to be showing you an example of where looping and modifying a list at the same time can be a bad idea. So here we have a simple list of people that contain the values of Anna, Bob, Chris, David, and Fred. Now let's loop through these people. So for person in people, first I want to print the person, and then I want to print, or not yet, I want to first check if the person is equal to Bob, print removing that person, which is going to be Bob, and we will remove that person. So people dot remove Bob. So now we have a simple for loop that attempts to modify that list as we are iterating through it. And watch what happens when we run this. When we actually try to run it, we'll get Anna, Bob, removing Bob, David, and Fred. So the operation worked perfectly fine, or at least that's how it appears. Because one thing that's missing is Chris. What happened to Chris when we were iterating through these people? All we have now is Anna, Bob, removing Bob, and then we just went straight to David and Fred. But Chris just disappeared into thin air. So while our operation might have been successful, our for loop was a huge failure. So to demonstrate what happened here, I'm going to just print a new formatted string that says print f-person, and we're going to get the index of that person. So people.index and pass in the person. And all this will do is tell us in lifetime the position of that person as we are iterating through this list. So if we were to run this one more time, you would notice that Anna is at the position of 0, Bob is at the position of 1, but once we remove Bob, David moves on to the position of 2, which is quite insane because Chris was originally at the position of 2. But since we removed Bob, Chris moved to the position of 1. So now instead of having Bob at the position of 1, we have Chris. And as far as the for loop knows, it already iterated through the position of 1. So it's not going to do it again. And unfortunately, because of this, Chris will never see the light of day, because now Chris has the identity of Bob, or has the position of Bob. And again, this happened because we were modifying this list while we were iterating through it. And that's why I always recommend you work with a temporary version of the original list. In this example, you might just even create a new list, such as new people, which will be of list of type string, and that will equal an empty list. Now we will still iterate through the original list, but all the operations that we're going to perform are going to be on the new people. Obviously, because of this, we're going to have to change our operations up slightly. So instead of removing Bob, we can just type in continue. Otherwise, we're going to append the person to our new people. So new people dot append, and here we can type in person. Then we can print our new people. And if we were to run this, we would have everything at its correct index. Anna at the index of 0, Bob at the index of 1, and this time we will finally have Chris, and then David and Fred, everybody in their correct positions, because this time we did not modify the original list while we were looping through it, so we didn't have to worry about that unexpected behavior. It's time we create another project in Python. And for this project, we're going to be building a simple grocery list. So it's going to look like this. It's going to start us off with a welcome message that says, welcome to groceries, which is our app name. And then we're going to get some instructions for how to use the program. So 1 to add an item, 2 to remove an item, and 3 to list all items. Then of course, if we want to exit, we can just type in 0. But here I'm going to type in 1 so I can add a banana, and then we'll add 1 again so I can add in an apple. And at this point, I have some items that I can list. So here I'm going to enter 3, and we will have a list of our groceries. Then we can remove an item if we please. We can say we want to remove the apple, and apple will have been removed. And we can verify that by printing our list once again. This time we only have a banana. But what happens if we want to remove an item that doesn't exist? So here I'm going to simulate that by entering 2 and trying to remove orange. Well, we're going to handle that appropriately in case we run into that issue. As you can see, there was no orange found in the list that contains our groceries. And then, of course, if we want to exit, we can just enter 0, and that will terminate the program. So that's the project that we're going to be making in this lecture. So as always, create a new empty Python file so that we can get started immediately with building this project. And to start off, we're going to import our system so that we can exit our program appropriately. And the first step to making this program is creating that welcome message. So here I'm going to create a function called welcome message, and that's going to return to us none. But this will contain all of the instructions we need for the user to understand our program. But first we will type in welcome to groceries, or whatever you want to name your app, and then we will enter the instructions. So enter, and here I'll insert a divider to make this look nice. And since this is a lot of text, I'm just going to paste this in because it's straightforward. It's just a bunch of print messages that simulate the instructions. So 1 to add an item, 2 to remove an item, 3 to list all items, and 0 to exit the program. And that's all this function will contain. Just the instructions on how to use the program so the user actually knows what to do when they are presented with some options. But below that, we need to work on the functionality that actually allows us to add items, remove items, and to see the entire list. So let's get started by creating the add item functionality. And this will take an item of type string and the groceries, which will be of type list of string. And that's going to return to us none. And then we can add the operation of groceries.append and the item. And the reason we're turning this into a function is because we can also add some other custom behavior, such as a print message that says has been added. A kind of success message that tells the user that the operation was successful. And for this function, it was quite simple. But now when we are removing items, it becomes a bit more complex. So here on line 20, I'm going to type in def remove item. And it's going to take the same function signature, an item to remove, and the list from where we want to remove it. And this will return none. Now, removing an item is a dangerous operation because it can raise an exception if we pick an item that does not exist. So here we need to add a try and except block. And we're going to try to remove the item. And if we do that, we can write a success message that the item has been removed. Otherwise, we're going to run into a value error. And that's what a list will raise if it does not find an item. And the way I know this is because I ran into that many times when I was learning how to program. So it's not necessary that you memorize all the possible scenarios. The important part is that you learn by experimenting. And here we'll type in no item found in the groceries. So I kind of lied. It wasn't that much more complex. It was just a try and except block. But moving on, let's try to create the functionality that lists our items or the groceries. So here we'll create def display. And this time we will only take groceries since we just need to display whatever the list is. And that will return none. And down here, we can try to format it. So print the f string, or it's not really an f string. So we'll just print 3 underscores, list, and 3 underscores. Then for I and item in enumerate the groceries, starting with 1, we will print the f string of the position of that item and the item dot capitalize. And I know this looks like new syntax, but don't worry, I will explain what enumerate does in detail later on in this course. To explain it very briefly, enumerate groups a list with some numbers in an increasing order. So for example, having groceries and 1 will associate each grocery with a number starting at 1. So if we have bananas, apples, and oranges, it will list them out as bananas 1, apples 2, and oranges 3. By default, this begins at 0. So if we were just to enumerate these groceries, we would have to add +1 to I if we wanted to get the same behavior. Anyway, I'll teach you more about enumerate later on in this course. Although for practice, I do recommend you play around with this because it's a lot of fun. Anyway, at the bottom, we're going to print a lot of underscores. And actually, I'm going to print 10 to be precise. So one thing you can do actually that's quite cool is multiply strings using numbers. So instead of typing out 10 underscores, you can just type in 10 times underscore. And that's going to create 10 of this string and add them all together. Otherwise, you can just type out 10 underscores. And finally, before we put all of this functionality together, we need to create one more function that checks that the user is inputting a valid option. So here we'll type in def is an option. And that will take the user input and it will return a Boolean. And this Boolean will return the text in 1, 2, 3, and 0. So here we're checking that the text is in this list. If it's not in this list, it's going to return false. If it is, it's going to return true. So it's a very simple way to check that the user input is valid. But now that we wrote all of the functionality, it's time that we put this together in our main entry point. So here I'm going to type in main, and of course that's going to do 2 things. First, it's going to create my main entry point, and then it's also going to create the if name is equal to main check. And again, I was able to do this using live templates. Anyway, inside here we need to create our groceries, which will be a list of type string, and that's going to be empty originally. Then immediately under that, I want to provide a welcome message. And we're doing this before we initiate the while true loop, which will allow us to run our program continuously. And on each iteration, we want to get some user input, which will be of type string, and that will equal the input of choose. And whatever the user decides to input, I'm going to lower that. And before we do anything with the user input, we want to make sure that it is a valid option. So here we'll type in if it's not a valid option, and we will insert the user input. Then we will print, please pick a valid option. And we will continue. So we will ask the user for some more input. And I want to add an ellipsis here, just for that dramatic effect. But below that, we can finally check what the user input is and handle it accordingly. So if the user input is equal to 1, we're going to create a new item of type string, and that will equal the input of what item would you like to add. And we will lower that. Then we will add that item to the groceries using our add item function. Elif the user input is equal to 2, we're going to want to remove the item. So item to remove of type string will equal the user input of what item would you like to remove. And we will lower that as well. Then we can use our remove item function with the item to be removed and the groceries list. Elif the user input is equal to 3, we can display the groceries to the user. And finally, if the user input is equal to 0, we're going to print that we are exiting the program. And we will call system.exit. So now if we try to test this out by running our program, we will get our welcome message. And first of all, let's try to list the items. And since there's nothing there, it's going to give us nothing back. But the program's not going to crash. Then we can try to add an item such as a banana. And I actually hate that there's no space here. So I'm going to go back and fix that real quick because it looks like on both of them, I forgot to add a space. So we'll go back, we'll type in banana, or before we type in banana, we need to add something. So let's add a banana. Then let's add an apple. And then we can also add some oranges. And then we will try to list all the items. And this time we'll have banana, apple, and oranges. And another thing you should note is that we can have duplicates. So if we were to add a banana and display this list, we would have 2 bananas in our list. But anyway, if we were to remove something using option number 2, such as banana, one of those bananas will have been removed. And it's actually going to remove the first occurrence it finds. So the first banana will have disappeared. And it looks like there's also another little bug. And that is with the enumerate function. I forgot to keep the start at 1, so all the items started at the index of 0. But obviously, a lot of normal people in this world who do not program will not understand why something starts at 0. So let's rerun this program, add option 1, and add a banana. Now when we actually try to list our items, we should have banana as the first item, instead of having 0 here. Also, for homework, I want you to solve 2 more issues. One is that if we try to add an item and we don't enter anything, it's going to enter that empty string as an item, and we do not want that behavior. So I want you to find a fix for that. And second, if you're really feeling ambitious, try to add a 4th option that allows you to modify a list item. Otherwise, the last thing to do here is to type in 0 and exit our program, because we have successfully created a grocery list app. And that's the end of this project. In this section of the course, we will be looking at how we can use OOP in Python. And OOP stands for Object-Oriented Programming, and it changes our approach to how we think and write our code. And rather than explaining it all theoretically, I'll be showing you over the next few lectures how we can use it and why it can be considered an ideal approach when programming. In other words, we're finally going to be learning how we can use the class keyword in Python. So I hope you guys are excited because we will be starting immediately in the next lecture. In this lecture, we're going to be taking a quick look at what classes and objects are in Python. And let's suppose we want to create a program for cars. When you break it down to the basics, every car has similar functionality. So why should we create an entire new program for each car when we can create something that's reusable for each car instead? For example, every car has wheels, an engine, the ability to drive, etc., etc. So let's create a class for this car. And a class is practically just a blueprint that contains all the information of what a car should look like. And in this lecture, I'm going to be writing a lot of code that we have not covered just yet, but don't worry because we will be covering it in this section of the course. But for now, we have a class called car, and then we have an initializer, which returns none. And inside this initializer, we practically just give the class the starting information it needs to create a custom car. And here we'll add a brand of type string and wheels of type string, or actually of type integer, because we want to pass in the amount of wheels the car has. Some might have 6 wheels, some might have 4, so it's good to be able to customize that. And again, do not worry about what this is or what self means just yet. I'm just going to quickly create this class and show you the benefits of classes and objects in Python. So inside here, I'm going to type in self.brand is going to equal the brand, and self.wheels is going to equal the wheels. So every time we want to create a new car, we're going to provide the brand and the wheels. And that's all we're doing essentially in this block. Of course, inside this class, we also want to define some functionality for the car, because if we don't define any functionality, the car is not going to be able to turn on or to turn off or to even drive. So right below, we're going to type in def turn on. And here it's going to return none. And we're going to print that we're turning on the self.brand. So whatever car we're working with is going to be inserted here. Then I also want to create a method that turns off the car. So right below, I'm going to type in turn off. And all we're going to do is type in turning off self.brand. And then of course, we might want to have some other functionality for this car, such as the functionality to drive. So we can create a method called drive. And here after self, we're going to define a parameter called kilometers. So we can choose to drive for that amount of kilometers. And this will also return none because we're still just printing things. So here we can print driving self.brand for kilometers km. And if you are in a country that is not based on kilometers, feel free to change this to miles. So this can even be mi. Whatever you prefer, we just want that car to drive. And finally, I just want some functionality that can describe this car. So def describe, that will return none. And here we're going to print the f string of self.brand is a car with self.wheels. Wheels. And that's all the functionality we're going to include for this car. Anyway, let's take a look at what we can do with this now that we have the blueprint of a basic car that has a brand and some wheels and some basic functionality. So right below this class, we're going to create our if name is equal to main check and our main entry point. And the very first thing I want to do here is create a BMW of type car, which is our car class. And that's going to equal a car. And inside here, we can pass in both a brand and an amount of wheels. So for this, I'm going to say that the brand is BMW and that the wheels are 4. Now watch what happens when we use dot notation with that BMW object. We get all the methods that we have described for that BMW, which at the end of the day is just a car with some custom setup. But now we can actually drive this car, we can turn it on, we can turn it off, and we can also describe it. So what I'm going to do is turn on the car, and then I'm going to type in bmw.drive for 10 kilometers. Then we can also type in bmw.turnoff because we are done driving. And finally, I also want to describe this BMW. And all of this functionality will be applied directly to this object over here. So when we try to run this, you'll see that in the console, we're going to get this output. First, that we're turning on the BMW, then that we are driving the BMW for 10 kilometers, and then that we're turning off that BMW. And when we want to describe it, it's going to give us back BMW is a car with 4 wheels. And at this point, it seems like we went through a lot of effort just for a simple BMW. But to show you the benefit of using classes, let's create a different car. And this car is going to be called Volvo, which will be of type car, and that's going to equal a car with the name of Volvo or the brand of Volvo, and it's going to have 6 wheels. And just like that, we created a whole new car that has all the same functionality as that of the BMW with some custom details. So we don't have to rewrite any functionality for this Volvo because we already created a blueprint that fits it quite nicely, which means now we can also turn on the Volvo. We can drive that Volvo for, let's say, 30 kilometers, and then we can turn it off. And finally, we can describe that Volvo. We were able to perform all of these same operations that we did with the BMW just by creating a new object of type car. And if we were to run this, you'll see that after we do all this stuff with the BMW, we'll also get the print statements for the Volvo. So we're turning on the Volvo, we're driving the Volvo, then we're turning off the Volvo, and finally, the Volvo is a car with 6 wheels. So we were able to use all of that functionality with a whole different car just by providing some minor setup. And that's why object-oriented programming can be very appealing also in Python. And again, I know that this was a lot to take in because there's still a lot which I didn't explain, such as why did I have to use self everywhere inside this class? And what is an initializer even? Well, don't worry about that just now because we're going to be covering all of that over the next few lectures. In the previous lecture, we explored the concept of classes and objects in Python. But now let's take a look at initializers, because earlier I created an initializer and I didn't really tell you anything about what it does and how it works. So now let's look at what init does in more detail. Suppose we have a class called connection that will handle internet connections, mobile connections, whatever connection we need. Every time you create a class and you want some custom setup, you're going to have to provide an initializer. The initializer is just a block of code that gets called every time we create a new object from this class. If we choose not to include it, we're not going to be able to customize this class. So to create an initializer, we use something called a dunder method, and dunder just stands for double underscore. So here we add double underscore, init, double underscore, and then we type in self. And self just refers to the current instance of this class. But I'll explain that in more detail in the next lecture. Anyway, when you create an initializer, you're always going to have self. And then we can choose to provide what kind of parameters we want to include for the setup of this connection. So here we can type in connection type of type string and the cost of the connection of type float. And an initializer will always return none because its sole duty is just to set up the class with the custom functionality that we provided. And inside here, you can insert whatever kind of setup code you need for this connection to actually work. So first of all, we can print a message such as the connection type, connection established, with the cost of dollars, cost per hour. Also, every time you create an initializer with some parameters, you're going to want to assign the values from these parameters to the instance of the connection. And I'll explain in more detail what an instance actually is, but for now just type in self.connectionType is equal to the connection type, and self.cost is equal to the cost. And again, self is just the current instance of the class. So if we create an internet connection, it's going to deal with that specific internet connection. But before I write more code inside our connection, I'm going to create our if name is equal to main check so I can explain a bit more what an instance is. So inside here, we're going to create something called internet, and this will be of type connection. And what we're doing here is creating an instance of the connection. It means it's just a place where we're actually creating that connection. And to do that, we use the class name followed by its constructor. And then we can pass in the arguments such as internet, and internet will cost $2 an hour. So this is an instance of a connection. And when you are creating an instance, programmers will often refer to this as instantiating this object. And this is just vocabulary that you'll get used to the more you hear it. So internet is in fact an object, but it is also an instance. And we can also create another instance of connection or another object of type connection right below, which we can call satellite of type connection, and that will equal a new connection. So now we are instantiating this object once again, and we can pass in satellite with $20 an hour because satellites are bloody expensive. And here we have two instances of connection. Anyway, with that being done, let's also add one method to our connection class so it's not worthless. And here we'll just create something called close connection because we don't want our connection to run forever because we don't have the money. And that will return none. And then we can print that we are closing the self dot connection type, connection. And we will use that on each one of these objects. So internet dot close connection, and then satellite dot close connection. So now if we were to run this, we're going to be able to establish an internet connection with the cost of $2 an hour and a satellite connection for $20 an hour. Then we can use the methods on both of those objects and close those connections. So to sum it up, the initializer takes care of the code that you need to initialize the object or to initialize the class. So if you want anything to have some custom setup, you would place it here, because every time you create a new instance of a class, the initializer is going to get called and it's going to run this code automatically. But now that we know what an initializer is and we learned more about the vocabulary regarding a class, it's finally time we take a look at what self is. Up until now, we've been using self a lot throughout our classes, but what is self exactly? Well, to explain it briefly, self refers to the current instance of the class. In other words, every time you create a new object, you want all of the data that you insert into that class to be associated with that instance of the class and not the class itself. But let's take a look at an example that can help clarify what I mean by that. So in this example, we're going to have a class called fruit, and it's going to have an initializer that takes a name of type string and the grams of type string. And inside here, we need to type in self.name equals name and self.grams equals grams. And right below this, I'm going to create our if name is equal to main check and create a few instances of this fruit. And the first one is going to be an apple of type fruit, which will equal a fruit with the name of apple, and it's going to be 25 grams. Then we're also going to create a banana type fruit, which will equal a fruit called banana, and this will be 10 grams. And the code editor is telling me that I'm quite stupid today because this is supposed to be a float. Anyway, here we have two instances of fruit. One is an apple and one is banana. In both of them, we passed in a name and some grams, and then we created some instance attributes that took that information and stored it inside that instance, which means apple is now associated with the apple instance. So what self refers to in both of these cases is the current object or the current instance. So in this case, apple is self. Otherwise, in this one, banana is self. And this just makes sure that this information is associated with the object and not with the class, because the class shares information while the object wants to have its own information and it doesn't want to share it with the other objects. So self is just used to make sure that this information stays in apple and that this information stays in banana, because thanks to that, we can actually refer to the information inside the apple and to the information inside the banana as different information. Right now, if we were to run this, we would get apple and banana printed to the console. Also, every time you create a new method for this class that actually has to use the information from this class, you're going to see self being used. And most code editors will insert this automatically for you. So maybe you want some functionality that allows you to eat the apple. As soon as you type in the function name and then you add some parentheses, you'll see that self will be inserted automatically. And this will return none. And again, what self does here is make sure that we're working with the current instance. So if we have an apple, it's going to use the information from the apple. If we have a banana, it's going to use the information from the banana. It's using the current information of the object that we are working with. So here we can print eating self.grams g of self.name. And now if we go down below and we try to eat the apple, self is going to be associated with the apple, while with the banana, self is going to refer to this banana. And now when we run this, you'll see we will have an apple and that we're eating 25 grams of that apple. And then we will eat 10 grams of a banana as well. And there's also one more thing. Self is actually a naming convention. So you can actually rename this to whatever you want. You can even call this this, if you want to refer to the object as this, but you just need to remember to change it everywhere throughout your class. And most code editors are going to tell you that usually the first parameter of a method is named self. So I don't really recommend you do this because other developers are going to be quite confused by why you changed it. But all I want to mention here is that using self is just a naming convention. It just refers to the object that we are working with. With self, we were able to define instance attributes, and attributes are just whatever belongs to the class. So if you have a method or a variable, those are considered attributes of the class. But there's actually another kind of attribute that we should explore, and this is the class attribute. And usually we use class attributes to tell Python that this information should be shared amongst all the classes, not the instances. And they can be quite dangerous if they are not used properly, so I'm going to be explaining everything you need to know about them in this lecture. And to get started, we're going to create a class called car. And this car is going to have a constant called speedLimit km, which will be of type float and will be set initially to 140. And this time we created this outside in the open as a class attribute, which means every class is going to contain this, and that it is not bound to the instance. So if we have a Toyota and a BMW, all of them are going to share this information. While if we want to create an instance attribute, we need to define it inside the initializer. So here we'll type in def init, and it's going to take a brand of type string that will return none. And here we'll say self.brand is equal to the brand. And that will have successfully created an instance attribute, because this is bound to the instance of whatever car we created. And right now our car is quite worthless because it doesn't really have any functionality. So we're going to define a drive method, and we're going to use an asterisk to force the user to insert the speed as a keyword argument, making it more explicit. And inside here, all we need to do is check if the speed is more than the self.speedLimit kilometers, then we're going to apply a limiter. So print the f string of limiter activated, driving at self.speedLimit km per hour. Else we can just drive at a comfortable speed. So print the f string of driving at speed kilometers per hour. And that's all we had to do to create our car class. So next, let's actually use it by creating our main entry point and testing it out. Right now, what we can do inside here is create a Toyota of type car, which will just have the brand of Toyota. And let's try to drive this Toyota at 200 kilometers an hour. So speed will be set to 200. Now, when we run this, the limiter should be activated and the car should drive only at 140 kilometers an hour. But we can also change the default of this speed by referring to the car class itself and referring to the speed limit kilometers. We can even update that to 170. And the next time we drive this Toyota and insert the speed of 200, you'll see that the limiter will have been activated at 170 kilometers an hour. Now, to actually see the benefit of this, we're going to create a BMW of type car, and that's going to have the brand name of BMW. And before we do anything, we're going to drive the Toyota and the BMW so we can see the original speed. And BMW will be set to 210. Now down here, we're going to update the speed limit to 99 kilometers an hour. Then we're going to drive both the Toyota and the BMW once again. So now if we were to run this, you'll notice that both cars are going to start off by driving at 140 because the limiter was activated on both of them. Later on, when we tried to drive the cars again, the limiter was activated once again, but this time it set both of them to 99 kilometers an hour. And that's because we updated a class attribute, not an instance attribute. If this was an instance attribute, it would only affect one car. So if we had a Toyota.speedLimit, for example, only the Toyota would drive at 99 kilometers an hour, while the BMW would have the default. And now it's time I show you the dangerous part of using class attributes. And to demonstrate it, I'm going to create a new class called animal. And this animal is going to have a class attribute called tricks, which will be a list of type string, and that's going to be empty initially. Then we will have an initializer that takes an animal name and returns none. And of course, we want to create an instance attribute for that name so that the name is linked to each animal. And this class will only have one method, which is called teachTrick. And that's going to take a trick name of type string and will return none, because all we want to do inside here is add a trick to this list. So here we'll type in self.tricks.append, and we will append the trick name. Now with that being done, we can create our if name is equal to main check and our main entry point and create a few animals, such as a cat of type animal, which will have the name of Helios. And then we will create a dog that will have the name of Boomer. Next, it's time to teach our cat Helios some tricks. So cat.teachTrick, and the first one will be wash dishes, a very good trick to have. And the second trick will be get a job. Two very useful tricks. And right below that, we're going to print these tricks to see what kind of tricks the cat has once we teach Helios these tricks. But we also want to do the same thing for the dog. So dog, teach trick, and the first one will be do finances, while the second one is going to be something else that's super useful, such as invest in stocks. Then we will print the dog.tricks. So what we did here looks quite straightforward, but watch what happens when we run our script. You'll notice that the cat will have two tricks, while the dog will have all of the tricks, including the ones of the cat. And in most cases, this is unintended behavior. This is unwanted behavior. We did not want our dog to have the same tricks as the cat because we didn't teach our dog those tricks. But since we defined tricks to be a class attribute, all the instances share that list, meaning that whatever we teach the dog will be applied to the cat and vice versa. And actually, if we were to print cat.tricks after we taught our dog some tricks, our cat would also know the tricks of the dog. So that was the dangerous side of using class attributes. And to fix this, all we would have to do is change this class attribute to an instance attribute. So self.tricks is going to equal this new empty list so that it is bound to the instance and not to the class. Now, the next time we run this, you'll see that each animal will have their own set of tricks. So the cat has these tricks and the dog has these tricks. They no longer share these tricks. Now that we are quite familiar with the syntax used to create and use a class, it's time to learn about Dunder methods and how we can use them in our classes. Now, first of all, the term Dunder method derives from the double leading and trailing underscores. In other words, it's a double underscore method, although you might also hear them being referred to as magic methods. And up until now, we've only been using one Dunder method, and this is probably the most important Dunder method that you will have to use, and that is the init Dunder method, which allows us to initialize our classes as soon as we create an instance of it. And one thing to note about Dunder methods is that we never call them directly. But let's look at a couple of examples. And in this lecture, I'm going to be using a new type called self. And this just refers to the class itself, or that instance of a class. It's no different than the self keyword, but this allows us to actually type our class. Here we're going to create a class called book, and we're going to define our first Dunder method, which is the initializer itself, and it's going to contain a title of type string and some pages of type integer, and that will return none. Then the self.title is going to equal the title, and the self.pages is going to equal the pages. And by this point, we're quite familiar with how the initializer works. It's a Dunder method which we never call directly. It only gets called when we instantiate a new object, but we never have to call it directly. But there are plenty of other Dunder methods that we can use, such as the length Dunder method. And what this returns to us is an integer. And this dunder method will be activated every time we use the built-in length function. So inside this block of code, we get to define the logic for how we want our books to be measured. And here I'm just going to return self.pages. So every time a user tries to get the length of a book, it's going to return the pages by default. But you can insert whatever kind of logic you want inside here, as long as you return an integer. Now very quickly, let's test it out by creating our if name is equal to main check and creating a few books. And the first one is going to be called PyDaily, which is of type book. And that's going to be equal to a book with the title of PyDaily, and it's going to have 100 pages. And the second one is going to be Harry Potter, which will have the title of Harry Potter, and it will be 340 pages long. And now that we have defined this dunder method, we can use the length functionality with both of these objects. So we can print the length of PyDaily, and we can also print the length of Harry Potter. So both of these objects will work with this built-in function. And if we were to run this, we will get the pages back, just as we have defined. Another way to get this functionality is to call it directly. We can type in PyDaily and get the dunder length back. But in general, it wasn't really meant to be used this way. So I really don't recommend that you do this and that you stick to using the built-in function to get the length. Next, suppose we want to add some books together. Right now, if we were to create something called combined books of type book, and we were to try to add PyDaily to Harry Potter, this would not work. Class book does not define the dunder method add, so the plus operator cannot be used on its instances. So we should be quite thankful that we actually get a warning for that, because if we were to run this, we would get a type error that we have unsupported operand types for plus, book and book. We have not implemented this functionality, so Python has no idea how we should add these books together. So once again, we're going to define that functionality. Right here, we're going to say def dunder add. And here we're going to have self and other, which is going to be another book. But since we cannot refer to the book class directly, we're going to refer to self, which is the same thing. And this will return self, which is the book. And inside here, we're going to create a combined title of type string, which will equal the f string of self.title and self.other, or actually other.title. Then the combined pages is going to equal self.pages plus other.pages. So we're just combining these two books. And what we want to do is return a book with the combined title and the combined pages. And just like that, we've defined the functionality for the plus operator, which means the next time that we actually try to add these two together, it's going to work. And we can also print the result. So print combined books.title and its pages. So watch what happens when we run this now. We're going to get PyDaily and Harry Potter and the sum of the pages. So thanks to that dunder method, we were able to use the plus operator with both of these instances. In this lecture, I'm going to be teaching you about two dunder methods that are quite useful when you are working with classes. One is called repr, which stands for representation, and the other one is called stir, which stands for string. And they're actually quite similar, so I'm going to create an example that shows you how to use them in a class and their differences. So suppose we have a class called person. And this person, of course, is going to need a name of type string and an age of type integer. And what we want to do here is say that the self.name is equal to the name and that the self.age is equal to the age, so that we can set up this class properly when we create an instance from it. And down below, I'm going to create our if name is equal to main check, and I'm going to create Mario, which is going to be of type person. And his name, of course, is Mario, and the age will be set to 27. Now watch what happens when we print Mario. What we get back is this representation of our class. And all it's saying is that we have a person object at this memory address. And this information is quite useful for a developer, but for anybody else, it's worthless. We don't really know what this means. It doesn't tell us anything regarding the information inside the class. So for anyone who's not a developer, this can be considered quite worthless. And that's because by default, when we print our class, it uses something called repr, which prints the representation of the class. But if you want to create something that's actually readable, I recommend you use the string dunder method. And in general, you will use this to write something that is human readable. So this is going to return to us a string. And what we will return is the self.name, comma, self.age, years old. And I'm going to change the comma to a colon because I'm feeling wild today. But now the next time we run this, it's going to use that string dunder method to print Mario. So Mario is 27 years old, and that was much more readable, which is actually quite nice if we want to see immediately what kind of information a class contains. And with that being done, we still have the option to see the representation by typing in repr of Mario. So anytime we want to see something that's useful for the developer, we can use this built-in function called repr. And that's going to give us back the mess from earlier. That tells us that we have an object at this memory address. But we can also define our own if that's what we want. Maybe we want to define something else that's useful for the developer. So this also returns to us a string. And what we're going to do inside here is return a person that's equal to the self.name and an age that is equal to self.age. So now this looks like something that a developer would want to see. For example, we have a person with the name of Mario and the age of 27. Thanks to having defined this dunder method, the next time that we run this, we're going to get that as an output. Now we have something that's both useful for the developer and quite readable. I mean, here it's obvious we have an object of type person that has these values inside of it. And in some cases, that can be much more convenient than getting that other representation that gives us back the information regarding the memory address of that object. So to sum this up, use the string dunder method if you want to create something that's easy to read for the user or for yourself. For anything that's more technical, use the representation dunder method, because that's something that the developer can use. It's something that helps the developer understand what that class actually is. What is the difference between a method and a function in Python? Well, the difference is actually quite simple, and I'm going to be using this code to explain it. So here we have a dunder method, and below that we have a regular method. And outside of the class, we have what we call a function. And just by following that logic, you might have already understood what the difference is. A method is practically any function that's defined inside a class, while anything we define outside of a class or in the open will be considered a function. It's not part of a class, it's not part of any system, so we call it a function. And that's really the sole difference between a method and a function. It all comes down to whether you defined it in a class or not. And every now and then you will hear me calling functions methods and methods functions by accident. And it's not the biggest error in the world, so I would not worry about it if I were you. Any sane developer will understand very well if you refer to this as a method and to this as a function. These are just terms we use in programming to make it slightly easier to understand whether a function is part of a class or not. But again, it's not the biggest error in the world. So if you call a function a method or a method a function, it's not going to stop people from understanding you. But just so you know the difference, a method is defined inside a class. That's why we have dunder methods and regular methods, and a function is defined outside of a class. Now that we learned a lot about how classes work, let's try to create a project that uses them. And for this project, we're going to be creating another simple chatbot, except this time we're going to do it using OOP. So to get started, I'm going to import from random the choice function. And then I'm also going to import from datetime the date and time. And the first step will be to create our class called Chatbot. And of course, every class should have an initializer. It's not required actually, but it's good to have this if we want our class to have some custom setup. So this will return none, and it's going to take a name of type string and an age of type integer. For some reason, our chatbot is going to have an age. Maybe in a more complicated chatbot, you could actually change the tone of voice based on the age you input. But for this example, I just thought it would be fun to give this chatbot a more human-like aspect by providing an age. Anyway, we're going to create an instance attribute called self.name and assign it the value of name. And then we will do the same thing for the age. And the very first method we're going to create is going to be called getDescription, in case we want to find out more about this bot. And that will return to us a string. So what we will return here is that self.name is a bot who is self.age years old. And that will be the information we get back when we try to get that description. And next, we're going to create a method called getResponse. And this will take some user input, which will just be some text of type string, and it will return to us a string. So every time we send a message to our bot, it's going to use this method to process it and to give us back a response. And the very first thing I want to do is lowercase whatever the user inputs. So lowered of type string will equal text.lower. And first of all, we're going to check if hello is in the lowered string, then we will return that self.name said hey there. Elif bye is in lowered, we will just copy this section here and return see you. And I also want to be able to ask how old the bot is. So how old are you in lowered? And here we can just copy and paste in this return, and self.name will say I am self.age years old. And some other cool functionality would be to get the time back if we ask about what time it is. So what time is it in lowered? And to do this, we would have to get the current date and time, which will be of type datetime, and that will equal datetime.now. Then we can return that self.name says that the current time is, and we will format this using the date and time format specifier. So now %h, %m, and %s for hours, minutes, and seconds. And between this, I will add some colons. And after that, I want to add something that checks for how are you, in case we want to ask the bot how it's doing. And we will just copy and paste this line here and respond, great, thanks. And for everything else, we're going to return a random response. So here I will create something called random responses of type list of string. And the first response here will be, I don't understand. And then I will add another one that says, would you mind rephrasing that? And below that, I'll write what? And finally, one more variation, which will be, what? So these are 4 of the potential responses that the bot will give you back if you type in something that is not compatible with all the other if statements. And at the end, we're going to just return that self.name said the choice of the random responses. And what the choice function does is pick one of these at random. It picks a random element from a list and returns it. So it's a very convenient function to import. But now that we created the basic functionality of the bot, let's also create a method that runs the bot. And here it's very important you keep track of which indentation level you're on. If you add a function right here, you're going to have nested a function. So that's one issue with creating these really large functions, is that it's easy to get lost on the indentation levels the more you scroll down. But at this point in our programming career, it's perfectly acceptable. So let's go back 1 indentation level and define a new method called run. And this will run the bot. So that will return none. And inside here, all we need to do is type in while true and get the user input of type string, which will equal the input of you. And then as always, we want to check if the user input is equal to exit then we're just going to print thank you for chatting with self.name. And we're going to break out of this while true loop. But if the user does not want to exit, we're just going to grab the response, which will be of type string, and we will call one of the methods from our class, which is getResponse. And here we will pass in the user input. And then we can just print that response. And that was the last method we needed to actually make this class functional. So now let's test it out by creating our if name is equal to main check and by creating a bot. And the first one's going to be a Mario bot. So Mario of type chatbot will equal a chatbot with the name of Mario. And that will have the age of 27. Then before we run the bot, we can also print mario.getDescription and we can call mario.run. Then we can test out the bot. So Mario is a bot who is 27 years old. First of all, let's say hello. Mario's going to say, hey there. And we can ask, how old are you, Mario? And Mario will say, I'm 27 years old. And maybe we just want to ask the time, because that's what people do on the street. What time is it? And Mario will give us back the current time. As you can see, it's quite early where I am. Otherwise, we can type in something random, such as blah, 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 blah. And Mario probably won't understand that because we did not program anything to handle that specific input. We can type in something else that's random, and Mario will give us a variation of the random responses that we provided in the else statement. But then we can say bye, Mario will say see you, and we can exit our loop. And our program will say thank you for chatting with Mario. Then we can move on to some other code if that's what we wish to do. But once again, the benefit of using a class is that we created an extremely easy way to create many chatbots. So in any case, this doesn't have to be Mario. You can even call it Bard, and the age can be 150. And maybe we just want to change the object name to Bard. And the next time we run this, it will work exactly the same way with the custom details that we provided. So now we can say, hello. Bard will say, hey there. And we can ask, how are you? And Bard will say, great, thanks. And it was that simple to create a whole new chatbot using our chatbot class. In this section of the course, we're going to start talking about inheritance in Python. Because at the moment, we know how to create a class, but what if we want to create a new class that is just slightly different from the original class? Do we really want to create a whole new class every time we have a slight variation of the main class? The answer is no, and to save time and energy, we're going to use something that's called inheritance. So first of all, let's get started by creating our main class, or the base class. And this one is going to be called animal. And an animal is going to have a name of type string, and this will return none, as always. Then we can assign that name to self.name and move on to creating a couple of methods. And the first method is going to be called drink. All animals should be able to drink. And here we will print that self.name is drinking. And then we will create one more. And this one will be called eat. So animal is eating, or self.name is eating. So we can agree that all animals can drink and eat, but not all animals will meow and bark. And we don't want to define a new method for each kind of animal sound in here, because it just won't be relevant to a lot of animals, and it gets more and more complicated if you put all of that functionality directly in this animal class. So what we're going to do instead is inherit and make those changes accordingly. So the way that inheritance works is that you create a class, and for this example, we want to create a dog class, and to inherit from any class, you just need to enter it in parentheses. So what we're telling Python here is that we're creating a new class, but we want to use animal as a base class or as a parent class. And with that being done, we still need to create an initializer that takes a name of type string, because once we use a base class, we also need to initialize that on top of initializing the dog. And to do that, we need to use the super call. So super dot init, and inside here we need to pass in the name. Super just refers to the parent class. So now we're initializing the parent class. And you can add other parameters for the dog, but what we have to do is make sure that we initialize the animal. And I'll be going over super later on in this section of the course, so I'm not really going to explain it all just now. Just know that this refers to the animal. But now that we have inherited from animal, we can just comfortably add our own specific functionality for the dog, such as bark. And this will return none. Then we can also print that self.name says bark, bark. And to show you a quick example of what inheritance did here, we're going to create one more method called routine, which will return none. And all we're going to do inside here is refer to the methods that we already created in both dog and animal. So a dog's routine can be to eat, then to bark, and finally to drink. As you could see, we inherited the eat method and the drink method from the animal. Theoretically, we have everything from the animal inside this class, and we can refer to everything from animal inside this class because we inherited from it. But creating a new class allowed us to make it even more specific with its own functionality, because again, a cat will not bark, so of course we want to have a slight variation of that animal called dog. But let's create one more example, and to do that I'm going to copy this class of dog and paste it directly under. And all we're going to do here is change this to cat, and instead of barking we're going to say meow. And here we just type in meow meow. And that would be the variation of the cat. So we still inherit from animal and it still has all the functionality from animal, but we were also able to define some very specific functionality that would only be applied to a cat. And then to actually use them, let's create our if name is equal to main check. All we have to do is instantiate them as we normally would. So a dog of type dog will equal a dog named Boomerang. And the same thing goes for cat. Cat of type cat will equal a cat called Snowball. And then we can do everything that we always do with these objects. We can refer to them and use their methods. But the dog is going to have its special functionality of bark, while the cat is going to have the special functionality of meow. And if we were to run this, you would see that Boomerang was able to bark and that Snowball was able to meow. Otherwise, we can still use everything from the parent class, such as eating, and this works for both the dog and the cat. So now if we were to run this, both of them are able to eat because they both inherit from animal, which means they share that functionality. In the previous lecture, we learned about the basics of inheritance, and we also ran into a new function called super. Now it's time for me to explain what super does in some more detail. And since we're going to be using this type later, I'm just going to import it now. So from typing, I'm going to import the override type. And this is new in Python 3.12, so code editors might still complain about it not existing, but as long as you run it in Python 3.12, this will work. Anyway, let's create a new class called shape. And this shape will have an initializer with a name of type string and sides of type integer. So we can find out what kind of shape this actually is. And then we can type in self.name equals the name and self.sides equals the sides. A very basic initializer. Then we can move on to create those methods, and the first one will be called describe. So we can get a small description of what this is. And we will print that the self.name has this many sides, self.sides sides. I forgot those curly brackets, but no problem, we can just do that. And then we will create something called a shape method. And this will return to us none. And all it's going to do is say that self.name called the shape method. So now we have a shape with two methods that we want to inherit from. So what we're going to do is create a new class below that called square. Class square. which inherits from shape. And then we can create our initializer. And one thing that's really nice about PyCharm is that it will give you this syntax highlighting saying that we did not include the superclass call. And if we just tap on that, it will do all of that dirty work for us. It will add the name of type string, the size of type integer, and it will provide that super call for us. And once again, what super does is refer to the parent class so that we can refer to its initializer and initialize it correctly. And then after we have initialized it, we're going to get all of the functionality back from that shape inside our square. So all super does is refer to the parent class or the base class. But as you probably guessed, there's one thing we don't really need to do here, and that is provide the amount of sides. I mean, by default, a square has 4 sides. That's the definition of a square. So if the user inserts 5 or 6, it kind of defeats the purpose of the square. So what we can do instead is remove that from the initializer and directly enter 4. So this would be the custom setup for the parent class. And also, instead of providing a name of type string, we can just change this to size of type float. And since we know the name is always going to be square, we can just insert square here. Then all that's left for us to do is type in self.size is equal to the size. And that would be the custom setup for this shape. As long as we pass in all the arguments into the initializer of the parent class, Python will be happy. And there's actually one other thing I want to do in this class, and that is change the custom implementation of describe. So what we're going to do is type in def describe, and that's going to return none. And what we're doing here is called overriding. And as of Python 3.12, we have the ability to add the @override decorator. And this is a sort of type annotation that tells Python that we meant to override this method. And once again, this is a type annotation, so it does not affect our code directly, but it will give us some warnings if we do something wrong. So all we're saying here with the @override decorator is that describe was meant to override the original. And then we can print something more custom, such as I am a self.name with a size of self.size. So now that we have our square, let's try to use it in our if name is equal to main check. So now we have our main entry point and we want to create a square of type square, which will equal a square with the size of 20. Then we can type in something such as square.describe. And we can also just type in square.shape method. As you can see, some of these come from the shape class or the parent class, and some of these are unique to the square class. So we can use both of them. And when we run this, what we're going to get is the implementation of the describe method, which we decided to override. Otherwise, we also have the shape method, which we inherited from our parent class, the shape class. But let's create one more example. And the next example I'm going to create is going to be called a rectangle, just so you can get the hang of this. And that's going to inherit from shape. Then we're going to have an initializer, and we're going to do the same thing from earlier. We're just going to hover over and add the superclass call. But once again, this information is quite worthless because we already know what the name of this is going to be, and the sides are always going to be set to 4. So instead, something more useful would be the length of type, not string, but float, and the height of type float. Then inside here, we just need to pass in rectangle and 4 sides because it's obvious. And then we need to create those instance attributes. So self.length will equal the length, and the self.height is going to equal the height. And we're going to override the describe method once again, since we have different information here. And instead, we'll just type in rectangle with parentheses, or to be fair, we don't need to do rectangle because that might change. We'll just type in self.name, parentheses, and the length times the height. So self.length or self.height, x self.length. I forgot which order these go in usually, whether it's length by height or height by length, but you know what I'm trying to do here. Anyway, now we can create a rectangle of type rectangle, and that will equal a rectangle with a height of 10 by 15. And then we can do everything we did with that square. We can either use some of the methods from shape, or we can use the special ones that we created for the rectangle. So rectangle.describe and rectangle.shape method. And when we run this, you'll see that we will get a rectangle back of the size of 15 by 10, and that we were still able to use that shape method with the rectangle. Moving on, let's talk about static methods, what they are, and how to tell Python that a method in a class should be treated as a static method. And to explain it, I'm going to create a class called calculator. And this will contain an initializer that just has the version number of the calculator of type int. And the self.version will equal the version. And for this example, this calculator is only going to have one method, which allows us to add as many numbers together as we want. So def add, and here we're going to use args to say that we can add as many numbers together of type float as we wish. And that will return to us a float. Then we're going to return the sum of the numbers. And that's all we're going to do inside this method. But as you might have noticed, add has that ugly squiggly line that says that method add may be static. And what it means by that is that we created a method that does not refer to the instance in any way. In other words, it doesn't have to be inside this class because it does not affect the class and is not affected by the class. It practically has nothing to do with the class from Python's point of view. And if you were to try to use this quick fix, it would move it outside of the class. But we don't really want that because that's functionality that should belong inside a calculator. So we're going to put it back inside the calculator, and what we're going to do instead is annotate it as a static method. And here we're explicitly telling Python that we know that this does not have anything to do with the class, but we think it should be grouped with the class because its functionality fits this class best. And having random functions out in the open is not always the best idea. Sometimes you want a group functionality that goes together. So with static method, we can do just that. And when you annotate any method as a static method, the self keyword is going to become redundant because we're not going to have to use it. And again, if we were to create any method that actually uses self, such as getVersion, and we return self.version, since this actually requires that we use the instance of this class, we cannot convert this into a static method. The only time we can convert it into a static method is if we don't use that instance at all. For example, if we return 10, you will still get that warning that getVersion may be static because we're not using the instance in any way, which means Python thinks we might have made a mistake with adding functionality that shouldn't belong in the class. But otherwise, if we were to create our if name is equal to main check and use the functionality from our calculator by creating an instance of this calculator, and we will just say that this is version 1, we can now still refer to all of the functionality inside the calculator as always. So here we will create a result of type float, and we will call calculator.add and add 1, 2, 3, and 4. And we can of course print that result. And what we will get back is the sum of all those numbers. And there's actually another benefit of creating static methods inside your class, and that is that you won't have to instantiate the class to actually use that functionality. For example, here we created an instance of the calculator by instantiating that calculator, but we did not have to do that. We can actually remove this completely and just use the calculator class directly, because this is a static method that does not rely on the instance. And if we were to run this, we'd get the exact same output. If we were to try to use this approach with getVersion, we're going to have to insert an instance. It's not going to know what self is because we never set up that instance. We're referring directly to the class, and that does not count as an instance. But with a static method, we do not need self, so we can call it directly from the class. In this lecture, we will be learning about class methods and how we can use them in Python. And to get started, we're going to import from typing the self type. Then for this example, we're going to create a class called car. And this car is going to have a limiter, and that will be of type integer with the value set to 200. And we're defining this because we don't want our cars to go faster than 200 kilometers an hour. So we're going to define this as a class attribute so that all the instances of this car will share the same limiter. Then right below that, we can create our initializer, and that will take a brand of type string, and it will also take a max speed for the car of type integer, and that will return none. Then the self.brand is going to equal the brand, and the self.maxSpeed is going to equal the max speed. So now that we've created the basic setup for a car, let's create our very first class method. And to do so, we're going to use the @class method decorator. And then right below that, we can define the method that we want to be treated as a class method. So here we'll type in def change limit. And this time you're going to notice something special. And that is that instead of having self, we're going to get the actual class as the first argument for this method. And this is going to refer to the car class, because now we're creating a method that affects the actual class, not the instance. So in case we want to change the limiter, we can create this class method that takes a new limit of type integer, and that's going to return none. And here we can refer to our class attribute, the limiter. So cls.limiter is going to equal the new limit. And that's all we're going to do inside this method. And the reason we had to do this via the class method is because if we were to do this via a regular method that works with self, this self.limiter would not refer to this limiter here. This would create a new instance attribute that would only belong to the current instance. So if we create a Toyota and we update the self.limiter with a value such as 150, only the Toyota is going to be updated, not the rest of the cars. While with a class method, this will effectively update all of the cars because we're referring to the class limiter, not to the instance limiter. But moving on, below this class method, what we're going to do next is create a method called displayInfo. And that's going to return none because we just want to print information regarding the current instance of the car. So print the f string of self.brand, and then we will use the information such as the max speed, which will be the self.maxSpeed, and the limiter, which will equal the self.limiter. And I know this might sound confusing, but here, when we refer to the self.limiter, the only one it can find is the one that was created in the class. So it's going to refer to this one. But if we were at any point to create something called limiter as an instance, this one would default to using the one we created here. And even if it doesn't exist in the initializer, just by creating it somewhere else in the class, such as down here, we'll effectively add this as an instance attribute to the current instance. Anyway, just note that if we don't define the self.limiter inside our class as an instance attribute, it's going to use the one that's defined as a class attribute. But now we have our car class. So let's test it out by creating our if name is equal to main check and creating some objects. So the first object is going to be a BMW of type car, which will equal a car with the brand of BMW, and the max speed will be set to 240. Then we're going to do the same thing with Toyota, except this time the max speed will be set to 190. And right below that, we're going to display the info of each one of these cars. So display info, duplicate that and change it to Toyota. And when we run this, we should see a BMW with a max speed of 240 and a limiter set to 200, and then a Toyota with a max speed of 190 with a limiter also set to 200. And for the Toyota, it might be a bit irrelevant since we cannot reach 200. But now there's something else we can do, and that is change delimiter. So we can refer to the car class and type in change limit. And all we need to insert is the new limit for all the cars. So we can type in 150 here, for example. And the next time we display this information, all the cars are going to have that new limiter. As you can see, the next time we print these two cars, the limiter is now set to 150 for both of them. Although it's important to note that because we wrote it as a class method, if we were to use it on an instance such as Toyota, it would still end up affecting all of the cars. So even if we called change limit on the Toyota, it affected the class attribute, which means all the cars are going to feel this change, since this is a class method. So just keep in mind that the class method affects all the instances, regardless from where you call it. And something else to note is that this is not the same thing as referring to Toyota.limiter and changing it to 150. In this case, we're creating a new instance attribute called limiter only for Toyota, which means that when we run this, only the Toyota is going to have that updated speed. It's no longer using the class attribute. It's now using an instance attribute, which we created right here. And the reason this works is because you can create attributes on the spot outside of the class. For example, you can even say Toyota.fuel is equal to 5. Even if we did not define this inside the class, this will define it as a new attribute inside the class. And that's why referring to limiter will create a whole new instance attribute inside that current object. But now that we have a basic understanding on how class methods work, let's take a look at another use case that we have in Python for class methods. And this time we're going to be looking at something that's called a factory method. And factory methods are used to create instances of classes with slightly different setups. So for now, I'm just going to replace all of this with an ellipsis because we need to update that later. And I'm going to go back up to our class. And inside our class, right below the change limit method, I'm going to create another class method. And here we're going to create something called auto generate max speed. And once again, this is going to take the class as its first argument. And what it's going to depend on is the brand that we insert. And then this will return self, which will be an instance of the class. So what we're going to do inside here is give the user the ability to insert a car brand, and based on that car brand, we're going to auto-generate the max speed for that car, so we don't have to manually define it. And the way we're going to do this is first by creating something called lowered of type string, which will equal the brand dot lower, just to make it easier on ourselves to recognize car brands, because of course BMW with uppercase letters is quite hard to recognize if we're checking for a BMW with lowercase letters. And then we're also going to define a default. So the max speed of type integer will equal 200. That will be the default for all the cars that we do not have information about. Next, we can check the brand and then provide the appropriate speed based on that brand. So if lowered is equal to Toyota, we're going to return, or actually we're going to set the max speed to 270, because now we are dealing with race cars. Elif lowered is equal to BMW, we will set the max speed to 290. Elif lowered is equal to Volvo, we can set that max speed to 300. And for all the other scenarios, the max speed is going to remain at 200. But the last thing we need to do here is actually return the class with the custom setup. So here we can return CLS, which is the class, with the brand and the max speed. And that's all the code we needed to create a class method or a factory method that helps us with creating new instances with custom setup. And to use it, we're going to create some objects. One's going to be called Volvo of type car. And this time, instead of using the default constructor, we can refer to the car and we can use auto generate max speed. And here we can pass in the car named Volvo. Then we can type in volvo.displayInfo. And when we run this, it's going to use that factory method to actually find out what the max speed was for a Volvo. And in a real life project, you'd probably have a database with hundreds of cars. But for this example, we only have 3. And we can also change this example to something else, such as some random car. And this time we're going to insert something such as a Ferrari. And just like that, it's going to use the default instead of the max speed from our database. But if we were to change this to something such as BMW and insert BMW here, the next time we run this, it's going to find that car in our database and it's going to create a new instance using the information that we provided from our database, which will end up giving it this max speed. In this lecture, we're going to be learning about abstract methods, and these can be used with abstract classes. And to keep it simple, abstract classes can just be considered as blueprints for other classes. It just makes sure that the classes that are inheriting from another class actually follow the structure of the parent class. But to use abstract methods, we actually need to deal with a few imports. And these imports will come from the ABC module. So from ABC, import ABC and abstract method. And I need to put a T here for code completion. Then down below, we're going to create a class called appliance. And this will inherit from ABC. And ABC stands for abstract base class. And that will help us with creating this blueprint. So first of all, we're going to create our initializer, and inside here, it's going to take a brand and a version number of type integer, and that will return none. Then we will create the instance attribute of self.brand and give it the value of brand. And the same thing will happen to version number. So that will equal version number. And we will also create a third attribute, one that's called isTurnedOn. Because whatever the appliance might be, we're going to want it to have both an on state and an off state. So this will be of type Boolean, and it will initially be set to false. And moving on, we're going to create a few abstract methods. Because once again, this here is a blueprint. It's not actually going to implement any functionality. It's just going to be used to tell other classes what they should do. So here we'll create something called an abstract method. And to do that, we need to use this decorator over here. And then we can define a method called turnOn. And that will return none. And this won't have an implementation. We will just enter an ellipses because the implementation will be handled by whatever class inherits from this appliance. And we're going to do the same thing for the turnOff method. So right below, abstract method, turnOff. Again, without any of the implementation details. We're just creating the blueprint here. But now that we have our blueprint, we can actually create a class that inherits from this appliance, and we can try to implement these methods in that new class. So below this appliance, we're going to create a class called lamp, which inherits from the appliance. Then we can create our initializer, and as always, it's going to give us that squiggly line, which allows us to easily add the superclass call, and this will return none. But something else you'll notice is that lamp is also going to contain this squiggly line. And what it's going to say is that class lamp must implement all abstract methods. And that's because we defined 2 abstract methods here, but we did not implement them just yet. By inheriting from appliance, we signed a contract with Python saying that we will implement those methods. And I don't remember if tapping on this will actually add them for us or not. And the answer is no. So I'm going to remove that and I'm going to manually implement them. So down below, we can just create both of them. We can type in def turnOn, which returns none. And for now, I'll just add an ellipses and def turnOff. And just by doing that, the warning will go away because we implemented all of the functionality. I mean, we didn't really implement it just yet because we just put a placeholder, But as far as the class knows, we created these methods and we added the functionality we wanted inside of them. But I'm going to fill this out with some real functionality. So if self.isTurnedOn, then we're going to print that the self.brand is already turned on. I mean, if the user tries to turn on a lamp that's already turned on, we're not going to turn it on a second time. We're going to warn them that it's already turned on. Else, self.isTurnedOn will be set to true. And we will just print that the self.brand is now turned on. And then we need to do something very similar for the turn off method. So if self is turned on, then we will set self is turned on to false. And we will print this print statement over here, except we will replace on with off. So self.brand is now turned off. Else it's probably already turned off, so we can do the exact opposite of what we did earlier and say that the lamp is already turned off. And just like that, we can now test our function or test our class in our if name is equal to main check by creating an instance of a lamp. So lamp of type lamp will equal a lamp with the brand being set to zlight and the version will be set to 1. Then we can test that lamp by typing in lamp.turnOn, and we will duplicate that to see that we can't turn it on twice. And then we will type in lamp.turnOff, and we will do that twice. And below that, we will turn it on and off like a maniac. And when we run this, we should see that zlight is now turned on. And since it's already turned on, we can't turn it on twice. So we will get this other message printed. Otherwise, we can still turn it off. And since we tried to turn it off twice, it's not going to allow us to do that. And finally, since it's turned off, we can turn it on and turn it off easily. So the lamp works as expected. But let's create one more example so you really get a good understanding on how abstract methods and classes work. And for the second example, I'm going to create a class called oven, which also inherits from this appliance. And we need an initializer, and we're going to force implement it by tapping on add superclass call. Now, as I mentioned earlier, we are forced to implement all the abstract methods that we defined in appliance. And if we were just to create an oven now of type oven and say that's equal to an oven with the name of Bosch and with a version number of 2, Python wouldn't even allow us to run this code. As you can see, we will get this type error that we cannot instantiate abstract class oven without an implementation for abstract methods turn off and turn on. And Python is actually kind enough to tell us which methods we are missing. So abstract methods are a great safety mechanism that prevent us from trying to use classes that did not implement all the functionality from the parent class. Anyway, let's go down here and implement those methods. So def turn on and def turn off. And now if we were to type in oven.turnOn and oven.turnOff, Python wouldn't complain and the program would run smoothly. Of course, we didn't implement anything, we just added a placeholder, but as far as Python knows, we created those methods, so it's happy. But before we conclude this video, there's actually one last thing I want to mention, and this is an extremely good habit that you should form, which is instead of using a placeholder such as the ellipses or pass, what you should always do when you don't want to implement code immediately is raise a not implemented error. This is one habit I absolutely recommend you form when you're creating functionality, but don't know what should go in there just yet. So here we would type in need to add functionality for turn on. And we would do the exact same thing for turn off. Raise not implemented error, need to add functionality for turn off. I mean, of course, you can add whatever kind of message you want in here when you are raising this error. Just make sure it raises a not implemented error if you did not add the functionality just yet. And the reason we do this as professional programmers is because someday when you're creating a very big program and you're referring to your class which you created, you might not always remember that you didn't actually implement all the details, which means that when you call it, you're not going to get an output and you're never going to understand why. Having no output is probably the worst case scenario for a programmer, because that means they have no information regarding what went wrong in their program. While explicitly telling yourself or anyone else what went wrong will make it easy to immediately understand where that has to be fixed. So right now, if we were to run this, you would see that we still need to add functionality for turn on as soon as we try to call it, because we did not implement those details. So in general, always raise a not implemented error if you do not have the implementation details just yet, because someday this will save your life when it comes to fixing your code. But when you're creating an abstract method, you are required to pass in an ellipses or pass. One of those two, and that's perfectly fine. You would not pass a not implemented error there, because you are actually never meant to pass any code inside this abstract method. All the abstract method does is say that all the classes that inherit from it must implement this method. It doesn't care how those classes do it, it just cares that they actually include it. What I'm about to show you in this video is one of the crazier concepts in Python, and this one is called name mangling. And there are a couple of reasons that one might opt in for name mangling. And the first one is to encapsulate the data, making it harder to access objects that should not be accessed outside of the class. And the second reason would be to prevent name clashes in the case of inheritance. But I'm going to be explaining all of that through examples, so let's get started by creating a class called car. And these cars are going to be built in the year of 2000 by default. So we will create a constant at the top called year. And this time I'm going to create this constant with 2 leading underscores. And later on, when we actually try to use this class, it's going to trigger the name mangling. But we're going to set this year to be an integer, which will be equal to 2000 initially. Then right below, we will create that initializer. And that will take a brand of type string and a fuel type of type string. And then we will return none. And here we're going to type self.__brand is equal to the brand. And we will do the same thing for the fuel type. So self.__fuel type is equal to the fuel type. And again, by using these double leading underscores, we're telling Python that we want to mangle both of these variables, or at least that we want to mangle the names. And right below both of these, I'm going to create one that is regular called a var. So self.var of type string is going to equal red. And we're going to come back to this later because this variable is actually going to break our code later. And name mangling is going to fix the issue that was created by this variable. But for now, let's continue with this class. So I'll create a method called drive, which will return none. And here we'll type in print driving self.__brand. So you can use these attributes the same way as always inside your class. Nothing really changes inside the class. And then we will create another method, except this one will be created with a double leading underscore, and it will be called getDescription. And that will return none. So note that you can also use name mangling with methods. It doesn't just have to be with attributes, you can also use it with methods. And here I'm just going to print that the self.brand has the self.fuel type. And finally, we will create one more method, which will be called displayCaller, and that will return none. But what we're going to do inside here is print that the self.brand is the self.var capitalized. So it looks quite nice. And right now the self.var is set to red. So by default, this variable is going to be red and then capitalized. So now we created a car that has a lot of double leading underscores. But what does that actually do? Well, to find out what it does, let's create our if name is equal to main check and create an instance of our car. So the car of type car is going to equal a car named Toyota, and the type is going to be electric. So now we have an electric Toyota. And the first thing we're going to do is test drive it. So car.drive. And if we run this, you can see that we can drive this Toyota without any problems. But now suppose we want to get the description of the car. So what we're going to do is print car, and we actually don't have any way of getting the description because we performed name mangling on all the variables and methods that had that double leading underscore, making it really hard to access via dot notation. As you can see, get description will not show up in the suggestions, and neither will the brand, the fuel type, or the year, because Python performed name mangling on them. So even if we were to copy the method name of getDescription and type in car.getDescription with 2 leading underscores, Python would not be able to find this. And if we were to run this, you'll see that car has no attribute getDescription, and it will actually give you a hint of what the real name actually is. So to actually use whatever has been name mangled, we need to include the class name in front of the mangled name. And in this example, it would be underscore car underscore underscore getDescription. Here we have the class name with a leading underscore, and then we have the method that we mangled. So under the hood, all Python did is change the original name to this mangled name, making it harder to access, and even the code editor has a hard time trying to find this. And we don't really need to print the car.getDescription because that triggers a print statement, so we can put that below. And we can also print the car.underscore to get that brand attribute back. But now when we run this, it will work like normal. We will get the brand of the car, and we will be able to use the getDescription method. So with name mangling, we made it much harder to use these methods outside of the class. And in general, you would do this with information that you just want to keep inside the class. For example, you might never want whoever is using this class to access the brand attribute or the fuel attribute directly, or even the year attribute. You might want them only to use this within the class, and name mangling helps ensure that you use it only inside the class. So theoretically, if we were to use getDescription like this, or if we were to name it like this, we would only expect to use it within this class. So for example, instead of just displaying the caller, you might also call double underscore or self.double underscore getDescription. As you can see, we could refer to it within the class without any issues. But as soon as we go outside of the class, it becomes much more difficult to refer to getDescription or to refer to the other ones that we provided a double leading underscore for, such as the fuel type or the brand. Anyway, let's remove this from display caller, because now I also want to show you another place where name mangling can be very useful. So what we're going to do here is create a class called Toyota, which inherits from car. And here we're going to create an initializer, and we're going to tap on add superclass call and just add the annotation of returning none. But here we're going to do something quite naughty. And this can be an honest mistake in a real world example. But what we're going to do here is pretend that we had no idea that self.var was defined inside the original class. And inside here, we're going to type in self.var equals 100. So this will coincidentally have the same name as the variable in the car class. And this will be the breaking change, because now if we were to create our Toyota of type Toyota, which will equal a Toyota. And I guess here we don't really need to supply the brand. We can just remove that and say that the brand is Toyota, making it easier just to specify the fuel type, which will be electric. But once we instantiate this object and we type in toyota.displayCaller, you'll notice that this will break our code. Int object has no attribute capitalize. And that's because we accidentally broke our implementation by creating a variable that coincidentally shares the same name as the one from the parent class. And what sucks about this is that we get no warning whatsoever about this breaking change. So an easy way to prevent this from ever happening is by adding that double leading underscore, which tells Python to mangle this name. And again, mangling the name means that under the hood, it's going to type in underscore car double underscore var. This will be the new name of this attribute as soon as we run our code. And we need to remember to also edit it everywhere we used it. But now the next time we try to run our code and we try to display that caller, it will say that Toyota is red, because now it's referring to the correct attribute. And that also gives us more freedom to create random attributes inside our Toyota class without messing up the functionality of the car class. And the last thing I want to mention is that if you want to use a mangled name inside your subclass, such as the year that we defined as a class attribute, it's not going to be that simple. For example, if we try to return, let's say the self.double_year, and actually I meant to return an integer, this is not going to work. PyCharm will be able to understand what we're referring to, but once we run this code, this will raise an exception because this will not exist. Python is going to mangle this name before we can actually refer to it with its current name. And we can verify that by printing toyota.getYear. As soon as we run this, we're going to get an attribute error. So if you're planning to use the year in subclasses, you're going to have to follow a different naming convention, which does not mangle the name, but which will tell the developer that it was only meant to use within the class. And that is by using a single leading underscore. This doesn't do anything magical, it's just a note to the developer that it should only be used within classes and subclasses. So now we can actually refer to that year with no problems, although it will not perform name mangling. By this point, we've covered a lot of Python's core functionality. Now it's time we start looking at the built-in functions that come with Python, because chances are you will use these a lot when you are coding. And it's just a good idea in general to know what tools you can use when you're programming in Python, because building functionality that already exists from scratch in most cases is going to be a complete waste of time. Anyway, in this lecture, we're going to be covering the print statement because there's a lot I did not explain regarding it, and it's just good to know everything you can do with it early on when you are learning programming. Now, first of all, we know that with print, we can print some messages to the console. And that can be a string, it can be an integer, it can be a Boolean, it can be any object that you want to display in the console. So if we were to print hello Bob and we were to run this script, it would print it to the console. Also, the first argument of print is args. I mean, right here it's called values, but under the hood it uses args. So we can pass in an unlimited amount of arguments by default, which means if we put 1, 2, true, a list of random letters such as A and B, this will be interpreted as arguments. And by default, it prints them out with a space in between each one of them. But now suppose we have 3 letters such as A, B, and C, and we do not want to have that space in between them, but instead we want to have a custom separator. Well, we can use the keyword argument of sep, which stands for separator, to insert any kind of separator that we want. So you have the option to leave it empty, and that will just glue them together, or you can add a small dash, and that will insert a dash in between each one of these elements. You can even add a space and a dot and another space, and you will end up with some really cool formatting. But we're going to leave it as the dash, because the next thing I want to show you is how we can add an ending to our print statements. And by default, every time you print something, it ends with a new line, which means that if we were to print something else, such as Bob, this would be printed on the second line, because by default, print inserts a new line for us automatically. But we can also customize that part of the print statement by defining an end. And the default is this \n, which stands for new line. If we were to run this, we would get the exact same output. But in front of the new line, we can even add a full stop, and that will be added to the end of the print statement after all the elements were printed. So you can even add 3 exclamation marks, and that will be added to the end of the print statement. So you can define your very own end. And in case you don't really want a new line, you can also just remove it completely and pass in an empty string. And you'll see the next time we print Bob, it's actually going to be added to the end of the original print statement. But Bob by default will have a new line. So under Bob, if we were to print Sam, Sam would be printed on a new line. And there's actually 2 other arguments we can pass in. One is file and one is flush. And I'm not going to be explaining these because chances are that you will never use these two in your entire programming career. But there's still one neat trick I want to show you that we can use with the print statement, and that's with unpacking arguments. So suppose you have a list of people of type string, and you want to print all of these people with a separator. Well, right now, if we were to print these people, we would just get the element of that list back. But what if we actually want to print the elements with a separator and with an end? Well, to do so, all we need to do is add the asterisk in front of the people, and this will unpack them into arguments. So doing this is the exact same as doing this. It's inserting them as arguments, not as a list. And because of this, we can now add a separator, which by default we will have as a comma, and we can add an end, which can be a full stop. So the next time that we print this, we will have a very nicely formatted list in the console. Recently, we've used the built-in enumerate function once or twice throughout this course, but now it's time we actually learn how to use it in more detail. Now suppose we have this snippet of code, and this snippet of code contains some elements, and we want to iterate through these elements, and for each element, we want to associate it with a number in a growing order. Well, we can definitely keep track of an integer, and while we loop through it, we can also increment that integer and associate it with the element. This works perfectly fine, but it also requires us to create a lot of code for nothing. It still gives us the result we are looking for, but just with too many lines of code, and it's just not really efficient. So what we're going to do instead is create an enumeration. And to create an enumeration, we can just create a variable called enumeration of type enumerate, and that will equal enumerate. And then we can pass in the elements. So this will enumerate the elements. And if we were to print that, we wouldn't get anything useful back. We would get an enumerate object at this memory address. And to actually see the values it contains, we're going to have to convert this to either a tuple or to a list. So right here, I will turn it into a list. And when we run it, you'll see that all our elements will be paired with a number in an increasing order. And by default, it starts at 0 and counts upwards. But if you want, you can also specify a start. So instead of starting at 0, you can tell it to start at 1. And the next time you run this, it will contain a list of tuples that start with the value of 1 and count upwards. But now that we know that creating an enumeration creates a list of tuples, let's see how we can use that in a for loop. So with for loops, we are not required to iterate through one element at a time. We can actually grab multiple values as we iterate through any object that is iterable. For example, here we can type in for I and element, and you can kind of consider this as a tuple in itself because it's grabbing the first element and the second element in enumerate the elements. So we know that this gives us an object that contains tuples with an integer and a string. And the first one is the integer and the second one is the string. Or I mean, if you had different elements, the element would be something else, but in this case, it's a string. But now inside the for loop, let's print these elements. So I and the element. And when we run this, we will get a similar result to what we had when we created our first for loop without enumerate. And again, by default, the enumeration starts at 0. So here we have two options. The first option is to add 1 to each iteration. And by doing that, it would update each value by 1. And this approach is fine. It's readable. We understand exactly what's going on, but it's not necessary because what we can do instead as the second option is just specify a start. So we can say this should start at 1. And the next time we run this, we will get the exact same result. And adding 1 to I would probably not affect the performance of your script that much, but it will still use some of your computing power. So just by providing a start can even be seen as a much more performant approach. In this lecture, we're going to be learning how we can easily round a float in Python using the built-in round function. So to get started, suppose you have some floats. And as you can see, these look quite beautiful. Now imagine we want to add all of these together and print the result. As soon as we run this script, we're going to get this beautiful answer back with I don't even know how many decimals. So all jokes aside, this is really unpleasant to read. It's actually really hard to understand what's going on there. It would just be so much nicer if we could round it to the nearest hundredth. And that's exactly what we're going to do. So instead of printing the result directly, what we can do instead is round that result. So here we can type in rounded of type float is going to equal the round function followed by the result and the amount of decimals we want to include. So if we want to round it to 2 decimal places, we will insert 2. And then we can print this rounded result. And what we should get back is a much nicer number, such as 265.56. And as always, we don't have to create a new variable for this. We can actually insert it directly into the print statement. And that's also an acceptable solution. As you can see, we get the same output. But I'm going to duplicate this a few more times because I want to show you what happens when we round it to 1 decimal place, to 0 decimal places, to -1 decimal places, and to -2 decimal places. So let's run this and see what it outputs. The first one we already went through. It rounded it to 2 decimal places and gave us this simple number. If we want to round it to 1 decimal place, it's going to round it to 1 decimal place. If we insert 0, it's just going to make a flat number, such as 266. Keep in mind that this will always return a float, even if you round all the decimals to the nearest whole number. Now, where this actually gets very interesting is when you start passing in negative arguments, such as -1 and -2, because with -1, we start rounding the whole numbers. So instead of 266, that will be rounded to 270. And if we insert -2, it's going to round it to the nearest 100. And I discovered that you could do this maybe 3 years after I learned about Python. So I'm actually really excited that I can share this with you early on in your Python journey. But anyway, using the round function is really just that simple. All you need to do is insert a number such as 2.3333, or it can actually be any float, and then specify how precise you want it to be. So here in this example, I think 2 decimal places are fine. So we will insert 2, and the output will look beautiful, or at least it will be readable. Up next, we're going to be learning about ranges. And to create a range in Python, we can use the range function. And that will provide us with an easy way of creating ranges of numbers in Python. So let's take a look at how we can create and use these ranges. So first, let's take a look at the problem it solves. Imagine you want to create a range of numbers from 1 to 5. Well, the first thing you might do if you're not experienced in Python is type in numbers of type list of integer and just manually type them out. So 1, 2, 3, 4, and 5. And that's perfectly fine. I mean, it works, we get our range of numbers, but now imagine that your task is to create a range of 100 numbers or even 1,000 numbers. There's absolutely no way we're going to type all of those out, not to mention that we might accidentally miss a number. So there's a lot of things that can go wrong by manually creating those ranges. So instead, what we're going to do is create something called myRange, which is going to be of type range, and that's going to equal a range from 1 to 6, because the upper bound is exclusive, which means it's not going to be included in the range. And the first time you print a range, you'll notice that what we're going to get back is some sort of representation of the range, which is actually quite convenient to read, but doesn't give us much information regarding the range. And that's because the range does not return a list, but it actually returns a range object, which can be treated as an iterable, which means it can be looped through, and so on. But if you want to see what it looks like as a list, you can just duplicate that and cast it to a list. So now when we run this, you'll see that we will get those 5 numbers back printed to the console. And if we want to print 100 numbers, we just need to replace 6 with 101, and that will create a range from 1 to 101, with 101 being excluded. So the next time that we run this, you'll see that we will get this huge range back, or this huge list of integers back. So the representation of the range is probably preferred in most cases, since printing out huge lists such as this one isn't always nice to read. But keep in mind that you are not required to specify both a start value and an end value. You can also just pass in a single value, and this will generate a range from 0 to 5. So now if we run this, you'll see that it will start at 0, and end at 5. And this will be the list that we will get back if we convert it to a list. But there are actually some other useful tricks that we can use with ranges. And in this example, I'm going to create a range from 0 to 10. And this time I'm going to specify a step. So by inserting 2 here, we're going to create a range that counts up by 2. And when we run this, you'll see that in the console, it will start at 0, then it will go to 2, and then to 4, 6, and 8. But now suppose you want to create a negative range, one that counts down. Because the first solution one might think is to go from -5 to 0. And while this does provide all the values in the negative range, it's still counting upwards. But what we want to do here is count from 0 to -5. But doing this will not work with the range. It's actually going to return to us an empty object. And that's because by default, range will only count upwards. In other words, the step is always going to be equal to 1. And if you try to count upwards from 0 to -5, that's just an operation that does not make sense. So in this case, what we have to do is add -1 to tell Python that we want to count down from 0 to -5. So the next time we run this, we will get those negative numbers back. And this time it will actually count downwards. And finally, remember that ranges are iterable. That means we can easily create for loops with them, such as for I in range 3 print I. This will iterate through that range and print each iteration out to the console. So now if we were to run this, we would get 0, 1, and 2, because we were able to loop through that range and grab each element from it and then print it to the console. And the nice thing about iterables, such as ranges and enumerations, is that we do not need to convert it to a list or to a tuple before looping through it. In a previous lecture, I showed you how we can slice iterables. Whether it's a list or a string, we can get back a certain section of it or a slice of it by using that slice notation. For example, we might have a list of numbers of type integer, and that will equal 1, 2, 3, 4, and 5. And if we only want to get a few elements back, we can print those numbers at the index of 2 to 4. And that will give us back that slice of the list. But now it's time I show you how we can create a reusable form of this slice. Because imagine you want to use this slice in many different places. Well, as always, if you had to copy and paste this in more than one place, it becomes quite inefficient, because later if you have to change it, you're going to have to change it everywhere. So what we're going to be learning how to do here is how to create a slice object. And for this example, instead of using numbers, we're going to use text. So text of type string is going to equal hello world. And that's the text that we're going to want to slice. And the first slice that we're going to create is going to always get back the first 3 letters or characters of the string. So we're going to call this one first 3, and this will be of type slice. Then here we can create that slice object by using this slice type. And the first 2 arguments are the start and the end. So just like this, we're getting everything from the index of 0 to 3. So now if we were to print the text down below, we can just insert that slice instead of manually specifying 0 to 3. And that makes it much more reusable, because now if we were to print this, we would get the first 3 characters back of that string. So now we can use this slice with any iterable. But now suppose we want to reverse the text. Well, then we can also create a reverse slice of type slice, which will equal this slice. And as you might recall, the syntax for reversing an iterable is : -1. So how would you do that using this slice type? Well, anywhere you see nothing, you're going to have to use the none type. So none, none, -1. And that will be the equivalent to using : -1. So now we can print the text with the reverse slice. And the next time we run this, you'll see that we will have our text reversed. And it was really just that simple to create a slice object. But let's create one more example where we step 2. And we're going to call this step 2 of type slice, which will equal the slice notation of none, none, and 2. So that the next time we print this text with the step 2 slice, our program is going to step 2 and give us this output. And again, that's super cool because now we can reuse this slice wherever we want. If we have other text, we can use it there. So instead of just using it on this text here, we can duplicate that and say second text. And I'm going to remove everything else. But as you can see, we can reuse this. And at any point, if we want to change it, we just need to change it in one place. So instead of reversing it, we can reverse it with a -2 step. And the next time we run this, we will get this output backwards with a -2 step. Up next, we have the built-in globals function. And this tells us exactly what is visible inside the global namespace. And since I'm going to be using the any type later, I'm going to import from typing any. But first of all, let's print the globals and see what it gives us back. And as soon as we run this, you'll see that it's going to give us back a dictionary. So this is returning everything that is visible in the global scope, which is the outermost layer of our script. And you can scroll through this and you'll see everything that we have available. And at the end of this dictionary, we also now have the any type, which we imported from the typing module. So now we loaded that also into the global namespace. And if we were to do something such as from math import everything, this is going to pollute the global namespace. So when we rerun this, you'll notice that at the end, we're going to get all the functions from math. And in general, this is a bad thing because once again, it can easily shadow other functionality that you have in your script. So I recommend you try your best to not pollute the global namespace. Anyway, look what happens when we define variables and functions in the global namespace. And before we do that, I'm going to revert this to any. But here, we're going to define some text of type string, which will equal Bob. And I'm going to create my list, which will be a list of type integer. That will equal 1, 2, and 3. Then I will also create a function called function that returns none. And I will insert a placeholder. But now if we run our script, you'll notice that if we scroll all the way to the end, our globals are going to contain everything we defined in the global namespace. So it has my list, it has the function, and in front of that, it has the text with the value of Bob. And there's actually a way to make this easier to read, which might make it a little bit easier to understand. And to do so, we're going to create a variable called my globals, but I wasn't supposed to delete all of that. So we're going to create it down here, my globals of type dictionary, which will have the type of string and it might contain any value. So this is the type of the key and this is the type of the value. And then that will be a dictionary of the globals. Now we can print my globals and we're going to get the exact same thing back. But the reason I converted it to a dictionary is because now we can use it in key value pairs, which means we can do something like this. For key value in my globals dot items, and items converts each key value pair to a tuple, so we can grab it as a key value pair. We're going to print the formatted string of k and v, so that the next time we run this, we're going to get everything in a vertical format instead of that horizontal format, which was really difficult to read. And as you can see at the bottom, we have the functions and the variables that we defined in the global scope. Otherwise, we have everything else, such as any from the typing module, and so on. This is everything that is visible in the global scope. And I know you're probably asking, why did I convert the globals to a dictionary when it already returns a dictionary? And the reason is that we're creating a copy with this dictionary. We're not using the actual globals here, because if we were to just use the globals directly, then we would have a runtime error that the dictionary changed size during its iteration. So as we loop through the globals, that can easily change. That's why we need to create a sort of copy of the globals before we iterate through it. Kind of like when you iterate through a list and modify it at the same time. It never really leads to anything good. Anyway, that's why I created a dictionary from the globals instead of just using the globals directly. Previously, we talked about the globals function. Now it's time we take a quick look at the locals function. And to get started, let's try printing the locals in the global namespace. And what we're going to get back is essentially everything we got from the globals, or actually it's identical to what we got when we printed the globals, because here we're using the locals in the global namespace, meaning that we're getting everything that is local to the global namespace. So in the outer scope, it essentially makes no difference whether you use the globals or the locals. It just tells you what is visible in this current namespace. Now, if we were to create a function called add, and that will take a value of A and a value of B, and that would return none to us because we would just want to print the result. But let's continue inside here by creating a result of type integer, which equals A plus B. And let's print that result. So A plus B equals the result. And on top of printing the result, we're going to also find out what is local. And to do that, I'm going to print that add has these locals. And right below, we're going to call it. So add 1 plus 1. And when we run this, you'll notice that add has these local variables, A, B, and result. These are the locals to add. Everything inside this function is what will be considered local to this function. And this information is not visible outside of the function. It is local to the function. Otherwise, we can also add a print statement that says add can see, and we're going to print the globals. And whatever we see here is what this function can use. So if we run this, you'll see that add can see everything from the global namespace. And if we were to add some random variables up there, such as example of type string, which equals Bob, you'll notice that when we run this function and scroll all the way to the end, that Bob will be visible inside the scope of this function. And all that's saying is that we can actually use it inside here. So if we wanted to print, let's say this example, which is Bob, we can do that. And also, as you might have noticed, add is also visible inside this function. And that's what allows us to perform recursion. So this was defined in the global namespace, which means we can also refer to it inside here. So if we wanted to, we could add 1 plus 2 inside add. I don't recommend you do this because it's going to create an infinite loop, but all I want to say is that with globals, we can see what can be used inside this function from the global namespace. Otherwise, we have the locals, which tells us what was defined inside this function and everything that's visible inside the local scope. Moving on, I'm going to show you some great helper functions that can help simplify longer Boolean checks. So suppose we have some Booleans, and these Booleans are just requirements for us to use some internet. For example, we need to check whether the Wi-Fi is enabled, whether the user has electricity, and whether they have an active subscription. So if all of these are set to true, then they should be able to connect to the internet without any problems. So a simple way to do this would be to type in if Wi-Fi is enabled and the user has a subscription and the user has electricity, then we can print that they connected to the internet. And since all of these are set to true, this will run perfectly fine. At any point, if we set one to false, this check will fail, so we're not going to get any output. So that was certainly one way to do it, but what if you have a lot of Booleans to check for? How long are you willing to chain this expression? Well, in general, I wouldn't recommend you ever go past 3. And in the cases that you even have much more than 3, then I will recommend that you use one of Python's built-in functions. So right now what we're going to do is set this to true, and instead of including this all inside here, we're going to create a list of requirements. So requirements of type list of Boolean is going to equal all of these requirements. So Wi-Fi enabled, has electricity, and has subscription. And then instead of chaining this, we're just going to ask if all of the requirements are true, then we're going to print connected to the internet. And all takes only one argument, which is a list of truthy and falsy values, or literally a list of any object. So now if we were to run this, we would get the exact same output, except in a much more maintainable way. And with only 3 things to check for, maybe it wasn't the most efficient approach, but it certainly will simplify it if you have more items to check for. And in a better example, you might have a list of integer that represents people who have voted and people who have not voted. So this is represented by ones and zeros. 1 represents true and 0 represents false. And to check that all of these are true would require you to code a bit of extra functionality. And as a general rule, if Python already has that functionality, you shouldn't have to rewrite it. The professionals have already taken care of that functionality, so it's highly optimized and is usually already the best approach to solving that issue. So we're going to do just that using the built-in all function to check whether all of these people have voted. So if all people voted, then we will print everyone voted. Else we will print that some people did not vote. And as you can see, there are some zeros, which means it's going to print some people did not vote. But in the case that everyone has voted, we're going to get this print statement executed. So as you can see, everyone has voted. And if you ever want to do the opposite, of course you can negate this by using if not all people have voted. So here we're going to say that one rebel decided not to vote. So we have a lot of people who have voted and one who hasn't. And here we can just say that someone did not vote, ellipses. Otherwise, everyone has voted. And there we're just checking the exact opposite. And as you can see, since we have one person that did not vote, we're going to get this printed to the console. Otherwise, once again, if everyone has voted, we will have the else block executed. One function that goes hand in hand with all is the any function. And any checks that at least one element in a list or an iterable is true for it to pass the check. So let's go back to the example we had in the previous lecture with the people who have voted. And in this list of people who have voted, you'll see that we only have one person who has voted. And based on this information, we're going to perform a check. We're going to check if any of these people have voted. And if any people have voted, we can print that at least one person voted. Else we will print that no one voted. And if we run this, you'll see that since one person voted, any is going to evaluate to true, meaning that this block of code will be executed. If at any point we remove that one and we have all of them set to false, the else block will be executed because nothing inside our list was true. So any is just a much more forgiving check than all because it checks that at least one element is true, while all checks that everything is true. And it's also worth mentioning that you don't need to pass it in as a variable. You can also directly pass in the list like this. So here we can pretend that 4 people voted. And if we were to run this, it would work exactly the same way. It's going to say that at least one person voted because at least one element in this iterable evaluated to true. In this lecture, we will be taking a closer look at a built-in function called isInstance. And when you're looking to compare data types, you should always use isInstance because it was designed specifically for this check. It checks if an object is an instance of another object or even a subclass of another object. But let's dive into how it works immediately. So first of all, I'm going to create these 4 variables. One is a number of type integer, one is going to be a float, then we have a string, and finally we have a list of integers. Now the very first thing we're going to do is check if the number is an integer. And to do so, we're going to print isInstance and pass in the number followed by the type we want to check for. So now we're checking whether the number is of type integer, or if it is an instance of integer. And if we run this, it's going to return true because it is of type integer. So this can be great for performing checks before actually using a value. I mean, this will work perfectly with an if check. You can say if that number is of type integer, you'll do the following. That works perfectly fine. Anyway, let's duplicate this and check if this number is of type string, or what happens if it isn't. So if we were to run this, it's going to return false if it is not of the data type we're checking against. But let's duplicate that one more time and check if number is of type float. And if we run this, we're going to get false back because the number is not a float. But let's remove all of these and check whether pi is of type integer. And that's also going to return false because here we specified pi to be a float. And it doesn't matter what type annotation we give it, what matters is the actual value, because again, type annotations are ignored by Python. They just help the developer catch silly mistakes early on in the development process. But if we were to change this to float, it will return true because 3.14 is a float. And finally, let's check that my list is of type tuple, which obviously it is not. So that's going to return false, but we can also check that it's of type list, which will return true. But what if you want to check for multiple types? For example, maybe we have pi here and we want to check that it's either an integer or a float. And to do so, we can easily create a union type using the pipeline. So now we can check that pi is either an integer or a float. And if we run this, that will return true. And this also works for other types, such as text. We can check that text is either an integer or a string. And that will also return true because it's checking that text is one of these types. But if we were to remove the string bit, it's going to evaluate to false. But moving on, for the final example, I'm going to create a class and a subclass because using isInstance with these two will teach you a lot. So here we will print isInstance and we will create a cat object, and we're checking that this cat is of type animal. And since cat inherits from animal, it's going to be considered an animal. It's a subclass of animal. And if we run this, we're going to get true back. But keep in mind that this does not work the other way around. So if we were to type in animal and check that animal is of type cat, that is not the same thing. And that will return false because animal is not a subclass of cat. While a cat is an animal is not a cat, in other words. So yeah, if you ever need to compare types, use the isInstance function. It will make sure that you compare your types properly. Now that you're actually getting a hang of how Python works, we're going to be creating a much more advanced chatbot using a lot of Python's core functionality. So let's get started immediately by importing from difflib the getCloseMatches function. And I'll explain how that works in just a moment. But first of all, we're going to create a function that says get best match. And this will take a user question of type string and a knowledge database of type string. And that will return to us either string or none. So the purpose of this function is to find the best match for a question that we enter. And the first thing we will do inside here is create a variable called questions, which will equal a list of type string. And that's going to equal a list comprehension of question for question in knowledge. And I messed up here because knowledge is supposed to be a dictionary. Then we're going to write matches, and the matches are going to be a list of type string, and that's going to equal getCloseMatches for the user question, the questions, and we want to get the most relevant question. So n is going to be set to 1 just to make sure we only get one result back. And the accuracy of how close our question has to be to the questions that we provided is going to be set to 60%. So we're going to add a cutoff of 0.6. But there's also a chance that the question we enter won't be found and won't be considered a match. So we do need to create one more check before moving on. And that is checking that if there is a match, then we're just going to return the first element, matches at the index of 0. Otherwise, it's going to return none by default if we don't specify a return type. And I'll explain more about this function as soon as we set up the bot. But next we need to create a function that runs our bot, and we're going to call this run chatbot. And that's going to take some knowledge of type dictionary and will return none. Then inside here, we'll type in while true. We're going to grab some user input of type string, which will equal the input of you. Now, depending on what the user enters, we're going to want to get back the best match. So here we'll type in best match of type string or none. So it's an optional will equal get the best match for the user input using this knowledge, which is a dictionary. So getting the best match does not give us a response. It just gives us the best match for the question that we have entered, which will make it easier to fetch a response. So what we need to do next is create a response of type string, and that's going to equal knowledge.get, and we want to enter the best match. Now with this response, we can check if response, then we will print that the bot has that response. Else we will print that the bot says, I do not understand. And that was all the functionality we needed to run this chatbot. Now let's create our if name is equal to main check and our main entry point. And inside here, the very first thing I'm going to do is create a brain, which is going to be a dictionary of type string to string. And here we can create the questions and the responses, which can be seen as an ideal approach for setting up the bot. For example, here we can say that if the user enters something that is similar to hello, the bot should respond, hey there. Otherwise, if someone writes something similar to how are you, then the bot should write, I am good, thanks. And this is much more convenient than setting up all of those if checks. Anyway, since writing out all these responses by hand is quite boring, I'm just going to copy and paste in some more, such as, do you know what the time is? And the bot's going to say not at all, because we obviously did not make or create that functionality. And I also added a variation, what time is it? Still says no clue. I also added something that says, what can you do? And the bot will say, I can answer questions if we insert something similar to this. And finally, I just entered OK, which just tells the bot to respond great. So let's try running this chatbot with the knowledge set to the brain. And if we tap on this green arrow, we can now test this out by saying hello. And the bot will say, hey there, regardless of the syntax we use here, even if we did something such as hello with 3 ellipses. It's still going to be able to understand what we tried to do, because now we have a system that checks that this message is at least 60% similar to this over here. And that's exactly what the getBestMatch function does. It doesn't return a response, it just checks that whatever question we enter or whatever user input we enter is similar to one of the questions in our dictionary. So if we type in how are you, no matter how we spell it, as long as it's 60% similar to this question over here, it's going to be recognized. So we can even say, how are you, with a lot of exclamation marks, and the bot will still be able to recognize that. And if we want to ask what time is it, we can say, what time is it? And we'll be super pushy about that. And the bot will have no clue, but it was still able to recognize this regardless of the case and regardless of the punctuation. Keep in mind though that you might still want to lower it, because here we entered an uppercase W, which is of course not the same as this lowercase w. So that will affect the accuracy, and that can lead it to fall below 60%. And if we wrote everything in caps, for example, this phrase would not be recognized by the bot, because it's not even 60% accurate to what we wrote here, since it's all in caps. The only character that it found probably was this question mark at the end. So that would lead to a very low accuracy rating. But I am going to give you a bit of homework, because playing around with this project will give you a lot of experience. For example, try adding some more responses and questions to your bot. This is a good start, but maybe you can make your bot do many other things. And also, if you're really feeling ambitious, here I did everything via functions, but you could easily turn this bot into a class and make it ultra reusable, giving it a name and some extra functionality. Maybe you can actually make the bot return the time. Just try to play around with it as much as you can. Let's continue with Python's built-in functions. Up next, we have a function called Callable. It allows us to check whether an object is callable or not. So let's take a look at how it works. And for this example, we're going to have a couple of variables, one that's called fruit with the value of apple, and a number of type integer, which is equal to 10. Then I will also create a function called function that returns none. And this function will print that function was called. And it didn't really have to be an F string. I just did that by habit, so I'll just remove that. But moving on, let's take a look at how callable works in Python. So here we're going to print the F string of callable, and we're going to insert callable of the object that we want to test for. For example, we can insert our fruit variable and check whether it's callable or not. And when we run this, we're going to get false as an output, because this fruit is not callable. And all that's saying is that if we were to use these parentheses after fruit, that would just not work. Python would raise a type error because this object is not callable. And we can also check with number whether the number is callable. And as you probably expected, an integer is not callable either. But now let's try with a few functions. So I'm going to remove this line and pass in our function. And note that I'm passing it in without the parentheses, because if you pass it in with the parentheses, it's going to call the function inside this function. And we don't want to call it, we just want to check for it. But the next time we run this, you'll see that callable will return true because function can be called. And for some other examples, we can also pass in the built-in types such as range and string. So now if we were to run this, you would see that all of these would return true because range, of course, will create a range if you add the parentheses. String can convert any value to a string essentially. So both of these work with the parentheses. And what's nice about this is that we can use it with some potential checks. So we can check if our function is callable before running it. Otherwise, we can print that the object is not callable. And if we were to run this, function will be called. But if we were to pass in something such as a fruit, we will get this friendly message that the object was not callable. In the next 3 lectures, we're going to be learning about 3 functions that can all theoretically be created as list comprehensions. So why am I teaching you these functions? Well, you might need to use them someday, or you might even see them being used in older projects. Knowing what they do is important for being able to read both modern and older code. Also, sometimes these built-in functions might be easier to read and use than list comprehensions. So they're just good to know about. But for this example, we're going to create some numbers of list of type integer, and that's going to equal a list of the range of 1 to 21. So when we print this, what we're going to get back are 20 numbers from 1 to 20. But now suppose that we want to filter the even numbers. And to do that, we're going to create a filter, which is just going to be a function. So isEven, which is going to take a number of type integer, and that's going to return to us a Boolean. And all we want to do here is return whether the number modulus operator 2 is equal to 0. So that's going to be the condition for our filter. Next, we can create a variable called even numbers, and that's going to be of type filter, because when we use a filter, it's going to return to us a filter object. And here we can type in filter, and first we need to pass in the function that should be applied to each number. And this will be used to filter the iterable. So we want to check isEven for each one of the numbers, and that's going to filter it according to our condition. Now, if we were to print the even numbers, we wouldn't see anything useful. We would get back this filter object, which is incredibly memory efficient. So you can use that in for loops and it won't take that much memory. But if you actually want to see the results immediately, we would have to duplicate that line and convert it to a list or to a tuple so that the next time we run it, we can actually see what's inside of it. Note that once we convert this into a list, it loads everything into memory, while a filter object will not do that. And that's why Python sometimes returns objects instead of just lists or tuples. It's just much more memory efficient. Anyway, here we successfully filtered our list. As you can see, we only have even numbers. But you might be thinking that it was actually quite a lot of work to create an external function that we had to use for our filter. As you may recall, using a list comprehension in a case like this was much easier. But in general, when you're using one of these built-in functions, you would not create an external function. You would use a nameless function or a lambda. And we're going to cover lambdas in detail later on in this course, but I will be explaining the basics of it now because this is where you're going to see it being used most. So instead of creating a whole new function, we're going to create this nameless function directly inside here, which is going to have the exact same functionality as the isEven function. And to create a nameless function, we use the lambda keyword. And first we need to provide the parameter that it takes, and that's going to be n. Then we use a colon, And after that, we can define the functionality. N modulus operator 2 is equal to 0. And this does the exact same thing as the function we created earlier. It checks that each number is even. So this is the parameter and this is the actual functionality. And we don't have to type in return because that's what it does automatically in the Lambda. But now we can print this list of even numbers and we will get the exact same result. But let me show you one more example using strings this time. So here we have some people, which is a list of type string, and that contains the values of Anna, Bob, Betty, James, and John. And what we want to do is get back the long names, or any names that are longer than 4 characters. So here we'll create a variable called long names of type filter, and that will equal a filter. And inside here, we're going to use that Lambda once again. So Lambda name, and we want to check that the length of the name is more than 4 characters. And then of course, we need to pass in the list that we want to check for. And here we'll pass in the people. So each person is going to be inserted as an argument, and then it's going to check that that argument is longer than 4 characters, and then return a filter object based on which elements met this condition. So now we can print the list of these long names. And what we should get back is a list of Betty and James, because those are the only 2 that satisfy this condition. But as I mentioned earlier, in modern Python, sometimes it's just going to be much easier to use a list comprehension. So for example, I'm going to create a variable called ln for long names, and this will be a list of type string, which will equal this list comprehension. And here we just need to type in name for name in people if the length of name is more than 4. And then we can print ln, and this will give us back the exact same result. The only thing to note here is that filter returns an incredibly memory efficient object, while our list comprehension returns a list directly. So if you have millions of elements, in general, you might want to use filter, because filter will return that memory efficient object that does not load everything into memory immediately, while a list comprehension will load that into memory immediately. Up next, we're going to be looking at how we can use the map function in Python. And map allows us to map a function to an iterable. So let's take a look at what the hell that means by typing in numbers of type list of integer. And that's going to equal 1, 2, 3, 4, and 5. And next, we're going to create a function called double that takes a number of type integer and returns an integer. Then we can return number times 2. So you probably already see where I'm going with this. It's not going to be that different than using the filter function, but it does provide us with some really cool functionality. So next we can type in doubled of type map, and that's going to map this double function without the parentheses to each one of the numbers. So practically it's going to loop through all of these elements using this function on each one of the elements, and then it's going to store the result of that into a map object. So now let's print doubled, and let's print the list of doubled. And when we run this, you'll see that it's going to return to us first a map object, and then it's going to return to us the results of that mapping. So it's just a very quick and efficient way to call a function on many elements in an iterable, and to return all their results in one place. But as I mentioned earlier, it's not really that common that you would actually pass in a function. What you would usually do is pass in a lambda. So here we'll type in lambda n, and that's the variable name or the parameter name that we want to take. And all we're going to do is multiply n by 2. And in this example, it was extremely easy and is even readable. So now we can run this and we will get the exact same result, except this time we used a lambda. And once again, I'm also going to be showing you the modern version of doing this via list comprehensions. So I'm going to comment out doubled, and right below that, I'm going to create another one called doubled, which will be a list of type integer. And this will equal the double of n, or actually that would require us to have the same function as from earlier. So I'm going to quickly recreate that. So def double number times an integer, return n times 2. So double of n for n in numbers. and then we can print doubled, and that would work exactly the same way. Or to be fair, this actually has to be called number, and then it will work exactly the same way. But this is actually a very silly example of using a list comprehension because you can actually perform that operation directly inside here. So n times 2, and that's going to save so much more trouble than recreating a function and passing it in there. Although you can pass in a function if you already have one that's created. So now we can remove all of this. And if we run the code once more, you'll see that we will still get the exact same result, but this time using a list comprehension. But next I'm going to show you a slightly more complicated scenario. And this one's going to be using two lists. So here we're going to create a lambda called combine elements, because the goal of this will be to combine these elements. And that's going to take a number of type integer and a letter of type string. And it will return to us a tuple of int and string. And I also really need to stress that in general, you never want to create names like this because it's very hard to read. And I can guarantee that if you ever come back to this function someday, you will not know what L is or even what N is. All of the code I'm teaching you right now, I wrote ahead of time. And it took me about 20 seconds to understand what L stood for because I thought it stood for list. But as soon as I read letters, I realized it stood for letter. So I don't recommend you pick up this habit. I'm only using it for demonstration purposes. In a real project, please define it as letter, and N in general might be descriptive enough because N in general would always stand for number, but it's always nice to be on the safe side by providing number and letter. Anyway, all we're going to do here is return the tuple of N and L. That's all this function is going to do. But next, let's create a combined object, which will be of type map, and that will map the combine elements with the numbers and the letters. So now we're using both of these inside this function. And what we're going to do next is print our list of combined. And when we run this, we're going to get 3 elements back, or 3 tuples back. And as you might have noticed, it will stop as soon as the shortest list runs out of elements, because our numbers contained 5 elements while our letters contained only 3. So once it ran out of elements to use in the shortest list, it just stopped there because it had no idea what to do with the rest of the elements. And you can also create a lambda here, so you can type in lambda n l, and here we just need to return n and l. And we need to do this in parentheses, otherwise Python will get confused, because if we just do nl, it's not going to understand anything here. It's going to think that the lambda ends here, so L doesn't really make any sense. So for context, Python has to have these parentheses to tell the program that this lambda is one expression. But if we run this once again, we're going to get the same result, except this time we used a lambda. In this lecture, we're going to be learning how sorted works in Python. And unlike with the other 2 functions I showed you, I do not recommend you use list comprehensions instead of this function, because sorting is a whole different operation, and sorted is highly optimized when it comes to sorting. Anyway, to get started with showing you how it works, we're going to create a list of integer, which just contains some unsorted numbers. But below that, we can create a variable called sorted numbers of type list of integer. And what we're going to do here is call sorted and pass in the numbers. And this time we can print these sorted numbers directly. It will not return to us a sorted object. It just returns to us the numbers directly. And what it does by default is sort the elements in ascending order. That's why it starts with 1 and ends with 10. But what will it do if we have a list of string? For example, we might have some people and we might want to sort these people. Well, we're going to do the same thing. We're going to create some sorted names of type list of string, and we're just going to call sorted on these people. And when we run this, you'll see that it sorted the names in alphabetical order, in ascending order. Or actually, to be more technically correct, it sorted it by its ASCII value. So one thing that you're going to notice is that if you have Anna with a lowercase a and you try to sort this, Anna is going to be placed at the end of the list. And this is because the ASCII value of an uppercase A is lower than the ASCII value of a lowercase a. So with characters and strings, it's going to sort them by their ASCII value by default. But let's change that back to an uppercase A and sort this once again. So we have Anna at the front. Now something else we can do is ask this function to reverse the sorting. So instead of having Anna at the front, we can make it so Anna is at the end and that Mario is at the front. And all we need to do is set this to true, so that the next time we run this, it's going to reverse that sorting. But what if we want to specify our own condition on how these names should be sorted? Well, for the next example, I'm also going to add Tom, because what we're going to do is sort these people by their lengths. And instead of using reverse, we're going to use something called key. And with the key, we can specify how we want to sort these names. For example, we can pass in a lambda that takes x as a parameter, and that measures the length of x. And x is going to be the name. So now we're measuring these people based on the lengths of their names. And if we were to run this, you'll see that Tom will only have 3 characters, so it will be the first one to be printed. Then we'll have Anna, Mario, and James. And if the length is the same, it's not going to change it. So Mario and James are going to remain where they are because it has no information regarding how those should be sorted. So it was quite simple with the basic data types. But how would we use this function with a class? And for the next example, we're going to have a class called animal, which contains a name and a weight. And I've only defined one dunder method in here, which is the representation dunder method. So we can see exactly what that animal looks like when we print it to the console. But right below this class, I'm going to create 2 animals. One which is a cat with the weight of 10 kilos and one which is a dog with the weight of 5 kilos. And actually I wanted to print one more animal, which was a kangaroo. So here we have 3 animals that we want to sort. So what we're going to do next is create something called sorted animals of type list of animal. And we're still going to use the same function, but this time we're going to pass in a cat, a dog, and a kangaroo. And as for the key, we're going to create a lambda expression that takes an animal. And what we want to do is sort these animals by their weight. So inside here, we can directly refer to our object and say that we want to use the animal.weight as the key for sorting these elements. And now if we try to print these sorted animals, what we should get back is a list containing these animals sorted by their weight. Otherwise, of course, you can sort them also by their name, and that will work just fine. We'll have cat, dog, and kangaroo, even if they are already in that order. But if we were to put the kangaroo at the front of the list, you would see that the outcome would still be the same, because we sorted them by their names. Moving on, we have 2 powerful functions that should be handled with extreme caution. One is called Eval, and the other one's called exec. And in this lecture, we're only going to be talking about Eval. Then we will continue in the next lecture with the exec function. Now, in case you're wondering, Eval just stands for evaluate. And with Eval, you can pass in any code as a source and it will execute it and give you back the result. In other words, it's going to evaluate that code. For example, here we might have a result, and this will be of type integer. And here we can use the eval function. And what we're going to pass in here is 1 plus 10 plus 100. And I don't know why I added an extra pair of parentheses, but all we need to do is pass in that source. And the next time we print this result, it's going to try to evaluate this expression and then store that result. And we can also use code from the script inside this string. For example, we might have a variable called x of type integer, which will equal 5, and a variable called y of type integer, which will equal 10. What we can do next is evaluate x plus y as a string, because this will use the information from our script, which means if we ran this before this print statement, it would be able to find these two and use them inside the string. So now if we run this, we will get back x plus y. And this can be extremely cool if you want to build something such as a calculator. For example, here we can type in while true. And what we're going to do is grab some user input of type string, and that will equal input. And here we can type in enter math. Then we will print evaluate that user input. So now the next time we run this, we can add our own math expressions, such as 10 plus 10, and it will add that, or 10 times 2 divided by 30. And it will give us back the result of that expression. And this is really cool because it adds a lot of flexibility to what users can enter in your program. But as I mentioned earlier, if users can enter anything into your program, this can be extremely dangerous as well. So you need to handle this with extreme caution, because if you ever post this kind of code online somewhere, there are some very clever people out there that can actually inject their own code into your script, meaning they might be able to access sensitive information from your script or even from your computer, and you might not always want that. For example, here I only entered some very simple math equations, but look, we can also enter code such as print hello. And it's going to execute that line of code plus return the result. So as you can imagine, if they were to enter code that was a bit more complex than printing hello world, then you might get into some serious trouble. So always keep that into account when you're using eval in your script. It's okay to use in your personal projects, but if you ever create a product that uses it, you need to really think hard about how to prevent users from actually injecting code into your script. With eval, we were able to insert a snippet of code and get back a result. Now, exec or execute can be seen as a much more powerful version of this function because it allows us to enter whole scripts of code that can be executed. And the major difference is that exec does not return anything, it only executes code, while eval evaluates that code. So as an example, you might have some code in the form of a string or in the form of a text file, and you might want to execute it. Here I'm using a multi-line string for this code block, or just for this code in general. And all it does is define two variables, add those together, print hello world, and loop through a range of 3. And the reason I created this is so that I could execute it using the exec function. So here we're going to execute that code. And as soon as we run it, you'll see that it will run that script without any issues. So it works exactly the same way as eval, except this one allows you to execute several lines of code, which means we can do the same thing that we did earlier. We can create a while true loop. We can grab that user input of type string, which will equal input, and we'll just type in command. And finally, we can execute that command, which will just be the user input. Now, if we run this, we can enter any kind of code we want and it will be executed. For example, print hello James, and the exec function will take care of executing it. Otherwise, we can print, let's say, the list comprehension of I for I in range 10. And if we were to run that, we would get that back. So once again, we can execute code in the format of a string. And that's pretty much all you need to know about this function. It executes code from a source, and it doesn't have to be a script. As you could see, it could even be a string. But once again, make sure that you only run code that you trust, and preferably don't use it online, because once again, people can use it to do bad things. Or in other words, they can inject some pretty nasty code in there that might be able to access your sensitive information. Or if you have a website, they might even destroy your website. So always use exec and eval with caution. Another built-in function that you might find quite useful is the zip function. And the easiest way to explain what it does is by showing you directly. So the very first thing I'm going to do is create 3 lists. One which will be a list of type integer with 4 elements, one which will be a list of type string with 4 letters, and one more which will be a list of type string with 3 random symbols. And what we want to do next is try to combine these lists. So the very first thing we're going to do is try to combine these numbers with these letters. And to do so, we're going to create a zipped object. So zipped of type zip is going to equal zip the numbers and the letters. And first we're going to print the object, and then we're going to print the list version of the object, so you can see what's inside it. Now, when we run this code, first we're going to get that zip object at this memory address, which doesn't tell us anything regarding what's inside it, but as soon as we convert it to a list, you'll see that the zip object contains tuples of the paired elements, which is really cool because it was very simple to use. And that also makes it very easy to loop through. For example, we can type in for NL, which stands for number and letter, in zipped print NL, with a separator being this colon. And I'm just going to remove these 2 lines of code. And now when we run this, what we're going to get back is this output. And in this example, it's not really any different than using enumerate, but this could actually be a list of anything. It didn't have to be a list of integer. But next I want to show you what happens when we try to zip lists of different lengths. So what we're going to do is remove this, print the list of zipped, and change the numbers to symbols. So here we only have 3 symbols, but numbers contains 4 elements. So what is zip going to do? Well, zip is going to ignore the 4th one completely. It will never go past the shortest list. So if you ever want to ensure that it zips everything, then you can set strict mode to true. And all this is going to do is raise an exception if your lists are not of the same size. So now if we run this, we will get a value error that argument 2 is shorter than argument 1. And to fix that, we're going to have to add another symbol, such as this @ symbol or this hash. And the next time we run this, it will work perfectly fine because everything can be grouped. Also, we don't have to limit ourselves to only using 2 iterables. We can even insert a 3rd and a 4th. So here we can say numbers, symbols, and letters. And that will work just fine. It's going to put them all in groups, one at a time. In this lecture, we're going to be talking about docstrings. And usually you will find them either at the top of a module or inside functions. And the sole purpose of docstrings is to inform the user on what the function does, what it returns, and how it should be used. But first of all, if you were to import a module and you were to hover over it, you'll see that it will contain a very basic form of documentation, such as this module provides access to the mathematical functions defined by the C standard. And if you hold Command or Control on Windows and tap on that module, you'll notice that this module has a docstring at the top. So this is used as documentation for the module. And if you ever create a module of your own, you can do the exact same thing by using triple quotes. This is a docstring. So just pretend this is a module and you import it into your script. The next time you hover over this module name, you will see this docstring. Otherwise, it also works in classes and in methods. For example, we might have a class called user that has an initializer that gives that user a user ID. Now what we can do inside here is add a docstring for this class. We can say that this is the base class for creating users. And then we can actually create one function that says show ID, and that returns none, and print the self.userID. The functionality right now isn't important, but what I want to show you is the docstring. Here we can type in something such as returns the user ID as an integer, or that's actually not true. What I wanted to write actually was prints the user ID, because we're not returning anything. And with that being done, we can create a user, but first I'm going to create our if name is equal to main check. So user of type user is going to equal this user here with an ID of 1. So now we can hover over this user. And what you should notice is some documentation that we wrote for the class, such as this is the base class for creating users. And that's really cool because you can add some very useful information inside there. And if we were ever to refer to user.showID and we needed some help with how the function works, we can just hover over it. And what we should notice is some documentation being displayed. And there's also another thing that I want to show you, and this is called Sphinx markup. So what we're going to do next is create a function outside of the class. And this is going to check if a user exists. And it's going to take a user of type user, and we're going to create a database, which will be a set of user. And this will return to us a Boolean, depending on whether it can find that user or not. And once again, we're going to insert a docstring. So here I'm going to add my triple quotes and tap on enter. And what you're going to notice this time is some Sphinx markup. Here it says we have a parameter called user, a parameter called database, and a return. And what I'm going to do here is type in checks if a user is inside a database. And this parameter will have the description of the user to check for. Then the database will be the database to check inside, and it's going to return a Boolean. And potentially you can be more descriptive with this part here, because most people will understand that by reading your type annotation. And all we're going to do is return the user in database. So it's going to return if the user is in that database. And regarding the Sphinx markup, I'm going to be leaving a link in the resources section of this lecture that explains it all in detail. But in general, just by tapping enter on your triple quoted strings, you should get auto completion in PyCharm for all the parameters and the returns that you set up. So going back to our main entry point, let's create a few users. The first one's going to be Bob, and the second one is going to be Anna. And what we want to do is create a database of type set of user. And that's going to equal these two users, Bob and Anna. Then we can check whether these users are inside the database. So if user exists, and here we can pass in Bob and pass in our database. So we're checking that Bob is inside the database. And also it would be a good idea to give Bob a different ID. So Bob will contain the ID of 0. Anyway, look what happens when we hover over the user exists function. What we'll see inside here is some really nice documentation. The first line being checks if a user is inside a database. Then we will also get some really cool information regarding the parameters and what this function returns. Anyway, now that we have all that information, we can pretend that we understand everything about this function, and we can print that user exists in the database. Else, we will print that no user was found. And if we were to run this, you would see that everything would work as normal. So it didn't really affect our functionality in any way. It just gave our developers or ourselves some extra information regarding what the function does, what the parameters are, and what it returns. And finally, for anything that contains a docstring, you can use the dunder doc method. So here we can print, for example, the user.dunderdoc. And we can also print the user exists dunderdoc. And what that's going to give us back is the documentation for each one of the functions. So here we have the base class for creating users, and then we have the documentation for our user exists function. And if you do not provide documentation and try to use that, what you're going to get back is none. Anyway, I always recommend you include docstrings in your functions, especially the ones that are a bit bigger than just adding two numbers together, because it can really help you and other developers understand your code much better with only a single glance. And if you ever need inspiration, you can always look at the built-in modules such as math. If you were to scroll down, you would notice that everything has a docstring. Or we can even import random and look at how they did it inside there. Sometimes they use comments, but every function will always contain a docstring. It's just the professional thing to do and helps users around the world understand what random does. By this point, we've been using f-strings already quite a lot throughout this course, so by now you should be quite familiar with the basic syntax. But there's still a lot more that I want to share with you guys regarding f-strings, because there are a lot of features that are just very convenient to use when you are programming in Python. And to start off, I'm going to be showing you one trick that really helps with debugging. And to demonstrate how it works, I'm going to create a variable of type integer, and that's going to contain the value of 10. Then I'm going to create a function that takes a of type integer and b of type integer as well, which returns an integer. And all this will do is add a plus b. Next, to use this trick, we're going to have to create an f-string, And here I'm going to open up the curly brackets. And first we're going to print the variable and its value. And this is the entire syntax. We have the variable name or the object name followed by an equal sign. And when we run this, what you're going to notice in the console is the variable name plus its value. And that's ultra convenient because that just saved us the trouble from having to write out var equals var. So that's one feature that fstrings provides us with that I really love. And this was a very simple example, but now watch what happens if we use the add function here. So here we can type in add, and we can add 5 to 10. Now this time when we run the script, it's going to show us exactly what we called and the result of it. And personally, I really hate when it's attached like this. So one thing you can do is place spaces in between the equals. And even if your code editor will complain, this is perfectly acceptable because the next time you run this, you'll see that you will actually have some space around the equals, making it much easier to read. Moving on, I want to teach you a little bit about number formatting using fstrings. And to get started, I'm going to create a big number of type integer, or actually of type float, why not? And that's going to equal 1, 2, 3, 4, 5, 6, 7, 8, and 9. Right now, if we were to print this big number, it would be this ugly mess. But with an fstring, we have some options that allow us to format this number to make it more legible. So we can pass in the big number followed by a colon, and next we can specify a comma. And the comma is going to work as the thousand separator. So when we run this next, you'll see that we will have our number formatted nicely in a readable format. And if we duplicate this line, we also have the option to use an underscore for the exact same purpose. And now the next time we run this, you'll see that it's going to format it by the thousand using these separators. And unfortunately, these are the only two you can use. These were the only two that were actually built into Python. So for the systems in the US, this is quite convenient. Here in Europe, it's going to be quite annoying because here in Denmark, we use the decimal as the thousand separator. But it's still a cool trick nonetheless. Also, I didn't mention this earlier, but at any point when you're creating a number in Python, you can use the underscore anywhere in your number and Python will ignore it. And the reason you would do this is to make your numbers more legible when you are creating them. And it can follow any pattern you please. It doesn't have to be every 3 numbers. It can even be every 2 numbers, if that's what you want. It just makes it more legible when you are creating it. But when you actually print this big number, it's going to ignore those underscores. So that wasn't really an fstring trick, but I thought I would mention that. But now suppose we have a fraction. So this will be a fraction of type float, which will equal 1234.5678. And what we're going to do with this fraction is format it so it can appear more pleasant in the console. And once again, we're going to be using the fstring for this. So here we're going to insert that fraction, use a colon, and this time we're going to use .2f. So it's going to round it to 2 decimal places as a float. And the next time we run this, you'll see that in the console, it's going to round the last 2 decimals. And this is quite nice if you have very large decimal numbers, but you don't really care about all the details. And one thing that's cool about this is that you can combine it with the comma or the underscore. So we can have both the thousand separator and the decimal formatting. And here I'm just going to use the comma. So the next time we run this, we will have both of the effects being applied to this fraction. And you can change this to whatever you want. It can be 1 decimal or 3 decimals, whatever kind of precision you're looking for, you just have to insert it here. And finally, I want to show you how you can format percents. So here we'll have a percent of type float, which will equal 0.5. Now using an fstring, we can pass in this percent. And just like we did with the rounding, we can do with percents. So 0.2%. And that's going to convert this to a percent and round everything to 2 decimal places. Which means now when we run this, we're going to get 50% as an output. If you insert 0, it's going to round it to a whole number. Otherwise, if we have 0.5555 for the rest of eternity and we decide to specify 0.3, it's going to end up looking like this. And once again, you can combine this with the thousand separator. So if we have 5.555, that's actually not going to be enough to use the thousand separator, so I'm going to add another one. But now you'll see that it also inserted that comma. And with the underscore, it's going to do the exact same thing. Up next, I'm going to be showing you how you can align your variables or your text using f-strings. So here we're going to create a variable of type string, which is just going to equal Bob in uppercase letters. But now that we've created that, let's create our f-string as always and pass in our variable. And this time we're going to insert colon and 10. And what 10 does here is specify that this variable should occupy 10 spaces, which means that everything we insert after that is going to appear at least 10 spaces later. So we can type in Bob and then type in hello. And when we run this, you'll see that Bob will occupy 10 spaces. And this is including the length of Bob. So Bob occupied 3 spaces and then it filled the rest of this string with 7 spaces. But we can also tell Python that we want to align this to the right by using a right arrow, so that the next time we run this, Bob is going to be right aligned. And by default, it is left aligned, but you can also explicitly say that with a left arrow. And if you want to center align it, you can just use this up arrow, so that the next time you run it, Bob will be perfectly centered. Or it's actually not guaranteed that Bob is going to be perfectly centered if the amount of characters it occupies isn't perfectly divisible by the amount of spaces we've defined it to occupy. Also, there's something really cool we can do with this syntax, and for this example I'm going to remove hello, and to demonstrate it I'm going to remove the up arrow and insert a bullet point with the right arrow. And this can be actually any symbol you want. It doesn't have to be a bullet point. But what this is going to do is fill the remaining space with that symbol. So if we run this now, you'll see that all the empty space is going to be filled by this bullet point. And this works in any direction. So we can also left align it and it will fill the remaining space while pushing Bob all the way to the left. Otherwise, if we use our up arrow, it's going to center Bob and fill the remaining space with those bullet points. And once again, this can be any symbol you want. So we can actually replace this with a hash and the bottom one with an @ symbol. And when we run this, we're going to get this crazy output. And one place I see this being useful immediately is when you are iterating through a lot of numbers. So for this example, we're going to have the numbers of 1, 100, 1000, and 10,000. And for each number in these numbers, we're going to print the f-string of the number, followed by an underscore, right arrow, and this should occupy 5 spaces in total, since 10,000 occupies 5 spaces. And at the end, I'm just going to type in counting. But now let's see what happens when we run this. And what we should get back is some very nice formatting of these numbers, because without this, we would get something that looks as follows. And this gradually grows as a pyramid. So personally, I think it's much nicer when we're actually filling those spaces, because this just looks so much cleaner. And finally, before we finish this lecture, I want to talk a little bit about r-strings, because sometimes you might have a string that contains a file path. For example, here's a path of type string, and this is going to equal \users / my username. And I'm also going to add the documents. And this is a real path on my computer. But as you can see, Python's not really happy about it because the / is actually used as an escape for certain characters, as I showed you with the quotation marks. And in this example, we start with a quotation mark, but unfortunately, our file path ends with a \, which means Python sees this as we're trying to escape the last quotation mark. Now, one solution is to escape the escape by adding another \ in front of each \. And we should also do it here for consistency. So now if we were to print this path, not float, but the path, we should get our file path back. But having to do this manually is actually quite ridiculous. So I'm going to remove each one of those \. And instead, what I'm going to tell Python is that this should be treated as a raw string. And to do so, we just need to pass in an r in front of our string. Although the one catch to using this is that your string cannot contain an empty \ at the end of the string. But otherwise, we do not need to worry about escaping random characters. So now when we run this, we're going to get our file path printed to the console without having to escape each \. And something that's really nice about this is that we can also combine it with f-strings. So here I'm going to create a user, and the user is going to be of type string, and it will be equal to my name. And to combine both the f-string and the raw string together, we just need to use that combination in front of the string. And I really like to refer to these as French strings just because it uses the country code of France. But now with that being done, we can actually pass in the user without any issues. And when we run this, you're going to see that it's going to print that string without any problems. But it's also worth mentioning that the order of these does not matter. You can also do rf, and it will work exactly the same way. I just find it quite cute to use fr because personally, I really like referring to these as French strings. When you are developing programs, sometimes you're going to want to make sure that certain conditions are met, because those conditions are going to determine whether your program will work or not. Maybe you created some sort of chatbot, but the language pack or the database for it is missing, and in that case, your program just won't work. So it can be a good idea to provide consistent checks throughout your program to ensure that all the essentials are actually in place. So in this lesson, we're going to be learning about assertions in Python. And for this example, we're going to create a function called start program. And to start our program, we need a database of type dictionary, which will be of type int to string. And that will return none. But as I mentioned earlier, this program should not work without the database. So what we're going to do is create an assertion using the assert keyword. And here we just need to pass in an expression, such as 10 is more than 5, for example, something that returns either true or false. And in this example, we're just going to check that a database exists or that it is not empty. Otherwise, if the database is empty, it's going to raise an exception. And here we can insert the exception message. Note that the syntax is a bit funky here. We're not using parentheses, but we're using a comma to insert the message. So here we can write database is empty. And this will only be used for debugging, because when we actually post our app into production, it's going to be too late. If the database is missing, all the users are not going to be able to use the app anyway. So this is just for us. But if there is a database, let's print that we loaded that database, and we can print that the program started successfully. And now let's test it out by creating our if name is equal to main check and creating a database. So database 1 of type dictionary of int to string is going to equal this dictionary here with 0 and A and 1 with B. Then we can start this program with that database. So db will equal db1. And if we were to run this, the program will work perfectly fine because we have a database which is not empty. Otherwise, if we were to remove all the values from this database, our program would have no information to function. So that's going to trigger the assertion error, because we told Python up here that we want to assert that there is data, because without this data, our program just will not work. And again, this is only useful during the development process, because when you actually post your app into production, these will not be part of your final code. So just make sure to use it anywhere you think there's something that can possibly go wrong, such as a missing file from your project. And again, assert works with any expression. So for example, here we can have a variable of type integer, which is equal to -5. And maybe we want to assert that a number will never be less than 0. So here we can assert that the var is always going to be more than 0. Otherwise, we can print that the var is not more than 0. And this will work exactly the same way. Since -5 is not more than 0, we're going to get that assertion error. Otherwise, if we insert 10 or any positive number, we're not going to get any errors at all. In this lecture, we're going to be talking about the concept of unpacking. And to explain how unpacking works, I'm first going to be teaching you about multiple assignment. For example, maybe we want to create a variable called a with a value of 5 and a variable called b with the value of 10. Sure, we can do this on 2 lines, but another way to do this is to actually use the comma, so a comma b, and assign those values respectively in the correct order, so 5 and 10. And that will achieve the same thing. So you should see this as a tuple, and the value of 5 is being assigned to the variable name A, and the value of 10 is being assigned to the variable name B. And you can do this with as many values as you want. You can even add a value of 15, and then add another variable name called C, and it's going to work accordingly. Now going back, this doesn't have to be a tuple. It also works with most iterables, such as a string. So if we were to print, let's say A and B, you'd see it would work perfectly fine. A has the value of 5 and B has the value of 10. And this also works with strings. So here you can have X and Y, for example. X is going to be assigned to A and Y is going to be assigned to B. And we can actually verify that by running our script, and you'll see in the console that each one of these variables is going to contain their respective value. But what if we have an iterable which is super long, such as A, B, C, D, E, and F? Well, here we're not going to manually type out all the variable names. That would take forever, because in some cases we might not care about assigning all those values to different variables. So what we're going to do here instead is add an asterisk in front of B. And what we're saying here is that A should absorb the first value and B should absorb the rest. So now when we run this, you'll see that A will just contain the value of A and B will contain a list of the rest of the objects. And you can also grab the first and last element this way. So A, B, and C. A will grab the first element, B will grab everything in the middle, and C will grab the last element. So if we were to print A, B, and C, inside the console, you'll see that A will be A, B will contain these 4 letters, and C will contain F. So using this syntax is quite straightforward. You just need to be aware of their positions. Because we can also say A, B, and then we can grab the rest. And that will grab the first 2 values and assign it to A and B, and then C will absorb the rest. Then you can continue with this by adding D, if that's what you want. And this will grab the last value in this string. But as I mentioned earlier, sometimes you're going to grab a single value because you just don't care about the rest. And as a convention, if you don't care about a value, you will use the underscore. So let's pretend we only want to grab the last value. So what we're going to do is use asterisk underscore, and we're going to type in last, because this will refer to the last value. And when we print last, we're going to get F back as a return. Keep in mind though that this is a convention and that an underscore is a valid variable name. So if you were to print that underscore, you would get all those values back. In general, when you use an underscore in Python, you're telling the developer or whoever is looking at your code that that value is not important. It's just a convention for ignoring the value. But now that we have some information regarding multiple assignment, I'm going to be showing you how unpacking works. And to demonstrate it, I'm going to create a function called add, and that's going to take A of type integer and B of type integer, and that will return none. Then inside this function, we're going to print the formatted string of A plus B equals, and it will give us back the result. Now that we know about that cool trick using F strings. So first of all, let's try to call this function the regular way by inserting the function name and adding our values. So here we can type in 5 and 10. And when we run this, we should get the result back. But now I'm going to show you a different way to provide these values. So here we're going to type in numbers of type dictionary, and this will contain a dictionary of string to integer. And here we're going to pass in the parameter names followed by the values that we want to insert. For example, there's a parameter name called A, and we want to insert the value of 5. And then we have B, and we want to insert the value of 10. Now that we have a dictionary of numbers, we can choose to unpack it directly into our function. And to do so, we're going to use a double asterisk, and we're going to insert our numbers. And this syntax is going to unpack that dictionary. And by unpack, it's just taking the values out of that dictionary. So it's telling Python that A should be mapped to A and B should be mapped to B in the function. So now if we call this, we're going to have the exact same result. But let's take a look at one more example before we move on. So here we're going to create some numbers, which will be a list of type integer, and this will equal 1, 2, 3, 4, and 5. Then we're going to create something called params, which stands for parameters, and that's going to be a dictionary of string to string. And inside here, I'm going to create a separator, and this will be the separator, and an end, with this being the end. Now, by looking at both of these, you probably guessed that I'm going to be using them with the print function. So first, I'm going to unpack the numbers as the first argument. And we already did this in a previous lecture, but by providing an asterisk in front of a variable that contains an iterable, it allows you to unpack those arguments. And the same thing goes with the dictionary. Now we can pass in asterisk asterisk parameters, and that will insert these keyword arguments for us. So now if we were to run this, we would get this output. And that was quite nice because we didn't have to directly type out these numbers in our print statement, and we didn't have to directly insert this setup into our print statement, which means if we want to use this setup throughout our program, we can refer to a single variable to do so. You just need to make sure that these keys exist in whatever function you are using, because if something doesn't exist, it's going to raise a type error that it is an invalid key argument for that function. One of the biggest mistakes I see students make when they are learning Python is confusing the equality operator with the identity operator. They both do things that are similar, but they are not the same. So first of all, suppose you have two variables and that you want to check that they contain the same value. The correct approach for comparing values is to use the equality operator. This checks that A contains the same value as B. And if you were to run that, it would return true. But a lot of beginners tend to make this mistake. They tend to check that A is B. And the problem with this approach is that sometimes it's going to return true. So as a beginner, you're going to think they are the same thing. But this is a huge mistake because this is checking that the identity of A is equal to the identity of B. And with small values such as 200, Python usually is going to use some special trick to make A have the same identity as B just to save on memory. Since it's such a small number, Python stored both A and B in the same point of memory. But watch what happens when we make these examples a bit more complicated. For example, we might insert the value of 1000 here, and for B, we might choose to insert the integer value of 1000. Now, the next time we run this, our first print statement is going to return true because A has the exact same value as B. But our second print statement is going to return false because A does not have the same identity as B. In other words, A is not B. These are two completely different variables. And that's what is does. It checks the identity or the memory address of these variables. But to better show you what I mean, I'm also going to print the memory addresses of both of these variables. And to do so, I'm just going to print the formatted string of the ID of A, and that's going to equal that ID, and then the ID of B. And what you should notice is that while they have the same value, they are not the same object because they have two different memory addresses. And as I mentioned earlier, with small numbers such as 200, Python is going to perform some magic that saves on memory by giving them the same memory address. So if we were to run this now, you would notice that both of these IDs are the same. And that's why is returned true, because for this specific moment in our script, Python thought that the most efficient solution for this small number was to give all the variables that used it the same memory address. And all I'm trying to say is that this is extremely unreliable for checking values. It's not made to do that. So do not use is when you're trying to check for the value of an object or of a variable. And you will also see is being used with types that never change, such as none. But to show you an example, I'm going to create a variable of type integer or none. So it's an optional and it's going to be set to none. So this might contain a value. So if var is none, we're going to print that there is no var. Else we can print that the var is var. And this would be the correct check for none. You would never check that var is equal to none. And luckily, if you're programming in PyCharm, you will even be prompted to use the identity operator. So we can replace that equality with is. And maybe an even better example would be if you had a class such as animal. And we will just ignore that implementation and create two objects. Object 1 of type animal, which will equal an animal, and object 2, which will also be an animal of type animal. And actually, I'm just going to call this cat and dog. But here we obviously understand that cat is not dog. And if we were to print the ID of cat and print the ID of dog, you would see that they would both have different memory addresses. So performing a check such as print cat is dog will obviously return false because these are two completely different objects with different identities. But if we were to check something silly such as cat is cat, you would see that that would return true because it contains the exact same memory address. In this section of the course, I'm going to be teaching you about a very useful feature in Python called data classes. Theoretically, you can do everything I'm about to show you using a regular class, but data classes are just much more convenient. So let's take a look at how we can create a data class and what the advantages are of using it. But first, we need to import from data classes the data class, because we're going to be using it as a decorator on a regular class. Now, suppose we're keeping track of some cryptocurrency, and that for each cryptocurrency, we want to keep track of the ID, the value, and the name. So what we're going to do is model our data using a data class. And the sole purpose of the data class is to hold and represent data. So to create a data class, we need to first annotate it as @dataclass, and then we need to create our class as normal. Next, inside here, we just need to define all the information that a coin should contain, such as the name, which will be of type string, the value, which will be of type float, and an ID, which can be of type string. And that's all our data class will contain for now. And below that, we can create our if name is equal to main check and create some coins. The first one being a Bitcoin of type coin, which will equal a coin called Bitcoin with a value of 10,000 and with an ID of BTC. Then I will duplicate this and call it Bitcoin 2. It's going to contain the same name, value, and ID. And finally, we're going to create one more coin called Ripple of type coin, which is going to equal this coin called Ripple with a value of 200 and an ID of XRP. So as you noticed, these classes do not contain functionality. They just hold information, which is just very convenient to keep track of. And another benefit is that if we were to print the Bitcoin and we were to print this Ripple, what we would get back is something a lot more readable than what we would get back with a normal class. And thanks to this, it also makes comparing objects easier, which means we can print whether Bitcoin is equal to Ripple or whether Bitcoin is equal to Bitcoin 2. And this will check the values by default. So now if we were to run this, we'd find out that Bitcoin is not Ripple, but the first Bitcoin is the same as Bitcoin 2 in terms of their values. And just like with a regular class, we can access all the attributes by using dot notation. So you can easily perform other checks, such as checking the value of Bitcoin to the value of Ripple. And obviously they are not the same, so I'm not going to run it. But as you can see, it's very easy to use the data from these data classes. And just to show you all the energy we saved, I'm going to be creating the same data class using a regular class. So I'm just going to comment this out and recreate our coin class right below it. So here we need to create a class called coin. And first of all, we have an initializer, which is going to take a name of type string, a value of type float, and a coin ID of type string. And this will return none. And you might be asking, why did I use coin ID here instead of just ID? Well, funny enough, ID shadows the name of the built-in ID function. And with a regular class, this is an issue. But with data classes, you can use built-in names without any problems. I mean, I didn't show you this, but if we were to go back, we can do things such as using print as a variable name. And this wouldn't ever cause an issue. But if we were to do the same thing here, this could potentially lead to issues. And I think this also works with data types. Can we type in string? Yeah. And we can also just pass in literally the data type. So we can say string of type string. And that would work just fine for the data class, while with a regular class, that might cause some issues. Anyway, all I want to say is that with data classes, we have more flexibility with those names. And that's why I renamed this the coin ID in our class. But inside here, the next thing we need to do is the same thing as always. So self.name is equal to name, self.value is equal to value, and self.coinID is equal to the coin ID. So now we have a class that looks exactly the same as our data class. As you could see, it took a little bit more effort to write this. And on top of that, if we were to rerun our code, you would notice that nothing would work as intuitively as it did with the data class. I mean, first of all, look at the representations we get back when we try to print Bitcoin and Ripple. All we get back are the objects with their memory addresses, which is really hard to read if we want to see the values. So to see the values, we would also have to define our very own representation functionality. And second, this time when we compared Bitcoin to Bitcoin 2, it returned false, because what it did is compare these two values, or these two representations, which obviously are different. In other words, using the comparison operator here wasn't any different from using the identity operator. So no matter what we did here, it would return false, unless we checked that Bitcoin was equal to itself, which would be quite ridiculous. That's the only way we could get true out of this comparison. So as you could see, using a data class can save us a lot of trouble when we just want to create classes that contain data. But this lecture was just supposed to be a small introduction, so we will definitely be covering more throughout the rest of this section of the course. Previously, we covered how we can create a very simple data class, but there's still an issue that we have to solve. And that is, how do we use mutable types with a data class? So let's jump into the code immediately by importing from data classes the data class and the field. Then we're going to create that decorator that says add data class, and we're going to create our class called fruit. And this fruit will contain a name of type string, some grams of type float for the weight, and the price per kilo. Then we're also going to include whether this fruit is edible or not. Personally, I can't really think of any fruits that are not edible, but let's pretend that there are some fruits that you just cannot eat. But since this is such a rare occurrence, we're going to provide it with a default value. And to do so, we're going to use the field function. And all it does is tell Python that we're creating a field. And with this, we can also insert a default value, such as true. So by setting this to true, we're telling Python that every time we create an instance from this class, to just insert true as the default value for edible. So we don't have to do that every time, because once again, having a fruit that's not edible might be considered rare. But it's also worth mentioning that if it's a value as simple as this, you don't really need to use the field function. You can just pass in true directly. But the order of default values must come after the fields that do not have default values. So we can't say that the default name would be default because the fields after that do not have default values. So just like with regular classes, the default values must come at the end. Anyway, at this point you're probably asking, why did I show you field if we can just do this directly? Well, field becomes very important when you are creating mutable defaults. For example, you might have something called related fruits, and that will be a list of type string. Forcing the user to provide this value each time they create an instance of fruit is ridiculous, because not all fruits are going to have related fruits, or actually I guess most fruits would, but that's just not a value you would want to force a user to insert, or at least in this example. So what we want to do here is create a mutable default, but we cannot just simply pass in a list or a set or a dictionary, because those are all mutable. And if you hover over it, it will even tell you that the mutable default of list is not allowed, and that you should use a default factory. So once again, we can use our field, and inside here we can define a default factory. Then we just need to insert which data type we want to use here. So in this example, we want to create an empty list. So we'll just pass in the list type. And now Python will be fine with that, because this will make sure that each time we create a new instance, we will also create a new list. Theoretically, if we were just to pass in these square brackets to create a list, it would not create a new list every time. So it's important that we use the default factory here. But now for the rest of it, it should be quite straightforward. So let's create our if name is equal to main check and create our fruit called apple, which will be originally of type fruit. And that will equal a fruit with the name of apple, and it will be 100 grams, and the price will be 5 currency per kilo. And as you can see, we did not have to provide the default values. So now if we were to print this apple, what we should get back is a fruit that contains the name of apple, the grams of 100, the price of kilo of 5, and then edible will be set to true by default. And the related fruits will just be an empty list. But we can also choose to specify those values. So here we're going to create a pair of type fruit, which will equal a fruit called pair. And here we will have 250 grams, and the price will be 10 currency per kilo. And we still have the option to pass in whether it's edible, and we can also pass in the related fruits. So maybe it's inedible. And if it is, we can just pass in false as the value. And here I wrote it as a keyword argument, but that's not really necessary. You can also just pass it in as follows. But since a pair is edible, I'm going to leave it set to true. And instead, I'm going to add some related fruits. And the related fruits will be an apple and an orange. Then below the apple, I'm going to print the pair, and I'm going to print the pair.related fruits. And the next time we run this, what we should see in the console is a new fruit of type pair, or actually that has the name of pair. Edible is still going to be set to true by default. And this time we're going to have those related fruits, apple and orange. And we can also refer to the related fruits by using dot notation. In this lecture, I'm going to be teaching you the concept of post initializers in Python. So to get started, I'm going to import from data classes the data class and the field once again. Then we can create our data class by using this decorator, and we're going to continue with our fruit. So that fruit will have a name of type string, some grams of type float, and a price per kilo, which will also be of type float. And on top of this, we're going to have a total price, and that's going to be of type float as well. And what we want to do here is multiply grams by price per kilo. So let's try to do that by typing in price per kilo times grams. And unfortunately, that's not going to work, and it's even going to give us a warning. Even if we were to refer to self, that's not going to work either. So what we have to do here is create a field and say that we will initialize this later. So init will be set to false. And one way to do this is using the post initializer. So here we can type in post init, and this doesn't return anything. So we're just going to return none. And post init runs directly after the original initializer, which in data classes we don't see because it happens implicitly. So here we can insert any kind of code we want to happen after the original initializer. And what I want to do here is type in self.totalPrice and set that to self.grams divided by 1000. So we get the kilos, and I want to multiply that by self.price per kilo. And that will set the total price to this computed value after the original initializer gets called. Also, I didn't show you this yet, but you can also add methods inside your data classes. For example, you can add one that's called describe, and all this will do is print a quick description regarding the fruit. So print the formatted string of self.grams, grams of self.name costs this many dollars, self.totalPrice. So it's the exact same process as defining a method for a regular class. But as always, let's create our if name is equal to main check to actually see how the post initializer works in this example. So here we can create an apple of type fruit, and that will equal this fruit called apple. It will have 1,500 grams and the cost per kilo will be $5. Then we will duplicate that and change this to an orange. So we have two examples. And the orange will be a bit heavier and it will also cost more. Now we can print both the apple and the orange. And when we run this, we should get these two fruit objects back with the total price being calculated as we described it to do so in the post initializer. But something else that's cool is that we also have our methods that we can use with our fruits. So here we're going to describe the apple and we're going to describe that orange. And when we run this, we should get these descriptions back. That 1,500 grams of apple costs $7.5, while 2,500 grams of orange costs $25. So it's pretty cool that we can use methods with our data classes. So yeah, if you ever have code that you want to run after the original initializer, just provide a post initializer in your data class. Although I should mention that this approach for the total price might not be ideal, because at any moment, if the weight of the apple or the price of the apple were to change, for example, if we were to type in apple.price per kilo is now 100. As soon as we run this code again, the changes will not take effect. And that's because the post initializer only runs once, which means no matter what we do to the information regarding the class, the total price will always be the same. So the better approach would be to use a computed property, but I'll be covering that quite soon in a different lecture. In the previous lecture, I showed you how we could create a post initializer to execute some code after the original initializer in our data classes. But now it's time I show you how to use the post initializer properly. And we're going to be using the code from the previous lecture for this example. And to get started, we're going to import something called an initvar. And to demonstrate how it works, I'm going to create a field which is called isRare. And that's going to be of type initvar. And in square brackets, we're going to pass in what kind of type this should be. So theoretically, this is going to be a Boolean, but it can also be none. So we're going to define this as an optional, and we're going to set that to none originally. And by providing initvar as the type annotation for this field, we're telling Python that this should be part of the initializer and not part of the class. And immediately, as soon as you create this, you're going to notice in the post initializer that we're going to have some syntax highlighting. And that's because we did not provide it in the parentheses. So here we are actually forced to provide isRare and say that that is of type Boolean or none, because this has now become part of the initializer. So you might be asking, what do we want to do with this field? What will happen if the user inserts true for isRare? Well, in this example, we can just pretend that if a fruit is rare, then the worth of that fruit will be doubled. So here we can type in if isRare, self.price per kilo is going to be doubled. And I actually meant to use the in-place assignment operator. So asterisk plus equals. And this will effectively double the price of the fruit if isRare is provided. Now let's go down to our if name is equal to main check, remove this line of code, and create a new fruit. And this one's going to be called passion fruit, or I'm just going to call it passion. And here we can type in that the fruit is passion fruit, and we're only going to have 100 grams of it, but the price is going to be incredibly high. So here I'm inserting 50, but now we also have the option to pass in isRare. So if we pass in isRare and set that to true, you'll notice that when we describe this fruit, that the price is going to double. As you can see in the console, 100 grams of passion costs $10, even if we provided the price per kilo to be 50. And that's all thanks to our initvar, because here we gave some information to our post initializer that allowed us to double the price of the fruit. And if we were to say this was $100 per kilo, it would still double the price per kilo. But let's also print the objects themselves. So print apple, print orange, and print passion, just so we can see what the data looks like. And the very first thing you'll notice is that isRare is not included as a value for any one of these fruits. So even if we were to reference it, we would get nothing back because it was declared to be an init only variable, which means we can only use it for initializing our fruit object. And that's very useful because, once again, if we wanted to double the price or provide some other custom behavior that depended on a value a user passed in, we can now do that without cluttering our class. So this will only be present in the initializer. Recently, I mentioned that we can compute values using the post initializer after we've initialized the class. But the problem with this approach was that if the user was to change the price per kilo during the lifetime of our program, the total price would not take that change into account. For example, let's go to our if name is equal to main check or our main entry point. And this time I'm going to remove everything but the apple. And right now, if we were to run this, what we should get in the console is a fruit with the name of apple. The grams are set to 1.5 kilos with a price per kilo set to 5, and that should give us a total price of 7.5. But once again, during the lifetime of our program, for whatever reason, we decide to update the price per kilo to maybe $20 per kilo, because there's some inflation with apples. But the problem with our current data class is that if we were to print, let's say, the apple once again, and I'll also describe the apple, what you'll notice is that even if the price per kilo changed, the total price remained the same. So 1,500 grams of apple still costs 7.5, which means we're losing a lot of money due to inflation because our prices did not update accordingly. So it's important to keep into account that if you are using the post initializer, the values that you create in there in general will not change. So what I'm going to do next is actually remove the post initializer, because what I'm about to show you will not be using it. And we also won't need these two fields, because what we're going to do next is create what we call a property. And to create a property, we need to use the add property decorator. And that's just going to say that this method that we create should be considered a property. So here we're going to give it the same name as total price, and this will return to us a float, because this should return the value that we want to get when we reference total price. And here we're going to return the self.grams divided by 1,000, so we get the kilos, times the self.price per kilo. And that's all we had to do. Now, every time we reference total price, it's going to perform this calculation from scratch, which means we're always getting the updated price per kilos. So now let's go back to our main entry point and see what happens when we run the exact same code. So here we tap on run. And what you should notice this time is that the price actually gets updated this time. As you can see, the first fruit that we create has a price of 5. And then later we decide to actually update that to 20. And the next time we actually run our class, the price per kilo is actually set to 20, which means that when we describe that fruit, we also get the correct price. And I'm also going to describe the fruit real quickly before we update the price per kilo. So here we can type in apple.describe and rerun the code, just so you can see that when we update the price per kilo, it does make a big difference. So anytime you have something such as, let's say, total price, which is just a value that depends on other fields from the data class, make sure to create a property out of it, because this will just make sure that you're getting the most up-to-date information each time you refer to the total price, unlike with the post initializer, which only sets that value once. And I know you might be asking, what happens if we don't use the add property decorator? Well, the next time you try to run your code, it's not going to give you back anything useful. It's going to think that you created a method and not a property, which means to actually get the total price back, you would have to call it using the parentheses, and then you would get the value back. But with add property, we can just treat it as a value or as an attribute that belongs to this data class. So apple.totalPrice, and we will get back the same result. To continue getting more practice with Python, we're going to be creating another project. And what we're going to be creating here is a nice little note-taking app. And we're going to be using data classes and regular classes for this. So to get started, let's import from data classes the data class and the field. Then I'm going to also import something from UUID, which is going to be UUID4 and UUID. And to explain what this is, I'm just going to create our data class real quick, and then I'm going to show you exactly what it is by creating an object from our data class. So here we'll type in add data class, and we're going to create a class called note. And this will take an ID of type UUID, which will not be initialized immediately. So we will set init to false. Then this note will have a title of type string and a body of type string. Then below we're going to type in post init because we're going to want to initialize that ID. But inside here we can type in self.id is going to equal this UUID. Cool. So now we have our data class. So now I can quickly show you what that UUID actually is. So we're going to create our if name is equal to main check, and we're going to create a sample note. So note of type note is going to equal this note here that says hello, and the body is going to say my name is Bob. And what we're going to do is print that note. And when we run this, what we should get back is first an ID of type UUID, which is this long identifier. And all the UUID4 method does is make it easier to create these very unique IDs for our notes in a very efficient way. And every time we rerun our program, it's going to give it a different UUID. And in a real life project, these would be used to keep track of each note because some notes might have the exact same title and the exact same body, but we wouldn't want that to be considered the exact same note. So we would give it a different UUID. And that's all we're doing with that UUID method. We're giving it a unique identifier. Anyway, now that we know what that is, I'm just going to remove all of this and add an ellipses. Because under the data class, we need to create a regular class which is going to be our note-taking application. So class note app. And as always, we should initialize our class. So inside the note app, we're going to type in init, and this is going to take an author of type string, so whoever is writing the notes, and it's also going to take a list of note, in case you want to include some default notes in your application. And of course, there's a chance that they do not insert a list of notes. So what we can do is also say that this is an optional type, which might also be equal to none. And the default value will be none. And the initializer returns none. Then inside here, we can type in that the self.author is going to equal the author. And we need to check whether the user has inserted notes or not. So if notes is none, that means the user didn't insert anything. So we're going to create a new list for our notes. And here I'm going to type in self._notes because we want this to be considered a private variable, and that's going to equal an empty pair of square brackets. Else the self._notes is going to equal our notes. And in case you forgot, all this underscore convention says is that this variable should not be used outside of the class. It was only made to be used within the class. Also, as part of the initializer, I'm going to want to display some instructions for whoever is using this app so that they understand how it works. And to do so, I'm going to type in self.display instructions, which is a method which we did not create just yet. So we should create that immediately right below. And here we can type in add static method, since it's not going to depend on the instance, and it's going to be called display instructions. That will return none because it's going to be a bunch of print statements. And to save time, I'm just going to paste them in because typing this all out doesn't teach you anything, but I will explain what I wrote. So first I have the welcome to the notes message. Then the next line just says, here are the commands: 1 to add a new note, 2 to edit a note, 3 to delete a note, and 4 to display all notes. So with that, the user should understand how to use this application, which means next we can actually get started with creating the functionality. And the first one we need to cover is adding a new note. So right below, I'm going to type in def_add note, and that's going to return none. And inside here, we're going to type in title of type string, which will take a user input. And here we can just type in title, so they know that they have to insert a title. And we can duplicate that because the next one has to be done for the body. And with this information, we can create a new note. So note of type note is going to equal this note here with the title and the body. Then right below that, we can type in self._notes.append, and we can append that note. Of course, we want to tell the user that we did that successfully. So note was added. Next, we need to create the functionality that allows us to edit a note. So right below add note, we will create edit node, and that will return none. And inside here, we will print which node would you like to edit. And here we're going to type in self.showNotes. And we did not create this just yet, so I will create a placeholder directly below, def show notes, which returns none. And here we will raise a not implemented error in case we forget about it. But now let's continue with this method. So right below the show notes method, we're going to type in try, because everything here is going to be considered dangerous. And here it's quite important because we're going to ask them which node they want to edit. So here we'll type in node index of type int, and that's going to equal the integer value of the input that asks them for the index. And for our program, we're going to make sure that the nodes start with the index of 1, even if our list is going to start with the index of 0. So what we have to do at the end is subtract 1, because when we show them those nodes, they're going to have an enumeration that starts with 1. But after that, we can grab the current node, which will be of type node, and that will equal self._nodes at the node index. And that's how we're going to grab that node. Then we can type in new title of type string is going to equal the input of that new title, the title that will replace the original title. And we're going to do the same thing for the body. So body, new body. And with that information, we can now update the current node. So next we're going to type in current.title, and that's going to equal new title. And current.body is going to equal the new body. And as always, it's nice to give the user a sort of success message, such as the body was updated, or even more specifically, the node was updated. And that was all the functionality we needed for this try block. But it is important to remember that these two lines can possibly raise exceptions. And one of them is the index error, because they might select an index which does not exist. For example, if we have 3 nodes and they insert the number 4, that's not going to be in our range. So it's going to raise an index error. And here we need to ask them to please select a valid node index. And we will just use recursion here and tell them to edit the node once again. And another exception we might run into is a value error. So except value error. And here we can type in index cannot be empty. And right below that, we will type in aborting operation. And this block here is just going to cover everything that can possibly go wrong when we're trying to convert the input to an integer. Because right now, if we enter any letters, it's going to raise an exception, or if we also enter nothing, it's going to raise an exception. But that covers the edit node method. So next we need to create a method that allows us to delete nodes. And it's going to be very similar to the edit node method. So I'm actually just going to copy this and paste it directly under. But since the functionality is going to be slightly different, I am going to remove everything from inside here. And we also need to make sure to update the title. So delete node. And instead of which node would you like to edit, we will type in which node would you like to delete. And once again, we're going to show those nodes. Then in the try and except block, we need to try to grab the index once again of the node that we want to delete. So node index of type integer is going to equal the same thing as from before, the integer of input with the index. And all of this is going to be -1. And if that works, we're just going to print that the node was deleted. And I actually forgot to delete the node, so this would be a false message, but inside here, directly under the node index, we need to use that along with the delete keyword. So self._nodes at the index of the node index. Then the errors are more or less going to be exactly the same, except we need to replace this with delete node. So we have a recursive call to deleting that node in case they enter an index that doesn't make sense. Okay, so we're making some very good progress here, but we still have a few more methods that we need to create. One that allows us to actually see the nodes, and another one that allows us to select an option. So let's move on to the show nodes method and actually implement the functionality. So inside here, we're going to type in if not self.nodes, And this will just check if there are notes or not. And if there aren't any notes, of course, we want to print that there are no notes. And we will return out of this function. Otherwise, we will create an enumeration by typing in for I and note in enumerate the self.notes. And we want the indexing to start at 1. We will print the index, which is I, followed by the notes.title and the notes.body. And that's all we had to do to display those notes. Next, we need to create that method that allows us to select an option. So select option. And this will take some user input of type string and will return none. And first of all, we need to make sure that the user always picks a valid option. So if the user input is not in 1, 2, 3, or 4, that means they wrote some complete nonsense that has nothing to do with the program. So we're going to print, please pick a valid response. And we're going to return out of this method. Otherwise, we need to create a bunch of if-else statements. One that checks that the user input is equal to option 1. And if it is, we can add a note. If the user input is equal to 2, we can edit a note. And we're going to do the same thing for the rest of the options. So if it's equal to the string of 3, we will delete a note. And finally, if the user input is equal to 4, we're going to display all the notes. So show notes. And that's all we had to do inside this method. Now, there's only one more method to create, I promise. And this is the one that actually runs the application. So right here, we're going to type in def run app. And this time we're not going to use the underscore because this is actually the only method we want the users to see. So here we have def run app, which returns none. And what it will do is create an infinite loop that takes some user input of type string. And the input is just going to say u. And with this user input, we can select some options. So select options. And of course, we need to pass in the user input. And with that being done, we can go to our main entry point and actually start using our app. First of all, I'm going to create some sample notes, which is going to be a list of type note, and that will equal these sample notes. So notes with the title of title 1, and the body is going to equal hello there, Bob. Then I want to create a second note that has the title of title 2, and this will contain more text. And actually, I need to type in body there. And thanks to these sample notes, it's going to make testing this a lot easier because we don't have to create a lot of random notes each time we run the program. So here we can type in note app, which will be of type note app, and that's going to equal a note app with the author set to Bob, and the notes are going to equal these sample notes. And we are not required to pass in any notes, but we can if we want to. Then we can type in note app dot run app. And all that's left for us to do here is to actually run our application. And what we should get as an intro is some instructions on how to use the application. But let's see what kind of notes we already have. So if I enter 4, it's going to tell us here that we have these 2 notes. And if I enter something that doesn't make sense, it will ask us to please pick a valid response. And I don't know why I wrote response. It's very early in the morning. What I actually meant to write is a valid option. Anyway, with that being fixed, we can rerun this script and we can try to add a new note. And this will be one called Bob. And the note will be, remember to cook dinner for the wife. And we will get that success message. Now, the next time we display all the notes, we should have that as a note. And let's see what happens if we add some random text. This time it's going to tell us to please pick a valid option. But let's also try to edit a note. Let's say that we don't really like the first note. So here we're going to select option number 2. It's going to show us all the notes and it's going to ask us which note would we like to edit. and we want to edit note number 1. So the new title will be James, and here we'll write, I don't really like James. And the next time we display all the notes, you'll see that our first note will have been updated. And finally, the last thing we need to test is whether we can delete a note. So here we're going to enter option number 3. And with option number 3, we're going to select 2 as the index. And the next time we display our messages, it should have deleted whatever was at the index of 2. Or in programming, of course, that would be the index of 1. But in the real world, regular people do not start counting at 0. They start counting at 1. So it's good to make this easy on them by making sure things start at 1. So realistically, this is at the index of 1. But in the real world, we would consider this the index of 2 because it's the second element in our list. But maybe you could name this to something better, such as position or item number, whatever you want. So that was the entire note-taking app. But for homework, there are a few issues that you can try to fix. One of them is that if you select on add a new note and you just tap on enter and tap on enter and display those notes, you'll notice that we're actually able to insert an empty note. And this is ridiculous. So if you're feeling up to the challenge, try to implement some code that prevents the user from doing that. Another thing that would be nice is an option to display all the commands once again. So try adding a 5th option that allows the user to do that. And finally, if you're really feeling up to the challenge, add a 6th option that gives back all the details regarding the notes, the total characters, the amount of notes, the author, etc., etc. Just some information regarding those notes. In this section of the course, we're going to be learning about asynchronous programming. And to be more specific, we're going to be learning how we can use async IO. So what is async IO and where should we use it? Well, in programming, it's very common to make a request to fetch some data from the internet. Sometimes it might even take several seconds to get a response back, depending on the connection or on how long the website takes to respond. But one thing we absolutely do not want is to have our program frozen while we're waiting for that response. So that's where async IO comes in. Async IO stands for asynchronous in and out, and is used primarily in IO-bound tasks, such as for fetching data from APIs. And asynchronous means not at the same time, as opposed to synchronous, which means to happen at the same time. So to make this more visual, suppose you have 2 functions, function 1 and function 2. And I'm writing this in the form of comments because, of course, I don't want to write this all out. But suppose you have these 2 functions. Now here we have a call to function 1 that has a delay of 2, so this would take longer to complete. Also, I forgot to mention, but pretend that these functions are grabbing data from the internet. So they're making a request to fetch some data. And for the sake of this example, the first function call is going to take longer. If we were to do this synchronously, it would take a total of 3 seconds because we would call function 1, wait for the response, and once we got the response back, it would be able to move on to the next line of code. But with async IO, we can start both of these at what will appear to be the exact same time. So it will start the request with function 1, and while it's requesting the data, it's going to move immediately onto function number 2 and request the data for that as well. And since function 2 will take less time to complete, our program will be able to terminate function 2 faster than function 1. And in total, this will take 2 seconds as opposed to 3. So we did not have to wait for function 1 to get started with function 2. We were able to start both of these at what seemed to be the same time. And I really want to stress that asynchronous programming does not speed the execution of our code. It only allows us to continue with other code while we wait for the results from an external source, such as a server or a web page. But that was just a bit of the theory behind asynchronous programming. In the next few lectures, I'm going to be showing you some very practical examples. So don't worry if none of this made sense. It was just the theoretical part of this section. In this lecture, I'm going to be showing you how you can get started with using async IO in Python. And lucky for us, it's a built-in module. So all we have to do is import async IO to actually get started with using it. But I'm also going to import a specific type from async IO, which is the task type. So from async IO, import task. And now that we have those imports, I'm going to immediately create our main entry point. And here, it doesn't really matter what kind of code we have. All that's important to understand here is that we have synchronous code. And when you are working with async IO, one thing you need in all your scripts is a main entry point, because you need to run that through async IO to actually make your code asynchronous. So to make our script asynchronous here, we need to do two things. First, we need to add the async keyword in front of our function. Using the async keyword in front of any function will define it to be asynchronous. And then, as I mentioned, we still need to define a main entry point for async IO. We cannot just run main directly. So down below, we're going to type in async IO.run, and the keyword argument we will use is main. And inside here, we will pass in our main entry point. So this is really the minimum amount of code we need to write to make any script asynchronous. But now that we have our main entry point and our very first asynchronous function, let's try to actually use it by requesting some dummy data. So what we're going to do next is import from datetime the current date and time, and we're going to create a new asynchronous function. And I also want to mention that you might hear asynchronous functions being referred to as coroutines. And coroutines are just functions that can be suspended and resumed in the future. Anyway, let's create this async function. So async def fetch data. And here we're going to type in some input data. And it's going to return to us a dictionary. Then the very first thing we will write is that we are fetching some data. So fetching data. So we can display this information in the console. Next, I want to create something called start time, which is going to be of type date and time. And that's going to equal datetime.now. And that's going to give us back the current date and time. Then I'm going to use the await keyword. And this is a special keyword that we use with asynchronous functions. And all it tells our script is to wait for this line of code to complete before moving on. And the reason we're using it here is because we're going to be using a built-in method from async IO called sleep. And here we want to pause the program for 3 seconds. And then we're going to create an end time just to show you that 3 seconds have passed. So I will just copy and paste that and call this end time. Then we will pretend that we actually retrieved the data. So here we can print data retrieved. And of course, we want to return that data. So return the dictionary, which will first contain the input data. So input, and here I'll pass in that input data. This parameter is just being used to give some flavor to our fetch data function. It doesn't do anything in particular. It just simulates that there's some data. Then we want to define the start time, which is going to be a formatted string of start time. And we're going to format that using the datetime format specifier. So hour, %minute, and %second. And we're going to do the very same thing for the end time. So you can just copy this line of code and change this to end time. And obviously it would be smart to also change this to end time. But now that we have this function that simulates fetching data, let's try to use it inside our main entry point. So here we're going to create two variables, one that's called data1 of type dictionary. And what we want to do here is await our fetch data asynchronous function. And once again, all await does is tell the program that it should wait for this function to complete before moving on. And we're going to do the same thing for data2. And as the input data, I'm going to insert 2 here. Then right below, we can print the formatted string of the data1 with an equals, just to keep things simple. And I'll duplicate that and do the same thing for data2. But next, let's try to run this script and see what happens. So if we tap on run, what you should notice is that our script is still running synchronously, which means it has to wait for one function to finish before moving on to the second one. As you can see in the output, the start time for the first function was at 41 and finished at 44. Then the second function started at 44 and finished at 47. So what was the point of all of this? Well, at this stage, there was no purpose in all of this, because there's actually one more thing we have to do before we benefit from using this asynchronous code, and that is creating tasks. So let's go back to the main entry point, and here what we're going to do instead is create some tasks. So this will be a task of type dictionary, because that's the data type we will get back when we fetch the data. And what we're going to do is type in async IO, create task, and inside here, we're going to fetch the data. And we're going to do the exact same thing we did here. So here we will insert 1, then I will duplicate this and call this task 2, and then insert 2 here. And this time, instead of awaiting fetch data, what we're going to do is await the task. So here we need to await task 1 and then await task 2. And by using this approach, we're telling Python that we want to start this task. We're creating a task and starting it. And the task in this example is fetch data. So that will start the task. And once it starts, it's going to move on immediately to the second line, where it's going to start another task. So those are going to start at what seems to be the exact same time. Where our code becomes synchronous again is here, because here we need to wait for task 1 to complete before moving on to the second task, which is perfectly fine, because now we're actually benefiting from our asynchronous code. And to demonstrate it, we're going to run our script once again. So this time when we run it, you'll notice that it starts both of them at what seems to be the same time. And even when you look at the data, you'll see that the start time was at 38 for both of them, and then that they both had the exact same end time. And this is amazing, because now we can request data from the internet, and we don't have to wait for each request to complete before starting another request, which means we can create as many requests as we want, and that will not affect the speed of our script. Previously, we learned a little bit about how we could get started with using async IO in our Python projects. But now it's time that we cover the topic of tasks in a little bit more detail. And a task in async IO is a scheduled and independently managed coroutine. And the nice thing about tasks is that we can query them, we can cancel them, we can retrieve the results later if that's what we want, and we can just handle them in many different ways. They are very flexible. So let's see how they work in a bit more detail. And to get started, I'm going to import async IO, and I'm going to import from async IO the task. And I do just want to mention that you're not required to import these separately. If you want, you can also just refer to async IO.task to use that type annotation. That works perfectly fine. I just really hate using dot notation with types. So as a personal preference, I import them on separate lines. Anyway, we also need to import from datetime the date and time. And for all of the examples, I'm going to be using the same function from the previous lesson. So this is a fetch data function that takes some input data and returns to us a dictionary. I did provide one minor tweak though, and that is providing a delay. So this time we can control how many seconds we want this function to sleep. But otherwise it's the exact same function. It simulates fetching data from some sort of API. So in the previous lesson, we learned how to create and run non-blocking tasks in our code while we wait for a response from the API. And to do so, we just need to convert all of this code into asynchronous code. So here we'll just type in async IO.run and make main the main entry point. Then of course, we also need to make this asynchronous, or this will not work. But to make our function asynchronous, we need to create a task. So here we'll create a task, which will be of type dictionary because that's what it returns. And we just need to use async IO.createTask along with the task that we want to start. And this will be fetch data with input data set to 1 and the delay set to 3 seconds. Then here we're going to await async IO.sleep for 1 second. And again, await just tells the program that we need to wait for this line to complete before moving on to the next one. It's a blocking line of code. Then we can print running other code, just to demonstrate that code can run while the task is running as well. And then we can get that data back by typing in data of type dictionary equals await task. And at the end of all of this, we're going to print that data. So let's run this and see what happens. When we start it, it's going to try to fetch the data, but as you can see, it was also able to run other code while it was fetching that data. And once it retrieved the data, we could display it to the user. So creating a task was quite simple, but there are also some other operations that we can perform on tasks while they are active, such as canceling a task if it takes too long. So for the next example, I will remove both of these lines of code and I will update the parameters in fetch data. This time we're going to return 2 and the delay is going to be set to 10 seconds. And maybe 10 seconds is too long for your program, so at that point you might want to cancel the task. But we're just going to cancel the task after 1 second. So here, to cancel a task, we can type in task.cancel. And then we can also provide a message on why we canceled it. And here we'll just type in took too long, because we are impatient and don't want to wait more than 1 second. Now we can print whether the task was cancelled or not. So task.cancelled, and this will return a Boolean that tells us about whether the task was cancelled. But I do want to mention that if you were to call this immediately after you cancel a task, it might not have the time to actually register that the task was cancelled. So if we were to run this, it might return false because we did not give it sufficient time to register that we cancelled the task. But if we were to await asyncio.sleep once again and run this code, you would notice that the next time we run it, it would have time to register the change or that the task was cancelled, making it return true this time. And that means that it's no longer fetching that data. But if you are cancelling your tasks around your program, a good idea would be to wrap your operations around in a try and except block, because here we can try to retrieve the data that we were going to retrieve anyway. So data is going to equal await our task. And of course, we want to print that data. Otherwise, we're going to accept an asyncio.cancelled error, because if the task was cancelled, we're going to run into this exception. So here we can print that the task was cancelled, and actually we can also get the error message back, so as E, and we can print E. And at the bottom we can print whether the task was cancelled or not. So let's run this and see what happens. And as you can see, first it tried to fetch the data, then when we tried to retrieve the data, it was able to understand that we cancelled the task. So that triggered the cancelled error. And then we got the error message back, and print.task.cancelled gave us back true because the task was cancelled and we had time to see that change. So now we know how we can cancel a coroutine. But next I'm going to show you how you can try to grab the result without waiting for that result. So what we're going to do here is remove all of this, and we're going to change the fetch data to 3 and the delay to 3. Then below this, we're going to create that same try and except block. And here we're going to create data of type dictionary, and that's going to equal the task.result. And the reason we're putting this in the try block is because if we try to access the result before we actually got one back, it's going to raise an exception. But if there is a result, it's going to work just fine. So here we can print the data, and we're going to accept asyncio.invalidstate_error as E. Then we can print E. So here we have a task that takes 3 seconds to complete, but we're only sleeping for 1 second before trying to access the result, which means obviously we're not going to get the result back in time. And this is what's going to happen if we try. So we try to fetch the data, and since no data has been returned yet, it's going to say that the result is not set, because just like that, we ran into an invalid state error for trying to access the result too early. But if we were to change this to 4 seconds, which will give it enough time to actually complete, the next time we run this, we should see the result in 4 seconds, because it was able to complete that task and retrieve the data. So result can just be very useful if you want to try to retrieve the result or access the result without using await. But something else we can do, which pairs very nicely with task.result, is task.done. So what we're going to do here is print task.done. And this returns a Boolean that informs us on the current state of our task, whether it is finished or not. And for this example, I'm just going to remove this sleep statement. And then I'm going to say that the data of type dictionary is going to equal await the task. And we can print that data as always. And right below that, I will print task.done. because obviously up here, this is going to return false since we didn't give it sufficient time to finish the task. But after it has actually finished, this will return true. So let's run that and see what happens. And just like I mentioned, the first time we try to check whether the task is done is going to return false because again, we just started that task. So it's obviously not done. But as soon as the task has completed, task.done is going to evaluate to true. And what I was trying to say earlier is that this could pair very nicely with task.result because you could easily check if task.done, the data is going to equal that task.result. We're actually checking that it has finished before trying to access the result. But moving on, there's one more feature that I want to show you that you can use with tasks, and that is the timeout feature. So suppose you have some input data of 5 and that the delay is set to 30. So you're trying to make a request for some data and it just takes far too long. Of course, you don't want to wait too long for some data because whoever is using your app is not going to know if anything's actually happening. So in most cases, it can be a really good idea to set a timeout to tell the user that, hey, something went wrong. It's taking far too long to retrieve that simple data. So we suggest you try again. Anyway, here we have a task that takes too long. And what we're going to do next is try to retrieve that data. So here we'll type in data of type dictionary. It's going to equal await asyncio dot wait for. And what's cool about this is that we can insert a task and a timeout. And here you can insert the timeout in seconds, how long you want to wait for that task to complete before giving up. And here we'll just add 3 seconds because we don't want to wait a lifetime. And then we will print the data if we get it. And here we can accept asyncio.timeout_error. And this will handle that exception. So print request took too long. So now if we try to run this, it's going to try to fetch that data, but after 3 seconds, it's going to say that the request took too long because we specified a timeout of 3 seconds. If we manage to retrieve the data ahead of time, for example, if there's only a 1 second delay for retrieving the data, everything's going to work perfectly fine. It's going to be able to access the data, so the timeout is not going to matter. In the previous lecture, we learned about tasks, how we can create them and how we can use them. And in this lecture, I'm going to be showing you how you can start a bunch of them without having to create each task individually. So instead of creating task 1, task 2, and task 3, and then awaiting all of them, we're going to be creating something that's called a future instead. And that's going to allow us to start all of these without having to go through the effort of creating all of them. Anyway, before we actually code anything, I just want to mention that we're still using the exact same function as from the previous lesson. So we're fetching data with a delay. And also something else we're going to do is import the future type. But next, let's go to our main entry point and create a future. So here we're going to type in tasks of type future, and that's going to return to us a tuple of responses. And a future represents an eventual result of an asynchronous operation. So all we're saying here is that we know that the results don't exist yet, but they will eventually. We're creating a promise in the future that something will come back. And then we can type in asyncio.gather. And this takes args, which means we can pass in as many coroutines as we want, or as many async functions as we want. So what I'm going to do here is first insert fetch data with an input value of 1 and a delay of 1. Then I'm going to add a comma and duplicate this line twice, and then remove the comma at the end. So here we're going to change the input data to 2 and to 3. Then the delay for the second one is going to be set to 2. And it was that simple to create a future. This will start all of these at what will seem to be the same time. So now we can start the process of fetching data from 3 different sources in one simple block of code, or in one simple line of code, because theoretically this could just be one line. But if you were to keep it as one line, it would end up being a very long line. So I prefer to format it like this, but if you don't want to insert all of them directly inside here, you can of course create a variable such as coroutines that will equal a list of all of this data. So you can just copy this and paste it in here. And then we can just pass the coroutines inside here. But of course you need to unpack this. So we have to use the asterisk. And this is perfectly acceptable as well. But I'm going to go back to the previous approach where we had all the data inside here, or all of the functions inside here, and remove our coroutines variable. Because next we want to get those results back. And here we can type in results of type tuple. It's going to equal await tasks. And now when we run this, what you'll notice is that it's going to start all of them at what appears to be the same time. And it's going to work perfectly fine. But I absolutely forgot to print the results, so you didn't get to see anything. So let's print those results. And this time we will get the data printed to the console. And if you want to make this more readable, of course, you can loop through it. You can say for result in results, print result. So that the next time you run this, it's going to print them line by line. And as you could see, they all started at what appeared to be the exact same time. But there's one more thing I should teach you before you start using this, and that's how to handle exceptions inside our gather function. Because right now, if any one of these were to raise an exception, we would lose all the results. And to demonstrate this, we're going to add a new parameter to our function. And this one's going to be called fails, which will be of type Boolean. And if fails is set to true, we're just going to raise an exception. And he will say that something went wrong. A very generic error that tells us absolutely nothing. And with this being done, we can go back down to our future and we can set our fails to false for the first one. And I'm just going to copy and paste this, set it to false for the second. And for the third, we're going to say that it should fail. And once again, right now, if we were to run this, you'll see that as soon as we get an exception, the program gives up. We don't get any of the other results back. I mean, the data was retrieved for one of them, but again, the exception kind of stopped the rest of them. So something really cool that we can do is specify the return exceptions keyword to be set to true. And this means that instead of failing, it's just going to return the exception to us instead of the result. So the next time we run this, it's not going to fail. We're going to get the data back, and we're also going to get the exceptions back, which in my opinion can be considered much nicer than having the entire operation fail. Also, if you were extra attentive to this lecture, you probably noticed that what we got back in our results was not a tuple. And we can actually see that once again by printing these results, that the data we get back is actually in the form of a list of dictionary. And the reason I annotated this as a tuple is because if you were to remove the future of type tuple from the tasks and you were to hover over the tasks, you would see that asyncio.gather actually returns a future of type tuple with dictionary and the base exception, because this can potentially return an exception. And that's why I returned a tuple here. But since we already know what the correct data type is for the results, we can change that to list of type dictionary. But to make that work, we would just have to annotate this as future without using that generic type. So if we were to pass in that this is a list of type dictionary, the code editor is going to complain because it expected a tuple of type dictionary. And sometimes you're going to have this strange behavior with type annotations. Type annotations in Python aren't perfect. They help a lot, but sometimes you're going to run into some very strange situations. Once again, the point of type annotations is to help yourself as a developer understand what type you are working with so that you can catch silly mistakes early on in your program. So as a rule of thumb, do your best to annotate the type as specifically as possible. And sometimes it might not always be possible to satisfy the code editor, so you're going to have to be a little bit less specific in certain situations. But in this scenario, we know exactly what it's returning, so it's perfectly fine to do this. And I mean, if we were to print the type of these results, we would obviously get a list back. As you can see, we got class of type list. So annotating it as tuple was a bit misleading. It's something that the documentation recommended us, but it wasn't the reality. And one last thing to mention is that with these tasks or with this future, you can perform a lot of the same operations that we did with tasks, such as canceling them, checking whether they are done, and so on. But this time you can do it in bulk. It's finally time for another Python project. And in this project, we're going to try to fetch the status for several websites as efficiently as possible. And this is a great place to demonstrate the power of asynchronous tasks. So let's get started with our imports. And the first one I'm going to use is from datetime, import datetime. Then I will import async.io. And from async.io, I'm going to import the future type. And to actually make the requests to the websites, we're going to have to import a package called requests. So open up your terminal, which you can find here in the bottom left-hand corner, or you can just use the shortcut as shown. I have Command T for opening the terminal. On Windows, it's probably Control T. But open up the terminal and type in pip install requests and wait for it to install. But once you have that installed, you can import the requests. And here I also want to import the response type. So from requests, import response. Then below these imports, we're going to type in async def check status. And we want to check it for a URL. So here we can pass in any kind of URL we want. It can be google.com, youtube.com, any website we want. And that's going to return to us a dictionary. And if you want to be very specific, of course, you can type these. You can say this is a dictionary that has a string as a key, and then the data type that you want the value to hold. And in our example, it's going to be of type int or string. So you can choose to type it like this. If you have no idea what one type is going to be returned as, you can of course import any, and any just states that this could be literally any type. And this comes from the typing module, so you're going to have to import that. But in this case, we know that it's going to return a dictionary that has the key of type string and a value of type integer or string. Then we're going to provide a start time, which will be of type datetime, and that will equal datetime.now. And in the middle, we will create a response of type response, which will equal await. And here we're going to use a new function called toThread. And this allows us to turn any normal function that is synchronous to an asynchronous function. So here we want to use something from the request module called request.get. And the parameters we want to pass in is the URL. And after that, we're just going to pass in none. And it appears I made a typo in response, so I'll just fix that. Then we're going to copy the start time and paste it right under the response and call this end time. So it's going to look a lot like the function that we've been playing around with throughout the async.io section. Then we will return the status, which will be the response.status code. And that can tell us whether the website's online or whether there's something that went wrong with the request. Then we will have the start time for how long it took to get that request, or when we started making the request, which will be the same thing as from earlier. So start time, %h, %m, and %s. And we have to do the same thing for the end time. So I'm just going to copy that and type in end time here. And of course, this should be changed to end time as well. And that will be the entire function. Next, we need to create our if name is equal to main check. And obviously we need to convert this to an asynchronous script. So async.io.run. And here we need to pass in main as main. And then we need to change this to an async def. But next we can create our tasks, which will be of type future. And that's going to equal async.io.gather. And now we can start checking some statuses. So here we're going to pass in https bing.com. And then we can duplicate this line a couple of times, maybe 4. Add in Google, Apple, BBC. And finally, I'm going to add one that raises an exception as well. So this one will be https lol, something that doesn't exist. But of course, in that case, we want to return the exceptions. So we will set that to true. Then we can print that we are fetching the results, or much better would be to place this above the tasks, like that. And then get the results right below. So results of type list of dictionary is going to equal await the tasks. Then we can print the results to see what that contains. And we can also print them in a much nicer way by saying for result in results, we're going to print that result. And that will be the entire program. Now, the next time we run this, we should see that our program tries to fetch the results, and what we're going to get back is this list of dictionary, and then it's going to give us back the status. And 200 just says that it's a successful request and that the website is online. But of course, if there's an exception, it's going to give us the exception back instead of crashing the program. And it looks like I made a big mistake here with S because I forgot the %sign. So if we want to fix that, we're going to have to add a % in front of S, so that Python understands that this is a date format specifier. And I actually think I would prefer this to be in ellipses. Anyway, we can try doing this with a different website, such as with my own. So I'm going to type in indently.io and get rid of .com. And we can change this to something else, something more interesting, such as youtube.com. And yeah, we'll leave it there. And something else that would be very nice is to actually know the website name for which status we're getting back. So right inside our return block, I'm going to add one more key value pair called website. And here we're just going to pass in the URL, which is of type string. So now let's run this one more time. And the first thing we will get back is a list of all of our results in the form of dictionaries. And then we will get each one of them printed out to the console. So Bing.com had a status of 200, Indently.io had a status of 200, and so on. And we also get the info of when we made the request and when we got the response back. Otherwise, if it raises an exception, as you can see, we still get that error message as a return. And that's why Async.io is so nice. We were able to make all these requests at what appeared to be the same time. If we did not use asynchronous programming for this task, we would have to wait to get the response back from Bing.com before starting with Indently.io, which means that if each request took 2 seconds, all of this would potentially take 10 seconds, instead of just taking 2 seconds in total. In this lecture, I'm going to be introducing you to a static type checker called MyPy, because up until now, I showed you that our code editor in most cases could help us catch silly mistakes when we annotate a certain object as the wrong type. For example, here we have a var of type string, but for some reason, we decided to assign it an integer. Here, our code editor will tell us that we did something silly. And this is an oversimplified example, because of course, with more complex types, this can end up being a lifesaver. But there will be some weird situations where our code editor will not be able to warn us about these silly mistakes. For example, we might have a list of items, and we will say that this is a list of type string. And obviously, we only want this to contain strings because that's what we defined this variable to be. So here we can say cup and apple. I'm not so creative today, but these are the items we want to include in our list. But you'll also notice that if we were to add other data types such as Booleans or other lists that contain integers, our code editor will not care. It will not say we inserted the wrong type. And in general, it's not going to matter which code editor you use. It's just not going to care if you insert a string or not into your list. And that's why sometimes in programming, we need to rely on things such as static type checkers. And static type checkers just check that all the types actually match the values before running the code. So what I recommend you use in all your projects is MyPy. And to use it, you need to first install it by using the pip install MyPy command. And once we have it installed, you're going to notice immediately that I'm going to get some syntax highlighting. And this is going to be a MyPy warning that list item 2 has the incompatible type of Boolean, but it expected a string. And the same thing's going to happen for the list. It is an incompatible type for what we wrote here. Although in your PyCharm, I can guarantee that you're not going to see this warning. And that's because to see this warning, you're going to have to install an additional plugin. So make your way to the settings and then go to plugins. And the plugin we want to search for is called MyPy. So in the marketplace, just type in MyPy. And you'll notice that there are 2 of them. One that claims to be official and one that's made by Roberto. And I just decided to go for the first one because it had more downloads and a better rating. I haven't tried the official one or the one that claims to be official. I don't even know if it is official, to be honest. I haven't seen this being quoted anywhere. It might be the official one or it might not. I have no idea. You'd have to do your own research on that. But in all my projects, I use this one. So once you install it and tap on OK, you should start to see some warnings. But since it is a third-party plugin, I don't recommend you only rely on these warnings. I also recommend that each time you want to actually check that your script has been annotated properly, that you run the mypy command. And to use it, all you need to do is type in mypy and the script you want to check for. So mypy main.py will check that we annotated this script properly. And if we did, it's going to give us no errors. But if we messed up somewhere, it's going to tell us that we have a few errors, such as list item 2 has incompatible type of Boolean, but we expected a string, and so on. So to fix that, all we need to do is convert these to strings or remove them entirely. And like that, we can rerun mypy. And the next time we do it, it's going to say no issues found because we provided the correct types for items. And another place it will probably warn you is when you are creating optionals in functions. For example, you might have a function called function, again, lack of creativity, but it's going to have a default value. And the default value is going to be of type integer. But initially, we're going to set it to none. Then we can do our check and whatever. Now, without mypy, you would get no warning whatsoever here. But mypy is going to tell us that this is an optional and that we should annotate it as such. But before we fix it, I also want to show you in the console that if we run our mypy.main.py command, it's also going to warn us here that on line 1, we have an incompatible default for argument default. The default has the type of none, but the argument has a type of int. And then it also references the PEP version or the PEP standard that prohibits this. And to fix it, all we need to do is either give it a default that is not none, or we need to define this to be an optional, and the error will go away. As you can see, if we were to run our mypy main.py command, we would no longer have any issues. So to summarize this video, make sure to use a static type checker such as mypy to really ensure that your code is following the correct types, because code editors aren't always going to be reliable. In the recent years, Python came up with a new operator which allows us to use an expression and to create a variable from that expression at the exact same time. In Python, this operator is called the Walrus operator because it looks like two eyes and two tusks. What's important to note when you are using this is that it was introduced in Python 3.8. So if you ever decide to use a version prior to this, it's not going to work. Anyway, let's take a look at how we can use this new operator in Python. So what we're going to do here is create a function called description. And this description is going to take a list of integer, and it will return to us a dictionary containing some information. And the first information we want to return is the length of this list. So here we have the number length or the numbers length of type integer, which will equal the length of numbers. Then after that, we're going to try to get the sum of the numbers that we insert. So we're going to type in n sum for numbers sum of type int is going to equal the sum of the numbers. And finally, we're going to try to get the mean of these numbers. So n mean of type float is going to equal the n sum divided by the n length. And then we're going to return all this data as a dictionary. So the details of type dictionary is going to equal first the length, which will equal the n length, then the sum, which will equal the n sum, and the mean, which is going to be the n mean. And at the bottom, we can return these details. But next, let's create our main entry point and try to use this function. So here we're going to create some numbers of type list of integer, and that's going to equal 1, 10, 5, 200, -4, and the lucky number 7. Then we're going to print the description of these numbers. And if we were to run this, we should get something quite simple back, which is the dictionary containing the description of these numbers. So these numbers have a length of 6 because there are 6 numbers in the list. If you were to add them all together, you would get the sum of 219, and the mean is 36.5. So it's a very fine description of these numbers. But now let's go back to our function and see how we can use the Walrus operator to reduce the amount of lines of code we need to actually write this function. So instead of creating 3 new lines of code, we're going to do everything directly inside the dictionary. And to do so, we need to open up some parentheses. And here we're going to type in that the n length Walrus operator, so colon equals, is going to equal the length of numbers. And by doing this, we can also remove this line of code here. And actually, we're just going to remove all of them because we're going to recreate everything inside here. So there's no point of keeping the variables up here. So now, of course, we need to try to figure out how to calculate the sum. And we're going to do the same thing as we did with the length. So nsum, walrus operator, sum of numbers. And again, what the walrus operator does is both create the variable and return the result of this expression on the same line. Which means now for the mean, we can type in nsum divided by n length. And that will work perfectly fine. And if we were to run this once again, we would get the exact same result. But maybe to simplify what I did here, we can go to our main entry point and print x walrus operator with the expression of 1 more than 0. If we were to run this immediately, what you'll notice in the console is that we get true as an output, because it will evaluate this expression and return the result, plus assign that value to x at the exact same time. So now we can use x anywhere in our code afterwards. So now if we were to print x, you would notice that x contains the value of true, and so does this expression. And that's exactly what we did in our description function. We evaluated this expression, and we got the result back, which we could associate immediately with length. And while we did that, we also assigned it to the variable n length. So we did everything in place. And then we did the exact same thing for the sum. So after these 2 lines of code, we could use these variables anywhere in our function. But let's try this with one more example. So down here, I'm just going to remove all of this, and I'm going to create something called items, which is of type dictionary. And this will be a dictionary of int to string. Then we can create some key value pairs, and the ID for the first one is going to be 1, and it's going to contain the value of cup. Then for the second one, it's going to contain the value of chair. And what we're going to do is check if there is an item, and then we will use walrus operator. We will try to get whatever has an ID of 3, which obviously does not exist yet. But as you know from before, if we try to access an element that doesn't exist, this is going to return none. So none will be assigned to item, which means if item is none, this block of code is going to fail. But if it succeeds, we can print that you have the item. Else, we're going to print no item found. So now the next time we run this, what we should get is that there was no item found. But if we were to change this to something such as 1, it would be able to find that item and use it. And this can be considered quite nice because we didn't have to create that variable out of nowhere. We could just use it immediately. Otherwise, we would have to type in item of type string or none, because that's an optional, equals items.get at the index of 1. And then we can do the exact same check. But as you could see, that would take an extra line of code. So by using the walrus operator, we managed to save a whole line of code for something as simple as checking whether an item exists or not. And again, if you want to use the walrus operator, just add an equals and then add your expression. But I do want to mention one last thing, and that is that the walrus operator will be considered controversial by a lot of developers, because some might consider this to be hard to read, and they will also consider this hard to read. But again, what's most important is the readability of your code. So if you consider this hard to read, don't use it. Just create some fresh variables. Otherwise, if you see this as something quite simple and easy to read, go for it. It saves on lines of code and can be used in a lot of places to simplify your code. I know it's been ages since I've mentioned it, but finally in this lesson, we're going to be looking at how we can use lambdas in a bit more detail. And lambdas are just nameless functions that you can create and use on the spot. So to create a lambda, all we need to use is the lambda keyword, followed by the parameters that we want this lambda to use. So here we can use x and y, for example, or you can just use x. Then you can insert a line of code that you would like to execute when you use this lambda. And here we're just going to print x. And in general, if you have a lambda, you would already insert it directly in the function. But there's nothing stopping you from actually creating a variable from it and assigning it that lambda. Now in theory, we can use p as a function. So here we can type in p and insert a value such as 10, and then p and insert a value such as let's say hello. And if we were to run this, we would get the output of 10 and hello. But as I mentioned earlier, you can also use multiple parameters. So here we can type in A and B. And this time we're just going to return A plus B. And one thing to note immediately inside a lambda is that we do not use the return keyword. It automatically inserts that for us. So you just need to insert the expression. And here we're going to change the variable name to add so that we can add these numbers. And here we can add 4 or 5 to 11. And if we were to run this, we would get 16 as an output. But next, we're going to create a function that can actually use this lambda. And for this example, I'm going to import from typing the callable type. Then we can create a very basic function called function. And as the first argument or as the first parameter, we're going to take a function of type callable. And the callable type is just used for anything that can be called. And that's why I'm using it with our function, because we want to make it obvious that what we pass in here should be able to be called. And then we want some values, which will be a list of type integer, and this will return none. And inside this function, we will type in for value in values, and we will call the function with the current value as an argument. So all this function does is use a certain callable with every single value that we provide. And maybe to give it a more descriptive name, I'm going to change this to use all, because we want to use all of these values with this function. Anyway, now that we have this, we can type in use all, and we can pass in either a function or a lambda. And in this example, I'm going to be using a lambda because obviously we're talking about lambdas here. So here we can say lambda that takes a value as a parameter will do the following. It will print the formatted string of the value times the letter X. And then all we need are some values. So here I'll add 2, 4, and 10. And now if we were to run this, you'll see that it's going to give us the output that we expected. For the first loop, it's going to multiply X by 2 because that's the value we inserted. Then for the second loop, it's going to multiply X by 4 and then by 10. And that's why we got this output here. And again, the benefit of doing this was that we didn't have to create a function anywhere in our code to actually use it. We could define the function directly inside the parentheses. And in a way, you should look at this as a one-time use function, because of course we can't refer to this later on in our program because we defined it on the spot without a name. But also to demonstrate what this would look like as a regular function, we can just type in def multiply X, and that's going to take a value of type integer and return none. And all we need to do is copy this statement here, paste it inside, and change this to value. And this contains the exact same functionality as this lambda. But the benefit of this approach is that we can reuse this function later. And to actually call it, we can just go down below here and insert the function. So multiply X without the parentheses. And if we were to run it, we should get 2 identical outputs because they both do the exact same thing. So it's really up to you to decide which one you want to use. As always, I recommend that you follow what's easier to read. And if you're going to reuse that lambda more than once, it might just make more sense to create a function. Otherwise, if it's a simple operation you're only going to use once in a single place, I would opt in for a lambda. And again, the most common place you'll see lambdas being used is with the built-in filtered, sorted, and map functions. But let's create one more example. And for this example, we're going to have some names of list of type string. And the first name is going to be, let's say, Bob, then James, then Samantha. Then we can have Luigi. And one more name can be Joe. And what we want to do here is sort these names by their lengths, because by default, it's going to sort them by ASCII value. So below this, we're going to type in sorted names, type list of string, and that's going to equal sorted. And the first argument will be the names. And then we need to provide a key, because right now, as I mentioned, if we were to just print it as is, it's going to sort these in what appears to be alphabetical order. But keep in mind that this is being sorted in ASCII order, which means if Bob had a lowercase b, Bob would appear at the end of the list. So it's not really alphabetical. But again, let's go back to our sorted function and add a key, which allows us to sort this by length. So here we can type in lambda x, and that should be the length of x. And x is the string. So for each one of these names, it's going to measure the length of the string, and it's going to sort it based on the length. Now, when we run this, we should get a list back sorted by the length. And you can insert whatever logic you want inside here. I mean, you can also make sure that it is case insensitive. So for example, if we have Bob and Luigi, which are not capitalized, we can just go here and say that x should be lowered before compared. And the next time we run this, we should still get the same output with Bob being in the front, because each one of these were lowered before they were compared. And that's why we still get everything in the correct order, regardless of their ASCII value. In this lecture, we're going to be learning about generators. And generators are a concept that are completely worth getting familiar with. They are incredibly memory efficient compared to lists, tuples, and most other iterables. So let's get started by importing from typing the generator type. And then we can create our very first generator. And to do so, you just need to start off by creating a regular function. So here we're going to create a function called 5numbers, and all it's going to do is generate 5 numbers for us. So that's going to return a generator, and then for I in range 1 to 6, we're going to be yielding a value. So now it's time we use a new keyword called yield, and here we will yield I. And that's all the code it takes to create a generator, or to be more specific, any function that yields a value turns into a generator. But now let's take a look at how we can use this generator. So first we're going to create some numbers, which are going to be of type generator, and that's going to equal our 5 numbers. Now with this, we can use next, and we can pass in our numbers. And that's just going to call the next number in our generator, or it's going to retrieve it. And yield is going to give it to us upon request. So right now, if we were to type in next and run our script, we would get 1 back as the first element in the generator. And if we were to print it, let's say 5 times, we would get all of those integers back. One thing to note though is that generators are exhaustive, which means once we retrieve a value, it disappears from that generator. So watch what happens when we actually print the list of numbers after we've retrieved 3 numbers. You'll see that all we have left are 4 and 5 because we already retrieved the first 3. And if we were to duplicate that list of numbers once again, right below the original, the next list will be completely empty because once you take anything out of the generator, it's gone for good. So where can a generator be considered useful? Well, pretend you have a huge amount of data. And to simulate this, I'll just remove all of this and change our function to something called huge data. And instead of for I in range 1 to 6, we're going to say that it should be 100 billion, which is immense. But next, let's try to get some of this data back by creating a variable called data, which will be of type generator, and that's going to equal this huge data. And as always, we can use next with this data, and it's slowly going to retrieve those values one at a time. So if we were to run this, you'd see that we would get those values back. And it's giving us back this data one at a time. It's not materializing this range or doing anything silly with this data. So it's incredibly memory efficient. I mean, if you were to materialize this generator at any point, and by materialize, I mean if you were to convert it to a list or a tuple or a set, you would see that this would take ages to load because it's just such a huge number. I mean, it's not even loading in the console. This could easily take minutes or hours depending on your computer. So I'm just going to stop the program here. But with a generator, we can do something such as for I in range, let's say 200, print next of data. And right now we're doing some name shadowing, so it would be a good idea actually to create our if name is equal to main check to avoid that. And we'll copy that and paste it inside main. But now if we were to run this, we would get those 200 values back upon request. And generators can actually yield anything. So I'm going to remove this example and I'm going to create a new generator, one that's called generate vowels. That will return to us a generator. So here we're going to get some vowels of type string, which will equal A, I, O, and U. Then for vowels or vowel in vowels, we will yield that vowel. And now we can create another generator. So here we can type in vowels of type generator is going to equal generate vowels. And we can do the exact same thing. We can print next and insert our vowels. And if we do that 3 times, we should get 3 vowels back, A, E, and I. And if we want, we can even iterate through all of the vowels. So for vowel in vowels, print vowel. And it will work just fine because a generator can be considered an iterable. So you can easily loop through it. Also, using a for loop simplifies this approach, but maybe a better way to show you what's actually happening is to type it out all manually. So yield A, yield E, and then I'll just duplicate that a couple times and say I, O, and U. And this is what's happening behind the scenes. Each time we try to retrieve a value from the generator, it gives us back one of them. And then once we've used it, this disappears and it goes to the next one until there's no more. And you'll notice that if we go down here to main and we print next vowels and we do this 6 times, we're going to get a stop iteration error. And that will be raised when there's nothing left inside the generator and you can't call next on something that's empty. This exception is the same one that's used to tell a for loop that it has nothing left to iterate over. Although with for loops, we do not get an exception because they handle that error by ending the for loop. If we do this manually outside, we would obviously have to put this in a try and except block to actually handle it. So here we can type in try, except, stop iteration, and we can print that the generator is empty. So that the next time we run this, we won't get that exception, but we will get a friendly message that that generator doesn't contain anything anymore. Congratulations on making it to the end of this course. By this point, you are now more than capable of using Python for building projects in the real world. But don't stop practicing just because you finished this course. The only way to gain real experience is by building real projects. And it's incredibly important that you start simple. You're not going to build a huge social media app in one day. Start with learning how to build some basic apps such as a notepad, a simple chat room, or even a URL shortener. What's important is that you break complex problems into much smaller ones. Now, the most powerful tool you will use for programming is Google. A lot of people think that programming is about memorizing everything, but that's not really the reality. Even the best of professionals have to constantly Google how to create certain parts of their applications and programs. Or even if they run into an error that they have never seen before, the first thing they do by instinct is Google it. But again, congratulations on taking your first step on becoming a professional Python developer. Before you go, I have one more important tip that can really help you master Python. And that is to spend some time every day reading the official Python documentation. And you can do that by going to the official Python website and tapping on documentation and then clicking on Python docs. That's going to take you here where you will be able to find the official documentation for Python. And it doesn't really matter where you start, just try reading about something new every day. You're going to learn things that courses will never teach you, and you will also learn how to read documentation, which is another crucial element in programming. For example, you can go to this tutorial section and you'll see that there are a lot of sections here. And while we covered a lot of these, some of these are going to be new, or they're even going to contain information which I did not cover. And just to show you what this looks like, we're going to tap on something such as break and continue. Once we tap on that section, you'll notice that it's going to give you a quick summary of how this stuff works, and it's going to also give you some examples. But again, just scroll through the Python documentation for 5 minutes a day, because it's going to help you learn how to get comfortable with reading and exploring documentation. Otherwise, I also want to mention that I have a Python channel that aims to teach you a bit more about Python every single week. It's completely free to follow, and I will leave a link to it in the resources section of this lecture. And once again, since it's actually impossible to teach every single detail about Python in a single course, it's good to have as many resources as possible to help you continuously learn Python one day at a time. There are developers who've been programming in Python for 20 years that are still learning something new every single day just by scrolling through the documentation or following a channel such as this one. But yeah, otherwise, thank you for learning Python with me, and I really hope to see you again in the near future.